Hey everyone, this is the complete review of AP Physics C Mechanics based on the new pattern. It covers all the units, Unit 1 to Unit 7. There are chapters in the video so you can jump onto the unit that you feel you're most struggling with. You can download the worksheet of the individual units from the link in the description. And if you need private tutoring, feel free to reach out. Okay. All right. First question, we are given a graph that shows velocity versus time for a puppy moving along a path. Um, According to the graph, when does the puppy change the direction, if ever? So what is the concept, guys? When does a particle changes direction? When velocity changes the sign? Um, Fortunately, this graph is a v versus t. So I can see that this is the point where the velocity is changing from positive. I can see that this area is positive, or this region is positive to negative, and this looks like 7. So among these options, the option C, 7 seconds, makes the most sense. All right. Here we are given that Donald is standing near the 9th hole waiting for his friend Chris to return with the golf cart. Chris is in such a hurry to get to the next hole that he does not slow down as he passes Donald. Okay. The graph shows the velocity versus time for both Donald and Chris as Donald tries to catch up on the cart, to the cart. Chris passes Donald at t equal to 0. How many seconds pass between the time the golf cart initially passes Donald and the time that Donald reaches the cart again? So basically, this is how Donald is going. He's initially, and this is, by the way, velocity versus time. That's already given in the question. This is v versus t. This is velocity, this is time, this is how Donald is traveling, and this is how Chris is going just steadily, on the cart. So don't you think it makes sense that Donald will catch up with the Chris when the distance covered by the cart is same as the distance covered by the Donald? Obviously, velocity, time curve, area under the curve gives us displacement, but fortunately here there's no change in the direction, right? So can we agree that distance and displacement are same? So we can safely assume that the area is indeed giving us the displacement, which is same as distance. Now, one option is to go, one way is to approach by options and see which one is, at which point the area is adding up, or, something like that, or make a calculated guess. So let's say, for example, this is the, let's calculate till this point, what is the area covered by both the parties. And this looks like 1.5 to me. So the area covered by the cart will be base times height, because this is a rectangle. So 2 times 1.5, which is just 3, right? So that's 3, and I think meters, or I don't really know what the unit is. But anyway, it doesn't really matter. For Donald, the area will be half times base, which is 1.5, times height, which is 3. And this is 2.25. So definitely not till this point. Now I need some more time for Donald to catch up with the Chris. So for the cart, let's say it happens at some time t that I do not know, right? Some time t over here. So can we agree that for that much more time, after 1.5, the area of the cart will be height, which is 2, multiplied with whatever length we have over here, which is just t minus 1.5, right? T minus 1.5. And over here for Donald, after 1.5, the approach is pretty straightforward, because this also becomes a rectangle as area under the curve. So let's say for this t, and this is the height 3, so this will be the area for Donald, right? Which will be height as in 3 units multiplied by the time, which is t minus 1.5, right? And I want these two to be equal right now. So all I have to do is just simplify this a little bit. Let's open this up. So this will be 3 plus 2t minus 3. So actually this will just become 2t. And this will become 2.25 plus 3t minus 4.5, I believe. So this will be 3t minus 2.25, And I want these two to be equal, right? So I want 2t to be equal to 3t minus 2.25. Let's subtract 3t both the sides. So minus t is equal to minus 2.25. And clearly the total time is 2.25 over here. So 2.25 seconds is the time when Donald finally catches up with the cart. Right, I hope this makes sense. Cat is running with a constant acceleration initially at rest, has a velocity of 1 meter per second at 2 seconds later. At t equal to 4 seconds, how far away from the starting point will the cat be? Okay, looks pretty straightforward. There is an acceleration over here and initially and has a velocity 2 seconds later. So at this point, it starts from rest, by the way. And at this point, it has a velocity of what, 1 meter per second. And this is 2 seconds. At t equal to 4, how far away from the starting point will the cat be? So they're asking it travels for 2 more seconds. So they need the entire distance traveled. Okay. I don't really know the acceleration, so I can use the first half to find the acceleration. I believe I can use V final is equal to V initial plus AT equation, because V final I know is 1. V initial is 0 because it starts from rest. Acceleration I do not know, and the time is up 2 seconds, that's given. So 1 is equal to 2a. Let's divide both sides by 2. So 1 over 2 is equal to a, or a is 0.5 meter per second square. And now I can just take this entire motion as a, entire segment as a single motion. And I believe I can use the second equation of motion, because that will give me s is equal to v initial times t plus half at square. So s will be equal to v initial, fortunately 0. Acceleration is constant, so if you want I can write 1/2 rather than 0.5. And time, be careful, it's the total time is 4. So it'll be 1 over 4 times 4 square 16. So the answer will be 4 meters over here. So it should be option D. Right, I hope this makes sense. Okay, a rocket is tossed vertically upward from a roof of a building where air resistance is negligible. Which of the following best describes the rock's velocity as a function of time? Velocity, be careful. So we have to take the direction into consideration, right? So they are saying that the top of a building, maybe somewhere over here, it is thrown upward like this. Okay, definitely not A. How can A be the answer? Because how will the scenario, how will the scenario be? I mean, it will go up, it will slow down, eventually it will come at rest, and then it will again come down, and after some time it will have the same magnitude but in the opposite direction, right? And then it will keep on increasing. The velocity will keep increasing as it falls down the building as well. So obviously E is also not possible. Now, the question B is also not possible. Why? Because it is not getting 0 anywhere eventually after some time, right? These two make sense because they are eventually getting 0 somewhere, and eventually they are also getting negative. But remember that this is a free fall, right? This is in the air, and in the air the acceleration is always negative g, or g downwards. And what is the acceleration? Isn't that the slope of the velocity time curve, or dv over dt, right? And if dv over dt is a and a is constant, so obviously I'm looking for a curve where the slope is always constant. Now c doesn't make sense because the slope is changing at every point, which means that the acceleration is changing at any point, which is not correct because the air resistance is negligible. Had there was air resistance, then it's likely that, okay, because of air resistance, the acceleration is changing, but it is negligible. So it should be a constant slope, a negative slope, which happens only in option D. So I will mark D as my correct choice. Okay. A frog that jumps upwards from the ground is under the influence of gravity. If it has an initial upward velocity of 5 meters per second, approximately how far above the ground will it be when it has a velocity of negative 2.5? So
It jumps with 5 meter per second. It goes to some point. Obviously, it will come at rest at the topmost point. And when it comes down, it will have a negative velocity. And somewhere over here, it has 2.5 meter per second in the downward direction. They're asking what is the displacement, because how far above the ground will just be the displacement. I think I can use the third equation of motion, which is V final square equal to V initial square plus 2as, because V final is minus 2.5, V initial is 5, acceleration is acceleration is negative g, because I'm taking downward direction as a negative one. So g is, I don't know, maybe take negative 9.8 or 10. Let's take negative 9.8 and see how the options look like. Let's solve this up. This is 6.25. This is 25. This is 19.6, I believe. As 6.25 minus 25 is negative 18.75. Sorry, 18.75. Negative 18.75 is equal to negative 19.6. S divided by negative 19.6 will give me the answer as 0.96 meters. And yes, fortunately, this is in the option, so I'm going to mark option B, right? Hope this makes sense. Okay. The position of a particle when the time varies is governed by this equation. So what is the acceleration? That's pretty straightforward, right? What is the acceleration when it changes the direction? I'm sorry. So still, first we need to find the expression for the acceleration. For acceleration, first we need the velocity from the position time curve. Velocity is given by dx over dt. Recalling our math skills, guys, power rule. So this will be 3t square minus 12. And acceleration, guys, is dv over dt, right? Take another derivative of this guy. So it will be 6t. But they need the acceleration at the time when it changes the direction. And when does the velocity changes direction? When obviously it changes its sign, right? So this is the velocity. I'm going to factor this vector the 3 out. So it will be t square minus 4. And t square minus 4 can be written as t minus 2 t plus 2. So again, I'm going to make a number line over here. This will be negative 2. This will be 2. This is just calculus, guys. I hope you understand what I'm doing here. I'm just making a number line, plotting the roots. Honestly, negative 2 should be ignored because this is a negative time, but it's okay. Any number greater than 2 that you like, maybe 100. And if I put 100 over here, this will come out to be positive. Likewise, any number between negative 2 and 2, let's say 0, this will come out to be negative, and this will be positive. So the points where the velocity is changing the sign is negative 2 and 2. Obviously, negative 2 should be ignored because that's a negative time. So I'm just going to take positive 2. So the acceleration is 6 times at 2 seconds. It will be 6 times 2, which is 12 meter per second square. So that should be our answer, which is option E. I hope you are finding these solutions helpful so far. If you are, then please, like and subscribe, share this video so that can help other students as well. It will also help my channel, and if you need private tutoring, feel free to reach out. Okay, let's try the next one. Uh, Aaron was biking due east but had to stop for a traffic light. Just as the light turned green and Aaron began to accelerate at a constant rate, his friend Betty sped by on her bike traveling in the same direction with constant velocity v. If it took Aaron time t to accelerate to Betty's speed, how long did it take him to catch up to Betty? Okay. Well, a couple of moving parts over here. So going in the east direction, and the acceleration is constant. So he's right now had to stop. So he starts from rest. I'm talking about Aaron. Acceleration is constant. Okay, just as the light turned green, so right at this point, Betty passed her, right? And she's traveling at a constant velocity, so that's good news. And it took Aaron t time to accelerate to Betty's speed. So let's say after this time, when Betty was still traveling with the speed v, Aaron is also Aaron is able to catch up. Sorry, Aaron's speed is also same as Betty's, so his speed is also v at this point. And we know that it took t time. So I think just from this information, we can have some relationship between the v and the t, because I'm going to say that v final, which is also v in this case, so v final is equal to v initial plus at. V final is v for Aaron. He starts from rest. Acceleration we do not know, and time is definitely capital T. So I have the value of a from here actually, it is v over t. So let's keep it aside. Maybe we'll use it sometime. Now the next scenario is how long did it take him to catch up to Betty? Let's say it took t time, and we know that both should cover the same distance, and distance and displacement are same in this case because they are not changing the direction. So in that t time, can we agree that Betty covered vt distance? And in that t time, we need to find out how much distance Aaron covered. So I think I can use the second equation of motion, which is s is equal to v initial times t plus half a t square. I already I don't know the s, of course. So s will be equal to, he starts from rest, so 0, half, a is v over t from here, blue box, and t square small t, what I need to find. And don't you think this s and this s will be same because they are, he catches up, so they cover the same distance. So vt will be equal to half v over capital T times t square. V and v is gone, and if you realize one of the t is also gone, so 1 will be equal to 1 over 2t times small t, and multiplying both sides by 2t, so 2t will be equal to small t, or small t is 2t. So actually in double that time, Aaron will be able to catch up with Betty. Excuse me. I hope this makes sense. It was a little tricky, but yeah, that's how it works. Okay, Romeo and Juliet drove their car horizontally off a cliff at height h, oh my goodness, at a speed of v. They landed a distance d from the base of the cliff, and this is, we are now entering the projectile world, guys. If the cliff had been 4 times as tall and the car had the same initial velocity, how far from the base would they land? So this is h, right? This is they jump off with v, and they land at a distance of d. And they are saying that if the height is now supposedly 4 times and this v is still the same v, then what will be this distance? See, I can definitely do the math for you, but try to understand this analytically. This distance will depend on speed and the time of flight, right? So right now, I'm going to say that distance is equal to v times t, where I don't really know what t is. And when the height is 4 times, then the distance will be, in that case, the distance d dash will be again v times some new time. And that time depends on the vertical height. How? By using the second equation of motion. So if you realize, if I apply the second equation of motion in the vertical world, I know that displacement is h going downwards. I know we take downward direction as negative, but I mean, okay, just to avoid any confusion, I'll do that. So I'm going to use v is equal to, s is equal to v initial times t plus half at square. S is minus h. Initial vertical velocity is 0 because it is thrown horizontally. Acceleration is, of course, gravity, negative g, and time of flight is t square. So negative and negative is gone. Multiplying 2 both the sides and dividing by g both the sides. So 2h over g is t square. So I have the time of flight as square root of 2h over g. Now think about it like this. If you really quadruple the height, don't you think that the time of flight will double? Because this factor, this h, will now be replaced by a factor of 4h. And what is the square root of 4? Isn't that 2? And the time of, and everything else remains the same. Just don't be confused with this 2 over g. If I were to break down the math, it will look something like this. Some constant k times h. Now t dash will be root of k times 4h. The square root of 4 is 2. So 2 root kh, right? And what is root kh? Isn't that the old time? So t dash will be 2 times t. So since the new time is twice of the old time, the new distance will also be twice of the old distance. So that is not anywhere in the option, so I'm going to mark option E as an answer. If you think otherwise, let me know in the comment section, but I think this is how this should be approached. Okay. A car was driving due east at 8 meter per second while a truck drove due north at 6 meter per second. At what speed and in what direction was the car moving with respect to the truck? We are talking about relative velocities now. East is right over here, that is 8, and north is right over here, that is 6. This is V car, this is V truck. We need to find the direction of the car with respect to truck. So direction of the car with respect to truck is given by velocity of the car minus velocity of the truck. Velocity of the car is definitely on the right side, but remember that whenever we take a negative of a vector, because this can be written as plus of minus velocity of the truck, the velocity of the truck will be exactly in the opposite direction. So now we reverse this. This is 6 and this 8 is already here. So this is 8 over here, and basically we are adding the two vectors now because I already took the negative of this vector already. This is negative of vt, this is vc, and now I'm going to add these vectors. So obviously it will be somewhere over here. Using Pythagoras, 8 square, 8 and 6 is a pretty popular Pythagorean triplet, so that will come out to be 10, and the direction is definitely south east. Southeast is right over here, which should be option C. Okay. Two sailboats, the Breeze Sneeze and the Wind Fair, were racing by tacking back and forth upwind. Oh, they justify what they explain what tacking is. Tacking means changing direction similar to zigzag. Okay, fair enough. The BS sailed D units east, then D units north, and the WF sailed D plus 1 east and D minus 1 north. Both boats began sailing at the same time and sailed for t seconds. Which boat had the greatest displacement during this time? Okay, so BS is going D units east and D units north, and WF is going D plus 1 units east and then D minus 1 units north. Displacement, they're talking about displacement. So I think, isn't that just about finding or using a Pythagoras theorem to figure this out? So for BS, let's call it x. So x will be equal to square root of d square plus d square, which is equal to root of 2d square, which is equal to root 2d. I don't think so this has anything to do with the time, because had they were asking average velocity or something, then time is important. Otherwise, time is not needed. Let's say this is y, so y will be square root of d plus 1 square plus d minus 1 square, which will look like a plus b whole square is a little bit of SAT coming in. A square plus b square plus 2ab, and this will be a square plus b square minus 2ab, guys. I hope you know these formulas. These are really basic, and if you don't, then please revise your algebra. These two are gone. So I'm left with d square plus 1 and d square plus 1, which is honestly 2 times d square plus 1. And what is root of 2? That's just root of 2. And I'm left with root of d square plus 1. And you know what? I'm going to rewrite this one also in a way that will make it easy for us to compare. That can be written as root 2 times root of d square. Now tell me, guys, which one is a bigger number? Obviously the other one, right? Because this is same, this is same, root is same, but this guy has a plus 1 to it. So plus 1 to it means this is a bigger number. This is a bigger number means the square root is also bigger. So WF, I think that is our answer that has the greatest displacement during this time. Hope that's clear. Okay, next one, we have the x and y coordinates of a particle as a function of time are given by x is this and y is this. At t equal to 2, what is the magnitude of the acceleration? It's pretty straightforward, guys. The only difference is now we have acceleration in both the directions. So what is the acceleration in x direction, or let's call it, what is the velocity in the x direction? That will be dx over dt. What is the derivative of this guy? I think that's 5, and this one will be 1.5 times 2t. So that will be 5 plus 3t, right? But I'm interested in acceleration, so acceleration will be dv over dt. The derivative of this is just 3. Okay, meter per second square. What about y direction? So vy will be dy over dt. What is the derivative of negative 60? That's just negative 6. And what is the derivative of negative 6? Isn't that just 0? Because the derivative of a constant is 0. So there is no acceleration in the y direction. The answer is just 3. This time is irrelevant because my acceleration is just coming as a constant. So it doesn't really matter what time you ask. It's just always going to be 3. Okay, more projectile. An arrow is launched 30 degrees above the horizontal with an initial speed of 20 meters per second from the top of a watchtower. Okay, so from here, this guy is launched something like this. This is 30 degrees and this is 20 meters per second. After 3 seconds, what is the arrow speed? So be careful when they are saying arrow speed, you need to find the sum of the horizontal, the sum of the magnitude of the what do you call? First, you have to find the horizontal and vertical components of the velocity, then take both into consideration to find the speed, right? That's what I wanted to say. Let's make the components of the velocity. We know that Vx will always be a constant and the x component of this will be the cosine component. So 20 cosine 30. Cosine 30 is square root 3 over 2. Obviously, you can, just use calculator, honestly. So I'll do that later. Let's first write as 10 root 3. Okay, this will remain constant. We agree on this, right? Because in projectile, if the air resistance is ignored, then the horizontal speed remains constant because there is no acceleration in that direction. For the vertical world, the initial vertical velocity will be v sine theta. So 20 sine 30. If you find 20 sine 30 is 1 over 2, but you can use a calculator as well. So that's 10 meter per second going up. Uh, and in the vertical world, acceleration is obviously negative 9.8 meter per second square. I know that the time is 3, and they are asking what the v final y is because they are asking the velocity after 3 seconds. So I think I can just use the first equation of motion, which is v final is equal to v initial plus at. So this is going to look like v final is equal to v initial 10 plus acceleration minus 9.8 and time is 3. I can grab my calculator. 9.8 times 3 and 10 minus this guy is negative 19.4, guys. Negative 19.4 meter per second. Okay, the options definitely try to trick you because 19.4 is in the options, right? But like I told you that you have to take both the pieces together and do the Pythagoras. 10 root 3 is approximately 17.32 meter per second, and you need to find the total speed. So now I know that one velocity is towards the x direction, which is 17.32, and one velocity is downward. How do I know it's down? Because that's negative, although it doesn't really matter. 19.4, and this is what I need, which is the hypotenuse. So I'm going to use 19.4 square. This answer will be square root of 19.4 square plus 17.32 square. So 19.4 square plus 17.32 square. Square root of this is around 26, somewhere around 26, which is definitely option C. That's the answer. All right. Consider a ball thrown from level ground with its initial velocity making some unknown positive acute angle with the horizontal such that it follows a parabolic projectile trajectory. In the absence of the air resistance, the ball flies up to some maximum height and then vertically returns to its initial position sometime t after being thrown while being horizontally displaced at a constant rate. When the ball reaches its maximum height, which of the following must be true about the ball? Okay, they have given a lot of an entire paragraph, but yeah, it's just that it is thrown like this. It's launched at this point, lands at the same height, and at maximum height, they are asking it had the same horizontal speed it did initially. Don't you think this is the correct answer? Because the horizontal velocity always remains the same, right? They are ignoring air resistance, I'm pretty sure. Have they mentioned? Yeah, in the absence of air resistance, I think this should be correct because this is not really going to change. But let's read the other options. It has same vertical speed it did? No. Vertical speed at this point is 0. It had the net acceleration of 0? No. Acceleration is always g downwards. It is momentarily at rest? No, because it has velocity on the right side. So definitely, this was pretty straightforward, right? The answer is just option A. Okay. At an airport, a student starts to walk backwards on a moving walkway. That's brave. The student accelerates at the rate of negative relative to the platform, and the platform moves with a constant speed of 1 meter per second relative to the floor. In 4 seconds, how much will the student have displaced relative to the floor? I hope you understand the scenario. Uh, this is a platform which has its own velocity. It's moving with 1 meter per second on the airport, and this is floor, which is obviously not moving anywhere. So in usual cases, you just stand on it, it will take you without any effort. But this brave student, what he does is he starts moving backwards with his own acceleration of 0.5 meter per second square. So they are asking with respect to floor, with respect to floor, how much will the student move? So I think I can use the second equation of motion, but keep in mind that the initial velocity, although the student himself just starts, so it looks like he starts from rest, of course, but since he is already on a platform that is moving, the initial velocity of the student will be 1 meter per second to the right. Acceleration is negative 0.5, of course, and the time is already given to us as 4 seconds. So I can use the S equation, the second equation, I mean, that S is equal to V initial times T plus half AT square. V initial is 1, time is 4, acceleration is negative 0.5, and time is again 4. This will be 4 plus 1 over 2 minus 1 over 2 and 16. Uh, 1 over 2 and 1 over 2 will become negative 1 over 4 times 16. 16 over 4 is 4, 4 minus 4 is 0. So it looks like he's not effectively displacing anywhere with respect to the floor. So the answer is option D. Right, over here they are saying that the projectile is launched upward at an angle from a height of 0. Ignoring air resistance, which of the following pair of graphs best represents the Vx and Vy while the projectile is in the air? I'm assuming air resistance, oh yeah, they have clearly mentioned that air resistance is ignored. So the best way to eliminate the options is to see where is Vx constant, because we just learned that in a projectile, the horizontal velocity remains constant if the air resistance is ignored. That happens not in A, not in C. So it has to be either B, D, or E. Now Vy, the way Vy works is initially Vy is maximum positive, then at the topmost point it becomes 0, and then while hitting the ground it becomes maximum negative because it is in the opposite direction. So it definitely changes the direction because we are talking about velocity, not speed. And honestly, there is only option E that indicates that the Vy is actually changing the direction, because these two are saying that the direction doesn't change. How do I know the direction? By the sign of V. So it is going from quadrant 1 to quadrant 4, and that's why I will pick option E as the correct choice. Okay. Right, over here we are given that which of the following types of motion could be represented by these equations. So that's parametric equations. Okay, x is at square and y is bt square. Okay, um, I'm thinking to take the derivative and finding the acceleration, because I'm feeling that if I take the double derivative, then this acceleration will come out to be constant. What do you think? Because I'm saying that Vx will be dx over dt, derivative will be a times 2t, that is Vx, and the acceleration will be dv over dt, and the derivative of velocity will be a times 2 remains as it is, and derivative of t is 1, so that's just 2a, that's ax. And likewise Vy, honestly I don't really need to do that, because the only difference is a is just b, so ay will be 2b. So acceleration in x is same, acceleration is y is same, which means that the total acceleration in x is constant, acceleration in y is constant, so the total acceleration is constant. So I will say it is a uniformly accelerated motion. So option E makes the best sense to me. What do you think? Okay, over here, there are three balls that are tossed from the top of a building. Ball A is released from rest, B is thrown horizontally with V naught, and C is with 2V naught. So which of the following correctly lists the ball in order from the time of fall? Don't you think it is same, honestly? Because we just discussed this thing a couple of pages before, that the time of flight only depends on the vertical height, not on the thrown velocity, horizontal thrown velocity, because that will change the distance from the base of the cliff, but not the time of flight, because that just depends on the vertical height and gravity and those stuff, which is same in all the cases. So I'm going to mark option what, D, because it is same for everything. Okay, a hobby rocket reaches height of this and lands this meter from the launch point with no air resistance. What was the angle of the launch? So that's pretty straightforward, I think, because they are saying that it goes like this, a regular projectile, and this is 111 meters, and this is 72.3 meters over here. And they're asking what was the angle of launch. Alright guys, here I'm going to use some direct formulas that I would recommend you to memorize as well, because these formulas are not given in the formula sheet, but these are super helpful in MCQs. These formulas, the formula that I'm talking about is the range of a projectile, provided the projectile starts from a point and lands at the same, a height, the same height. The range is range as in this horizontal displacement, has a formula V naught square sine 2 theta over g, and the height, the maximum height, which is given to us as 72.3, is V naught square sine square theta over 2g. Okay, they are asking angle of launch. So what I'm going to do is, from these two equations, I'm going to divide them, because V naught doesn't really have any job here and I want to get rid of that. So R over H will be equal to V naught square sine 2 theta over G over V naught square sine square theta over 2G. Be careful, we need to use keep change flip. So R over H will be equal to V naught square sine 2 theta over G multiplied by 2g over v naught square sine square theta. G and g is gone, v naught square is gone. Let's sub in the numbers here. So 72.3, sorry, 111 is the range and 72.3 is the height, and this is 2, because this 2 is left here, 2 sine 2 theta over sine square theta. You can use the graphing calculator now, or Desmos, of course. How I will do using Desmos is, I will type in 111 over 72.3 minus 2 sine 2 theta over sine square theta expression in Desmos, and set it to the degree mode and find its x-intercept. Let me show it to you. So this is how it looks like. I just typed in the entire expression. Obviously, I replaced theta with x, because that's the variable that Desmos understands. And I already changed it to the degree mode. So the point of intersection that I'm getting, the x-intercept is 69 around. Fortunately, that is in the option. So it was a pretty good question. So the answer is option A. That's what we have. Okay. Uh, Next question. The spring-loaded gun can fire a projectile to a height of h if it is fired straight up. If the same gun is pointed at 45 degree from the vertical, in terms of h, what is the maximum height uh, that can be reached by the projectile? Okay. So I'm assuming that the velocity remains same, right? So in this case, it is just going up with v, and it reaches a height of h. Let's find the height of h. I think we can find it because v final is 0. So I can use the third equation of motion, which is v final square is equal to v initial square plus 2as. This is 0. V initial is v. Acceleration is minus g, and s is h. So this will become 0 is equal to v square minus 2gh. So the adding 2gh both the sides and then dividing by v square. So sorry, divided by 2g. So v square over 2g, that's the height that we are getting initially. Now, if it is fired from a projectile, again, I'm going to use the direct formula that I just used in the previous question. It is at 45 degree. So height will be v square sine square theta over 2g. So v square over 2g remains as it is, and theta you are saying is 45, so sine 45 square. And what is sine 45? 1 over root 2. And what is the square of 1 over root 2? That's 1 over 2. And isn't v square over, let's call it h dash, and isn't v square over 2g something that I can just see over here, which is just h? So this will be h times 1 over 2 or h over 2. So half of the height is our answer, which is option C. All right. Two trains depart from one station, one going north at 30 miles per hour and another going northeast. Okay, fair enough. At what rate does the distance between the two trains increase? This is a fancy way of asking what is their relative velocity. One is going north, there you go, 30, and one is going northeast. So northeast is like this, 45 degree and 60. They are asking what is the relative velocity. Relative velocity means what is the velocity of 1 minus velocity of 2. First, I would like to make the components of this velocity because this is at an angle. So the horizontal component will be 60 cosine of 45 degree and 60 sine of 45 degree, right? So these numbers are around 42.43. So 42.43 upward and 42.43 to the right. Now, whenever we subtract velocity, we take the we change the direction, right, of whichever vector we are subtracting with, and then we are supposed to take the absolute value. So if we change the direction, this will become left 42.43 and down 42.43. So another way to if you do not really like this method of changing the arrows and all, I can tell you another way in which you write this guy as 30 j cap. I hope you understand what is I cap, j cap. J cap is just towards the y-axis. And then you subtract this with the vector, this vector, which is 42.43 I cap and 42.43 j cap. Right, and then you take the absolute value. So this will be minus 42.43 I cap, then 30 j cap minus 42.43 j cap. So what is 30 minus 42.43? That's negative 12 point. So this will be negative over here. 12.43 j cap. Sorry, yeah, j cap. And the absolute value of this will be square root of Pythagoras, right? 42.43 square and then 12.43 square. I'm not writing negative because even if you write the negative, you have to square the negative, which will become positive. So there's no point of writing that. And if I do all this, I'm going to get 44.2 miles per hour. So that should be our final answer. Question, there's a block of mass m that is held in equilibrium by two strings. What is the tension T2 in the diagonal string? So we are supposed to find what is the tension over here.
So this is based on equilibrium. So the net forces should be equal, or the net force should be zero, or I can say the left force should be equal to the right force, or then the upward force should be equal to the downward force. So at this point, I can say that there is T2 going to the diagonally, T1 over here, and there is an mg going downwards because of this mg, right? I hope you understand. Although, see, this is actually, to be very specific, this is some tension T3. But this tension T3, the same T3 is over here as well. And that is balancing mg, right? So this T3 is actually mg. So I'm going to make components of this T2 now. If we notice carefully, this angle will also be theta because these are alternate angles. So this will be T2 cosine of theta. This will be T2 sine of theta. And this is just mg going down. So I'm going to say that T1 is equal to T2 cosine theta. That's the first equation because the left force is equal to the right force. And likewise, I have mg, downward force, should be equal to the upward force, which is T2 sine of theta. I think I'm going to divide both the equations because if I do, then I can get rid of T2 and I can get the value of T1. Although they need T2, but if I have T1, I can get T2 as well, right? Or you know what? It's not actually required. I just noticed that I can just use this equation, right? I can just divide both sides by sine theta. So I'll have mg over sine theta is equal to T2. And isn't that what I want? I want the value of T2, which is mg over sine theta. And yes, that is in option D. So that should be our final answer. Okay. A block of mass m is placed on a rough surface. The coefficient of static friction between the block and the surface is mu. The angle of inclination is slowly increased. So what is the maximum angle at which the block remains at rest? This is actually a direct formula, guys. I don't know if you guys know this. I'm going to tell you both ways that if there is a mass m and this is the angle theta, so the maximum angle till which this can be inclined so that this box will not slip is dependent on the coefficient of static friction, and the relationship is given by mu is equal to tan theta, right? So if I rewrite this, flip the omelette, tan theta is equal to mu, so the value of theta is going to be tan inverse mu. That's one way to deal this question, which is formula based. The other way is you can just, and you can just make the components and do that thing. For example, if I incline and let's say this is the tipping point or the verge of motion where it is about to slip, I'll say that as FBD will look like there's a normal reaction. There are two components of gravity. I hope you understand. The along the incline is always the sine component, right? So this is going to be mg sine theta. This is going to be mg cosine theta, and this is going to be the friction force. I know that mg sine theta must be equal to the friction force. Friction force is given by mu times normal reaction, so mu Fn. So mg sine theta will be equal to mu times normal is mg cosine theta. mg is gone. I hope you understand Fn is mg cosine theta, right? So I'm left with sine theta is equal to mu times cosine theta. I'm going to divide both sides with cosine theta. So sine over cosine is tan. Tan theta is equal to mu. So theta will be equal to tan inverse mu. So the answer should be option C. That is the value of maximum angle. Okay. A mass m is suspended by two strings that go over two pulleys and are attached to different masses. This is a scenario over here. So what must be the mass m in order for the system to be in translational equilibrium? Okay, the m that we are looking for is this. This is the capital M that we are looking for. They should have mentioned that which one is which mass, but I'm going to assume that, let's say, the left one is 1.1 kilogram and the right one is 1 kilogram. Okay, FBD is going to look like there will be a tension over here. Let's call it T1. There will be a gravity force, which is mg. So m is 1.1 times g. This T1 will also come here. Here I have T2. This will be m times g. So 1 times g, which is g. So this is T2. and this is mg over here. Okay, so this one T2 over on the right side will become T2 cosine of 15 degree, and this will be T2 sine of 15 degrees because I'm just making components. Likewise, this T1 will be T1 cosine of 30 degrees, and the upward force will be T1 sine of 30 degrees. And over here, T1 is equal to 1.1 g and T2 is equal to g because, they are in equilibrium. So the equations are T1 is equal to 1.1 g, T2 is equal to g, and then over here, the left should be equal to the right. So I'm going to say that, in fact, I don't think so I need that because, they just want the value of capital M. So I'm just going to say that the upward forces should be equal to the downward forces. So T1 sine 30 plus T2 sine 15 should be equal to M times G. T1 is 1.1 G, so 1.1 G sine 30, and T2 is G from here. G sine 15 is equal to capital MG. G is gone, and I'm just going to pull up my calculator now. So I'm getting the left side when I calculated 0.8088 is equal to capital M. So capital M is going to be 0.81 kilogram, and yes, this is in option B. So that should be our final answer. Right. A block of mass m is released from rest on a steep inclined plane at an angle of 65 degrees. The coefficient of kinetic friction is given. So how long will it take for the box to reach the bottom? I need acceleration for sure because if I have the acceleration, I can use the equations of motion and find the time, right? Because I have the displacement. For acceleration, I need the net force. So let's make FBD. This is normal reaction. This will be mg sine of 65 degree. This will be mg cosine of 65 degree. And here I have a friction force. So I know that normal reaction should balance mg cosine 65. So I'm going to write that. And over here it has an acceleration. So I'm going to say that the net force is equal to ma, and the net force down the incline is going to be mg sine 65 minus friction, and that should be equal to ma. I know that the formula for friction is given by mu times normal reaction, so that should be equal to ma. So mg sine 65 minus mu times normal reaction is this, which is mg cosine 65, and that is equal to ma. We can see that m is gone from all the sides, and I think I have the acceleration, which is g sine 65 minus mu. Do I know mu? Yeah, 0.15. So 0.15 g cosine 65, that's going to be my A. So let me pull up my calculator. So the acceleration is coming as 8.26 meter per second square. I need the time, so I'm going to use the second equation of motion, which is s is equal to v initial times t plus half at square. S is given as 2, v initial is 0 because it is released from rest. Acceleration is 8.26, and I need to find the time. So 2 will be equal to 8.26 divided by 2 is 4.13. So 4.13 t square. I'm going to divide both sides by 4.13. So 2 over 4.13 is t square. And if I take the square root on both the sides, this is, by the way, a 0.4842. And if I take the square root on both the sides, then the value of time will come out as 0.6959 seconds. Let's see if 0.6959, something like that. Yeah, we have 0.7, 0.69, of course, is very close to 0.7, so that should be our final answer. Okay. A hockey puck sliding on ice at 10 meters per second stops after traveling 50 meters. So what is the coefficient? Okay, that's a pretty straightforward question. They need the coefficient of kinetic friction. I know that the only force that is stopping this hockey puck is friction. The other forces are normal and gravity over here.
So friction will be equal to minus ma. I'm putting minus because, that's a deceleration. And ma because obviously, F net is equal to ma. Friction formula is mu times normal reaction. That's equal to minus ma. Mu, I do not know. I know that the normal reaction is just mg, so that's equal to minus ma. So I found that mu times g is equal to minus a, or a will be equal to minus a over g. But I need to find the value of a now. I can do that using the equations of motion because I know that the initial speed is 10, final speed is 0, s is 50, a I do not know. So I'm going to use the third equation of motion, which is v final square is equal to v initial square plus 2as. So that will be 0 square will be equal to 10 square plus 2. A I do not know. S is 50. So 0 is equal to 100 plus 100A, right? Subtract 100A both the sides. So negative 100A is equal to 100. Dividing both sides by negative 100. So I have A as negative 1 meter per second square. And that I'm gonna plug in over here. So the value of mu will be negative of negative 1 over 9.8. So 1 over 9.8 is 0.10 around. So that will be 0.1020 to be precise, up to 4 decimal places. And let's see, 0.10. Yeah, we do have that in the option, 0.1020. So option B. Okay. Box slides down frictionless, okay, that's important, frictionless incline, and then on the surface of the horizontal, again frictionless surface. The VT graph is best represented by which of the following? Okay, I know that for this portion, the velocity must increase because there is a gravity or a component of gravity at least that is pulling it down, right? Obviously, whatever component it is, actually we can be very precise about what that component is. That is g sine theta. We know that very well because if this is g, then this component is g sine theta. So it is a constant acceleration. So I know that velocity has to increase linearly because I will say v final is equal to v initial plus at. So v final will be equal to 0 plus g sine theta times time. G sine theta is a constant. So it's more like y equal to mx. So it's a straight line increase. But when it comes here, there is no friction, no air resistance, so its velocity, whatever it gained, it's not going to change because there is no one to change that velocity because there is no force and hence there is no acceleration. So it will stay constant, whatever it gained at that time. So obviously the best choice is option E because it has to increase linearly, that we know for sure. So it cannot be B or D or E. And after reaching that point, it has to stay constant. It cannot decrease because there is no friction, right? They say frictionless. Yeah, frictionless surface. So it has to be option E. That's the best choice. Okay. A box slides with a constant velocity down an inclined plane that makes an angle of theta with the horizontal. What is the coefficient of friction between the block and the surface? So they are saying it is going down with a constant velocity, which is interesting because constant velocity means acceleration is 0. Okay, let's say this is a mass, this is of mass m and this is of theta. So this would mean that this is mg sine theta, this is mg cosine theta, this is a normal reaction, and here I have a friction force. If the acceleration is 0, then the net force must also be 0, which means that this and this should be equal. They should balance out. So can I say mg sine theta is equal to the friction force, which means that mg sine theta is equal to mu times normal reaction, which means mg sine theta is equal to mu, which I need to find. And normal reaction is of course equal to mg cos theta. mg is gone. Divide both sides by cos theta. So sine over cos is obviously tan. So tan theta is mu, and that's what they're asking. That what is the value of mu? So that's going to be tan theta, which is option C.
Okay, a crate of total mass m sits on a slab of mass m, both on an incline. All contact surfaces have mu s as 0.4, where theta makes the angle as 15 degree. As the mass of the crate m is steadily increased, at which point will the two masses start to slide? Okay, fellas, this is a tricky question. The concept lies in how is, I think I talked about this in the previous question only, that what condition of mu is required for the inclined plane to be in equilibrium. And that condition is that the mu s should be greater than equal to tan theta. That should be the condition. Now, in this case, theta is 15. So if you find tan 15, it's going to be 0.27 around. And is the mu greater than equal to 0.27? Yes, reasonably, it is 0.4. So this means that this is going to be in static equilibrium. Increasing the value of mass is not really going to change anything because it depends on mu and tan. And since the condition for equilibrium is already met, so it is not going to slide. So the answer is option E. Okay, a passenger rides in an elevator, and the elevator and its passenger have a combined mass of 1600. If the elevator, originally moving downwards at 12 meters per second, is brought to rest with a constant acceleration over a distance of 29 meters, what is the tension? Okay, if it is brought to rest while it was moving down, it makes sense that the acceleration must have been upward, because then only it can come to rest. So I know that its initial velocity is 12 going downward. So let's take it as minus 12. Its final velocity is 0 because it comes to rest. Displacement is 29 and acceleration I do not know. So I'm going to use v final square is equal to v initial square plus 2as. So 0 is equal to minus 12 plus 2a 29. So 0 is equal to minus 2 times, minus 12 plus, I think that's 58, 58a. I'm going to rearrange this. So this is going to look like 12 is equal to 58a. So dividing both sides by 58, 12 over 58 is a. Okay, now this is helpful for us to find the tension, because the FBD is going to look like there is a tension over here, and there is an mg over here, and there is an acceleration over here. So I'll say tension, which I do not know, minus mg. M is already given to us as 1600, that's the combined mass. So 1600 G is equal to MA, where M is 1600 and A is, I just found that, that's 12 over 58, right? That's what I have plugged in over here. Well, at this point, it is just rearrangement. So T will be equal to 1600 G plus 1600 times 12 over 58. So this is going to be 1600 times 9.8 plus 1600 times 15, times 12 divided by 58. So this is going to be 16011 Newton, around that value, 16011, which is, I think, option B is the closest value, right? So that should be our final answer. Right, over here, a block of mass m is on a frictionless incline and is pulled with a force F. What is the acceleration of the block? Isn't that pretty straightforward, actually? I'm just going to make an FBD, which is going to look like normal reaction is over here. This will be a sine component. I think by this time we know that along the incline is, the sine component. This one is going to be the cosine component. Although I don't need normal and mg cos theta, so I'm just interested in the acceleration. So I'm gonna say F net is equal to ma. F net is F minus mg sine theta is equal to ma. Dividing both sides by m. So that will be F minus mg sine theta divided by m, that is equal to a, and that's what they were interested in, right? So F minus mg sine theta over m, that's going to be option E. That's the final answer. Okay, a block of mass m is pushed with a force of F at an angle of theta. They're not really talking about any friction anywhere. I'm assuming there is none. They're asking what is the normal force. So once again, make sure you make the components of it. So since this angle will also be theta because these are alternate angles. So the right component will be f cos theta and the downward will be f sine theta. This will be the normal reaction and this will be mg. Okay, so upward forces should be equal to the downward forces, right? So the upward forces, there is only one force, Fn, and the downward force should be equal to F sine theta and mg both, plus mg. I think that's my answer. That's what they were looking for, right? Fn is F sine theta plus F plus mg, which is option E. So that should be my final answer. All right, here the graph shows the velocity of a car moving under a varying force in a straight line as a function of time. At what time is the magnitude of the net force on the car the greatest? Okay, so F is greatest. I know that F net is ma. So F is greatest whenever A is greatest, right? And A is nothing but the dv over dt. So I'm looking for a point where the derivative is maximum, right? The derivative is maximum. Definitely not 1 seconds because at one, sorry, definitely not 0 seconds because the derivative is just 0 because derivative is just, really the slope. So that's what I'm looking for. Don't you think that this dv over dt, I'm using a little bit of calculus skills here, will be maximum when the function changes from concave, changes the concavity, right? And I think that happens somewhere around 2 seconds, because if we notice, actually it's somewhere around this point. This should have been a precise point where the concavity changes the sign, it's concave down to concave up. But given the options, I think I'm gonna take, because option, it is 1 second either, which is somewhere over here, so its slope is something like this, and then it is 2 seconds over here, which is also something like this. It's very difficult to eyeball these things, eyeballing and finding out that which one is a bigger slope or more steep is a little difficult. So I think the best option should have been around 1.5, but I think I'm going to go then with option C, that is 2 seconds. All right. The next one is a tiny mosquito moves forward in a straight line with a speed that obeys this equation. Which of the following could best represent the acceleration? So I think I know that the acceleration is just what dv over dt, right? That's what we know. All we have to do is use our derivative skills now. So it will be d over dt of v naught e raised to minus bt. V naught as a constant is going to be thrown outside, so V naught is thrown outside and I have d over dt of e raised to minus bt. Derivative of e to the something is just e to the something times the derivative of the power, right? Because we are using a chain rule over here. Derivative of minus bt is just minus b. So this answer will be negative v naught b e to the minus bt. That's going to be the acceleration. Negative v naught b e to the minus bt. Interesting. That is not in the options. That's because we have to, use the question again to eliminate the e to the bt. Let's do that. So acceleration is negative b. I'm writing negative b first, and then v naught e to the minus bt. And don't you think v naught e to the minus bt is something that I'm seeing in the question that can just be replaced by v? So acceleration is actually minus b times v. That's the answer, which is option. Fortunately, it is in the option. That is option A. All right. Right. A sphere of mass m is dropped from the top of a building and reaches the ground, reaches the ground before achieving terminal velocity. The force of the air resistance is minus kV, where k is a constant. Positive constant v is the velocity. What happens to the magnitude of the sphere's velocity, acceleration, and the distance falls each second as the sphere approaches the ground? Okay. See, it reaches the ground before achieving the terminal speed. So
I know that the FBD is going to look like this, that mg, and this is kv. And I know that kv is always less than mg, because if it is equal, it will reach the terminal speed, and they are saying it doesn't reach the terminal. It actually reaches the ground before reaching the terminal. So I know that mg is going to be always greater than kv, which means that acceleration is downwards. Now, whether the acceleration increase or not, that depends on not mg, because that's constant. That depends on velocity over here. Obviously, when it is thrown down, when it is going down, not thrown down, but it is released, and when it is going down, v is going to increase with time. And if v is going to increase, first thing is definitely the magnitude of the velocity is going to increase. So it has to be either a, b, or c. And don't you think that if v increases, this component increases, which is basically, opposing mg. So overall acceleration is going to decrease, because v is increasing, so opposing force is increasing, so net force is decreasing, so the acceleration is decreasing. So it cannot be increasing, it has to decrease. So it has to be either option B or option C. Right, guys, for the distance over, this is a little tricky, and the distance has to increase. You don't really want to go into too much math over here and making the differential equations and all. A very simple way to understand this will be when the distance, literally the distance that has fallen, is just the speed for a very small time, that is 1 second, speed times time. And this change of speed is always going to increase. Why? Because the speed is increasing, and the time is anyway for every 1 second. So this is probably an easy way to understand why the distance will keep increasing. Also remember, acceleration, although the magnitude is decreasing, it is always supporting the speed. So that's the reason why the change of speed will always be more, and that's why the change of distance for every second will also be more. So the correct option is option B. It was a tricky one, but yeah, that's how we do it. Okay, Atwood-machine. So two blocks, 2m and m, are connected by a light string that passes over a massless and frictionless pulley. What is the acceleration of the system? Pretty straightforward. I'm going to say that FBD will be 2mg here. Let's say the tension is T. Guys, the tension will be same because this is the same rope. This is T, this is mg. It makes sense that the heavier one will go down and the lighter one will be up. So the situation will look like 2mg minus T is equal to 2ma. That's the Newton's law for the right side. And for the left side, it will be T minus mg is equal to ma. The best way to solve Newton's, the Atwood machines related questions or a system of equations in physics and in Newtonian mechanics is just to blindly add the equations. Because if you do, this minus t and t will be gone, and you will just have the acceleration right away. So 2mg minus mg is just mg. 2ma plus ma is 3ma. mm is gone. So g is equal to 3a. And dividing both sides by 3, I have the acceleration as g over 3. So correct answer should be option B. Okay, masses m1 and m2 are connected by a light cord, m2 is greater than m1, and m2 remains on the floor while m1 remains suspended. What is the normal reaction on m2? So again, FBD. So here I have m1g, here I have a tension. This tension will come down over here like this. There's a normal reaction on m2, and there will be an m2g as well. Remember, the entire system is at rest, so I'm going to say for m1 that T should balance m1g, and for m2 I'm going to say that T plus normal should balance m2g. I already have T, so I'm going to replace T with m1g. So m1g plus Fn will be equal to m2g. I'm going to subtract m1g both the sides, so m2g minus m1g. So normal reaction will be m2 minus m1. Why? Because g is taken as a factor. So m2 minus m1 times g, that should be the final answer. Okay, another Atwood machine. Block 1 is pulled by a force of magnitude mg, and block 2 is attached to another block of mass m connected by a perfect pulley. over a perfect pulley. Let A1 and T1 be acceleration and tension of the block 1 situation and A2, T2 of block 2. So what is the relationship between them? Okay, so this is T1 and this they are saying is, going over here by A1. So I think the situation, don't you think this T1 is basically nothing but the force of mg, because this force of mg which is being pulled, the thread is pulled with this force that is going to transfer over here and become T1. So although I'm saying that T1 is equal to, the first thing I'm saying is T1 is mg, and then I'm going to use Newton's second law and say that T1 is also equal to ma1, and T1 is just mg, so mg is ma1, so g is equal to a1 or a1 is equal to g. Okay, in scenario 2 I'm going to say that this is mg, this is T2, and likewise this T2 will come over here, this is A2 and this is obviously A2. Everything is going down, so the Newton's law for this object is going to look like mg minus T2 is equal to ma2, and for this block is going to look like T2 is equal to ma2. Like I said, just add, it will be very easy for you. So I'm going to add both, so T minus T2 and T2 are gone. So mg is equal to 2ma2. So m and m is gone, and g over 2, if I divide both sides by 2, is the acceleration. And if I need the tension, let's put the acceleration over here. So T2 is already ma2, and a2 is replaced by g over 2. So T2 will be mg over 2. So obviously both T2 and A2 are half of T1 and A1. So I'm going to say that A1 is greater than A2, which is over here, and T1 is also greater than T2, which is over here. So it should be option E. That should be the best choice. Hey guys, I hope you are enjoying these solutions so far. If you are, please share this video with your friends so that it will help my channel, it will help your friends as well. And if you need private tutoring, feel free to reach out. All right, over here, we are given 3 blocks of mass 10, 20, and 30 kilograms, and they are pushed by 60 Newton force. Okay, good news is it is frictionless. So what is the force exerted on the 30 by the 20? Okay, a very good and easy way to solve this question is first to treat this entire thing as a single system. I can do that because there is no friction. So I'm going to think of this like a big 60 kilogram box, and I'm going to say that F net should be equal to ma. F net will be 60, total mass is 60, and A is I do not know. So from here 1 is equal to A, or A is equal to 1 meter per second square. Okay. The 30 kilogram by the 20, we have to find the force that is exerted on the 30 by the 20. So obviously because of this surface, they are exerting or exchanging a normal force. This 20 kilogram is going to exert a left normal force on 30 kilogram, which I'm interested to find. And now it's pretty straightforward because I know the acceleration. So just consider this block of 30 kilogram, and I'm going to say that F net on this 30 kilogram should be equal to ma. F net will be 60 minus Fn will be equal to 30 times A. So 60 minus Fn will be equal to 30 times 1, which is just 30 because A is 1 over here. So obviously minus Fn is equal to, subtracting 60 both the sides, I have minus 30. So the normal reaction, or the force that 20 kilogram is exerting on 30 kilogram is 30 Newton, which has to be option C. Right. 50 kilogram acrobat is swinging on a rope with a length of 15 meters from a horizontal platform to another. Both platforms are equal height. If the maximum tension of the rope can support, the maximum tension that the rope can support is 1200, then what is the maximum velocity he can reach without breaking the rope? Okay, all right. So the scenario is something like this. Let's say this is platform 1,
and this is platform 2. Let's say this is somewhere the pivot where the rope is connected, and he is trying to swing something like this. So it makes sense that the maximum velocity will obviously be at the bottommost point, and the rope should be able to support at this point, because if it can support here, then it can automatically support anywhere else. The maximum tension is 1200. Remember, there will be an mg as well, so 50g over here because the mass is 50. And this is circular motion, of course. So I know that F centripetal will be equal to mv square over r. F centripetal will be 1200 minus 50g because that is the net force towards the center. Mass of the acrobat is 50. V I need to find, and the radius is nothing but the length of the rope, that is 15 meters over here. So over 15. So if we pull my calculator, so this is going to be, if I take GS10, this is going to be 700, and this is 50 over 15 times V square. So V from, I'm going to cross multiply, so multiply both sides by 15 and divide by 50 both the sides, and then take the square root of this guy. So V is a square root of 700 times 15 over 50, which is 14.49 meter per second. So it looks like option D should be the final answer. Okay. Car traveling at 20 meter per second enters into an unbanked curve with a radius of 25 meters. If the coefficient of friction between the tires and the road is this, then what is the magnitude of the change in velocity of the car if the car is going to stay in the lane? So there is no slipping because it stays in the lane. And this is a fancy way of asking that what is the magnitude of the car's change in velocity, because okay, let's talk about that in a minute. So this is the car over here, and I know that its friction force is the one keeping it in the circle. So friction is over here. Obviously, the normal and gravity will be equal and opposite. So I'm going to say that the centripetal force is equal to mv square over r, and the centripetal force is nothing but the friction force. So friction is equal to mv square over r. Friction is mu times the normal reaction, and normal is obviously mg. So this is equal to mv square over r. M is gone, so I'm going to multiply both sides with r. So mu gr is equal to v square. So v square is mu gr. Let's sub in the value of mu, which is 0.75. V, which is, sorry, g, which is, let's call it 10, and r, which is 25. So this comes out as 13.69 meter per second. So if it wants to stay in the lane, it has to slow down from 20 meter per second to 13.69 meter per second. So what will be the change of velocity? Obviously, the change is going to be 20 minus 13.69, which is somewhere around 6 or 6.3 meter per second. So I think the best option for the change in velocity of the car, I'm going to mark as 6 meter per second. All right, this was I mean, it was easy question, but the change of velocity thing might have tripped some of you guys. So yeah, that's how we do this question. Okay, a force of F is exerted on M1 and the system accelerates without M2 and M3 slipping. There is a friction between M1 and ground, so which of the following free body diagram is correct for M1? Obviously, there will be a normal reaction from the ground on M1, right? So, and there will be an F of applied. There will be a friction from the ground on M1. So I'm gonna mark the numbers over here. One is the normal reaction because of the ground. One will be the normal reaction due to the surface between M2 and M1. So M2 will be pushing M1 downwards, obviously. So that normal reaction will also be here. Let's call it due to Fn2. There will be an M1G over here, and there will be a friction due to the kinetic friction due to the ground as well. That's it, because the friction is only between M1 and ground. So I think 1, 2, 3, 4, 4 forces on M1. Let's see which option is giving me that. Isn't that option B?
because there is an Fn ground. No, it's not option B because it's missing one force. I think then it's not option A, it's not option B, it's not option D. I think it's option C. There you go. Friction due to ground, M1G, normal reaction due to 2, normal reaction due to ground, and F applied. Exactly. So we are looking for option C. That's the best choice, right? An object weighing 4 Newton falls from rest subject to a frictional drag force given by this. What is the terminal speed? So I know that the terminal speed happens when the downwards force, which is mg, is equal to the upward force, which is drag, in this case bv square. So I want bv square to be equal to mg. So v square should be equal to mg over b. So v will be equal to square root of mg over b. M is, I don't know. They have given weight, not mass, so that's fine. Actually, that's even better, right? Don't you think the weight is nothing but mg? So I can just replace mg by mg with 4 because that's the weight, and b is already given as 3. So the square root of 4 over 3, that should be the answer, which I'm getting as 1.15 meter per second. So that should be the terminal velocity. Should be option C. All right. A block begins to slide with a speed of v on a rough surface. The coefficients of static and kinetic frictions are this. What is the acceleration of the block? Okay. I know that the block is sliding, so the coefficient will be kinetic, not static. It is sliding with a speed of v, and I know that the only force that is acting on it is the kinetic friction. This is the normal reaction, of course, and this is mg over here. So I know that F net is equal to ma. F net is Fk is equal to ma because normal and mg are equal to each other. Fk is mu k times normal reaction, that should be equal to ma. Normal reaction is mg, so mu k mg is equal to ma, gone. So mu kg is our acceleration, which is, well, there you go, option C. That is the required acceleration. Actually, that's deceleration, so I would have put negative, but I think they are just interested in the magnitude, right? So yeah, mu kg, that's the magnitude. A box slides down a 45-degree ramp where the coefficient of friction between the box and the incline is 0.8. The mass is given. How much total force does the box exert on the incline? That's a fancy way of asking what is the normal force, because the box exerts on incline the same force as the incline exerts on the box, and incline exerts normal on the box. This component, by this time we know that this is the sine component, so mg, this is 45 degrees, so sine 45 degrees. This is just mg cos 45 degrees, and then there is some friction about which I do not understand. Actually, you know what, don't you think the friction is also a part of the force that the box exerts on the incline? Yeah, I think so. We have to take this friction into account as well, and the normal as well into account. Fair enough. Well, do we know the okay, so I think we just need to find normal, which is just mg cosine 45 degrees, right? Let's plug in the mass and everything. So 1.6 times 9.8, or let's take it as 10. Times cosine of 45 degrees, which is somewhere around 11.31 Newton. And the friction force is, since it is a sliding friction, is just mu k times normal reaction. And normal reaction I just found as 11.31, and mu k is 0.8. So 0.8 times 11.31, which comes out as 9.05. We need to find the total force that the box is exerting, on the incline. So this is, like I said, same as what the incline is exerting on the box. So normal and friction are at 90 degrees. So the total force is going to be Pythagoras, square root of 11.31 square plus 9.05 square root, which is around 14 Newton. So I think the best choice will be option D. That is the total force that the box exerts on the incline or the incline exerts on the box. Right. Two different objects of mass m1 and m2 are accelerated by the same unknown force and are given accelerations a1 and a2. If you wish to calculate the magnitude of the force, what is the minimum information that you need? Okay, so I know that mass m1 is accelerated by some unknown force to give acceleration a1. Okay, so don't you think I just need well, any three quantities. Definitely A will work because I know that F net is equal to MA, so M1A1, and also F net will be equal to M2A2. So I don't need really any three quantities. Only two quantities would suffice. So, well, I hope there is no trick here. The answer should be option A. Right. Ball is thrown in the air. There's a retarding force F on the block. Well, they should have definitely used another word here. With magnitude BV, which is I think air drag, where V is the speed of the ball and B is the positive constant. Before it reaches the maximum height while it is moving up, the magnitude of the acceleration A of the ball at any time is equal to which of the following? So I think it is pretty much similar to, because if a ball is thrown in the air and before it reaches the maximum height, so let's say the ball is thrown somewhere from this point and this is the maximum height. So at this point, obviously, mg is acting downwards because gravity is not going anywhere, and there it has air drag as well. Now remember, the air drag will not really be acting upward because it will try to slow it down. So air drag will also act downward like this, bv. So the net force while going up will be equal to mg plus bv, and the acceleration will be f net over m. So that's going to be mg plus bv over m. And if we split the mass, it will be mg over m plus bv over m, which is just g plus bv over m. So g plus bv over m is an option C, so that should be our best choice. Okay, an elevator accelerates upwards at this. Inside the elevator are two stacked books, each of 2 kilograms. How much normal force does the bottom book exert on the top book? Okay, so it's something like this. There is one book over here, another book over here. They are of equal mass. So this is 2 kilogram. This is going up by 1 meter per second square. And this is also 2 kilogram. Okay, I know that this 2 kilogram will exert a normal on this 2 kilogram upwards. Let's call it Fn1. And there is a reaction force of this Fn1 on 2, which is downwards Fn1. And there will be a normal reaction due to the floor on the bottom 2 kg as one. Let's call it Fn2. Although I'm not really interested in the bottom one because I just need to concentrate on the top book. And the only force acting on this top book is Fn1. And I know that F net is equal to ma. F net is just Fn1 is equal to ma. Fn1 I need to find. Mass of the book is 2. Acceleration is 1. So this is going to look like, I'm sorry, obviously I missed an mg force, right? So there is an mg, which is 2g over here. So F net will be Fn1 minus mg. So that's going to look like Fn1 minus 2g. So Fn1 minus 20. So Fn1 will be equal to 20 plus 2, which is around 22 Newton. So I think it should be 21.6 because if you take as gravity as 9.8, that's just going to come as 21.6. So that's the closest option. It should be option C. Just to be clear, there will be an mg on the bottom one as well. I've not shown it. It's not relevant for us, but yeah, just to be clear. Okay,
An object is subject to a non-zero net force. Which of the following statements about its motion could be true? The object will remain at rest? No way, because if there is a net non-zero force, there is a movement, there is an acceleration. The object is traveling in a circular path with a constant speed. Uh, well, maybe. The object has a constant velocity? Nope. Because if there is a non-zero net force, there is an acceleration. If there is an acceleration, then how can the velocity be constant? The acceleration is perpendicular to the net force. How can that be possible? Acceleration is always towards the net force. Object is traveling in a straight line path with a constant speed. No, because if it is a straight line and constant speed, which means that the velocity is constant, which is not possible. So B is the only option, that it is going in a circular path with a constant speed. Remember, in circular path, the speed is constant, but the velocity is not, because because it is changing the direction at every point. So velocity is not constant, and yes, there is an acceleration or a net force always acting towards the center, which is called Fc, which is non-zero. So it has to be option B. A ball on the end of a string is being swung in a vertical circle at a constant rate. Which of the following statements about the forces acting on the ball and the acceleration are true? The tension in the string at the top of the circular path and the bottom of its circular path are equal in magnitude. I do not think so. Definitely not. Because at the top, the situation will, let me make the complete thing. At the top, the situation will be T and mg. That's the T1 and mg. That's the FBT. At the bottom, it is T2 and mg. So at the top, if I write the centripetal force equation, net force towards the center will be mv square over r. Remember, speed is same because they are saying constant rate. And at the bottom, it will be T2 minus mg is mv square over r. How can these be same? Because from the first I'm getting T1 is mv square over r minus mg, and from the bottom I'm getting T2 is equal to mv square r plus mg. So definitely no. At the bottom, the tension in the string acts up while the acceleration of the bottom ball is down. Definitely no. Tension is definitely up, but the acceleration is also up because acceleration is towards the center. That's why it's called centripetal force. At two times in its circular path, the string is perfectly horizontal, one on the way up and once on the way down. The only difference is the net force between these situations is the direction of the tension force. Looks promising because they are right. Once it is horizontal over here, once it is horizontal over here, and the only difference is the net force between these situations is the direction of the tension force, because over on the right the tension is to the left, over on the left the tension is to the right. Looks promising. I'm going to shortlist this. At the top of the circular path, the tension in the string acts down while the acceleration is up. Definitely no. Tension acts down, but the acceleration is again down towards the center. At two times in the circular path, the string is perfectly horizontal. Once on the way up, way down. The tension in the string is greater. No. Tension is same, just the direction is different because the tension is the only thing acting at the center and the velocity is same, so the tension is same. Only the direction is different. So yes, our intuition was right. Option C is indeed the best choice. Sorry, option C. Did I say option D? I meant option C. Option C is the best choice. A conical pendulum consists of a ball attached to the string, which of the following gives the speed of the ball. Okay, so here a little bit of geometry is involved. There's this tension over here. Remember, this is the circle and this is theta because they are alternate angles. So this component will be t cos theta and this component will be t sine theta. This is obviously mg. We don't really know what the radius is, but we are going to figure it out. If you notice this triangle closely, this is the radius. So I can say sine theta will be equal to opposite over hypotenuse. So L sine theta is going to be the radius. So I'm going to say that it's vertically not going anywhere. So T cosine theta should be equal to mg.
and t sine theta will provide the necessary centripetal force, which is mv square over r. I'm going to divide both these guys because I do not need tension, I just need speed. So t sine theta over t cos theta is just tan theta because t is gone. And mv square over r over mg. So this is going to look like tan theta will be equal to mv square over mgr. M and m is gone. Multiplying both sides by gr. So gr tan theta is v square. And what is r, guys? L sine theta. So g times L sine theta times tan theta is equal to v square. Is there any such weird option? Yeah, there is. So taking square root both the sides, it is g L sine theta tan theta under the square root. So gl sine theta tan theta, yes, it is an option E, and that is our final answer. Right, a roller coaster, by the way, just a gentle reminder, guys, if you can subscribe and share this video, please do that. It's really going to help me. I will also be posting more videos like this of unit reviews, so make sure you hit the notification button. And if you need private tutoring, feel free to reach out. A roller coaster designer is constructing a track with the goal that the riders will feel weightless when they reach the top of a bunny hill that is 45-meter high. Which of the following represents the velocity that the designer should construct the track for the car to reach the top, if it can be assumed that the roller coaster car is at the top of a vertical circle in this position? So that's just a fancy way of saying that there is a vertical circle. The roller coaster is over here. And if I want the person to feel weightless over here, right? Weightless over here at the top, then okay, in this case the FBD will look like FN and MG. But when you want them to feel weightless, you want those people to almost lose the contact from the floor, to be in the air, of course, if you're weightless. And as soon as you lose the contact from the floor, this FN becomes 0 at the topmost. So mg is the only force that is providing mv square over r, because that is the centripetal force. M and m is gone, multiplying both sides by r, so gr is equal to v square. So v will be equal to square root of gr. G is 9.8, or I don't know, maybe 10. And the radius, okay, and they are saying that when they reach the top of the bunny hill, that is 45-meter high. So I think the radius will be half, right? Because if this entire thing is 45 meters, the radius should be 45 divided by 2. So this comes out as 15 meter per second. So that should be the velocity at the top, which should be option A over here. Right, a sparrow is flying around a circle at a constant speed and height. There is air resistance. In which direction is the net force from the sparrow on the air as it flies? Okay, a sparrow is flying around a circle at constant speed and height. So it means that sparrow is probably, in a horizontal circle like this because it is at the same height. What is the direction, or in which direction is the net force acting from the sparrow on the air as it flies? This is a slightly tricky question. Now see, so if the bird is, there are three kinds of motion that the bird is doing. Bird is trying to keep itself at the same height, otherwise it would have gone downward because of the gravity. So definitely it makes sense. A bird is trying to push itself upward because of the air. So it must be pushing the air downward, so that the equal and opposite reaction will give it a thrust upward. So there should be a downward force on the air. Likewise, the bird is also moving forward. So in order to have a forward thrust, it should push the air backward. So there should be a backward force as well. And since the bird is moving in a circle, so bird must have a centripetal force towards the inside. So bird must be pushing the air as per reaction
outward. So all three forces are going to be exerted by the bird on the air, right? That's how this question works. Okay. Assistant pilot with a mass of 50 kilogram wishes to pull their jet into a vertical circle while traveling at a horizontal speed of 270. Pilot can handle up to 9 Gs of force without blacking out. What is the smallest circular path that can make this happen? So this is the circle, all right, and they are saying that the maximum acceleration that the pilot can handle is 9 g. So I know that Fc is equal to obviously mv square over r, and maximum value of Fc will be based on this acceleration, which will be mass times 9g is equal to mv square over r. Is gone, so I'm gonna multiply both sides by r, so 9gr is equal to v square. So 9 times 9 point, I need to find r, right? So r will be equal to v square over 9g. So r will be equal to v square, which is 270 square, over 9 times 9.8. So the value of r from here comes out as 826.53 meters. Why meters? Because that's the SI unit, right? They are talking about meter per second and all that. So answer is option A. Right, a block of mass m is being swung in a string of L. We have done a similar question. What are they asking this time? Ball is swung with a speed of velocity of v. The tension is equal to F. The length of the string is doubled and the ball is swung from the same angle with the same velocity. What is the new tension? So they are looking for the tension, right? New tension. So over here, this tension has a force of F. This I know is theta. So this is F cosine of theta. This is F sine of theta. Let's say the radius is R and this is mg. I honestly don't think that the tension is going to change, because look at the arrangement here. F cos theta will be equal to mg, right? These two should remain same. So F should be equal to mg over cos theta. Now tell me, theta is not changing, gravity is not changing, m is not changing. So how can F change even if I double the length? So it is not going to change, it is going to be same, which is option C over here. Right, a train of mass 5,000 kilograms starts from rest and is accelerated around a curve about a mountain. The train maintains 0.2 meter per second square tangential acceleration throughout the curve. What is the direction of train's acceleration vector relative to the radius line drawn to the center of the curve after it has completed 20 degree of the curve? So notice carefully, it has a tangential acceleration as well as obviously a centripetal acceleration, right? They are saying that what is the train's acceleration vector related to the radius line drawn from the center of the curve after it has completed 20 degree of the curve. So probably something like this, the train is somewhere over here and it has completed 20 degrees. The centripetal acceleration is going to look something like this, and the tangential acceleration is exactly at 90 degree, so it is going to look something like this. And they are saying what is the angle with respect to the radius line drawn to the center of the curve after it has completed. So this line, with respect to this, they are asking what is the angle. So for that, I need to find, let's say I want to find this angle alpha, right? That's what they are interested in, or let's call it theta. So can I just say that tan theta is opposite, which is a tangential, over the adjacent, which is a centripetal. A tangential is already given in the question, I don't need to worry about that, but the A centripetal is going to be V square over R. V is, do we know V? For V, I think I can use the equation of motion, which is V final square is equal to V initial square plus 2as. It starts from rest, acceleration is 0.2, and s is nothing but this thing, right? Recalling SAT formulas, this is the length of the arc, and the length of the arc is given by theta times radius, where theta should be in radians.
So it is 20 times pi over 180 times the radius is 300. So if we simplify this, I get 300 pi over 9. That is the value of L, or the S. So this is what I'm going to sub in over here, which is 300 pi over 9. So if I find the V final from here, which is basically the V over here, that comes out as 6.47 meter per second. So A centripetal will be 6.47 square over radius, which is 300. So this comes out somewhere around 0.14 meter per second square. And now this becomes pretty easy for me because I can put an A tangential, which is 0.2, and A centripetal, which is 0.14, and that is tan theta. So the theta will be tan inverse of 0.2 over 0.14, which is somewhere around 55 degrees. So definitely this was a challenging question, but yeah, I hope you understand this, how I got 55 degrees. All right, guys, these last couple of questions are on gravitation now. We are given that the acceleration due to gravity on Earth is g. So what is the acceleration due to gravity inside the Earth at a distance of r over 3? So be careful. If we are talking about outside the Earth, and let's say r is the distance from the center of the Earth, then the gravity is inversely proportional to 1 over r square. But if we are talking about inside, then the situation is different. Then gravity is proportional to just r, right? So if you are going inside at r over 3, yes, if the radius drops to 1/3, then gravity will also drop to 1/3, as simple as that. This is called Newton's shell theorem. It is in unit 2. I'm not sure if you guys have already learned it, but if you haven't, just remember that inside the rule is a little different. G is proportional to r. Right. This is, I think, based on the same concept that a planet exists with a mass of m and radius r, which are the following graphs represents the gravitation force on an object that moves from inside the uniform planet at a distance of 0.5 r to 3 r. So the same idea that till it reaches r, and over on the x-axis we have the ratio of r over r. So till it have a ratio of 1, it will behave like g is proportional to r, which means that it is a straight line like this. But then after r, it will behave like g is inversely proportional to r square, which will be a rectangular hyperbola like this. So out of all these 5 options, I think only this one makes the best sense, right? D, which is increases linearly and then rectangular hyperbola, right? Assume the Earth has uniform density rho and a radius of re. What is the strength of gravitational field at 1/2 re? Okay, so this question wants us to do all that effort. So Newton's shell theorem states that the gravitational force or the value of gravity inside any planet at a particular radius is only due to the mass of that radius. So for example, this is the radius r, and I need to find the gravitational the value of gravity at this point. So whatever the mass of this particular portion is, we need to use that portion and use just the regular formula dm over r, gm over r square. But the question is how to find this mass. So for that, we need to use the density formula, because we know that mass is equal to volume multiplied by density. Volume for this much portion is 4 over 3 pi r cube, because that is the formula for the volume of the sphere. And the density of Earth is just, let's call it rho, because that's what they are taking it. And if these two things we are going to sub in over here, then it will be g over r square multiplied by 4 over 3 pi r cube times rho. And r cube over r square will just become r. So it will become 4g pi over 3 rho. These are our constants times r.
So there you go. This is the value of the gravity that we were talking about earlier. I said that G is proportional to R. Yes, so this is the exact answer for it. And let's see which one is matching. We have 4/3 G pi rho RE. Okay, looks like option C is the correct choice because um, sorry, 1 second, hang on. We need to plug in the R, right? 1 second. R is one half of RE. So let's plug that in. This is the generalized formula for you guys. But yeah, in this particular question, they want us to sub in R as 1/2 RE. So no, actually it will become 2/3 this time. So 2/3 G pi rho RE. That should be our answer. Which is, I believe it's option D. It's no longer option C. It has to be option D. All right. I hope this makes sense. Was a slightly tricky question. All right. Over here, we are given that there are two stars of identical mass and size, and they are a distance d apart. The distance d between the star remains fixed, and the stars orbit in a circle about the center of mass. About their center of mass is shown. So this is the center of mass over here, right? Okay, so in order to find the correct relationship between them, this is a typo, guys. This is just indicating the mass m over here. So don't be confused with this n. Okay, this is a classic question where we need to compare the gravitational force with the centripetal force because after all, they are moving in a center. Take any one star and obviously the force is going to be attractive in nature. So we are going to say that this gravitational force is basically equal to the centripetal force. Gravitational force, be careful, it is G m1 m2, which is same over now r square. R is d square, and this is equal to mv square over, now don't make the mistake of writing d here because the radius is half of that, exactly mv square over r, so it's d over 2. So this is going to look like gm square over d square will be equal to 2mv square over d. One of the d is gone, one of the m is gone. So gm over d is equal to 2v square. What do we have to find? Okay, we need to isolate v square. Divide both sides by 2. So gm over 2d will be equal to v square, which looks like option B. That should be our correct answer. All right, okay. Over here, we are given that there's an astronaut on a new planet. He's hanging various objects with different known masses, one at a time from a spring scale. The astronaut then records the mass and the force reading, construct a table, and he's interested to know the gravity. Then which of the following graphs and the attribute of it will help us to identify the value of G? Honestly, guys, this is a really easy question because it's something like if this is a spring scale, right? And this is the mass. And remember, he's measuring force, which is this, and at the equilibrium, obviously, force will be equal to mg. So don't you think, guys, if he has force, if he has mass, then all he has to do is graph force versus mass over here, force versus mass, and the g is nothing but the slope, the straight line, the slope, because this is nothing but y is equal to mx situation, right? Where x is your mass, y is your force, and m is the slope, which is gravity. Should be option A, straightforward. All right. Um, we have this one. Two planets, J and K, have different gravitational field strength values at their surfaces. Gravitational field strength of J at its surface is twice that of K at the surface of K. K is 3 times the radius of J. Which of the following is the correct relationship between their masses? Okay, all right. We know that gravitational strength of J at the surface is twice the gravitational strength of K. So this the formula is G m of J over R J square, where R J is the radius of the planet J, is 2 times G m K over R K square. G is gone. So mj over, and it's given that K is 3 times the radius of, what do you call it as J. So if K is 3 times, can I replace Rk with 3 times radius of j, right? It's 3 times. So it will be mj over rj square is equal to 2mk over 9rj square. rj square is gone, and now we have to find a relationship. So I think we already have one, because from here I have mj is equal to okay, mj reminds me of spiral math, but mj is equal to 2 over 9 mk. 2 9 mk is, there you go, mj is 2 over 9 mk, which is option B. All right, this one talks about there are 3 different masses are arranged in a straight line. Uh, what distances x and y between the center of masses would balance the force experienced by mass 2? So in other words, the left one is pulling this one over here, the right one is pulling it over here. I want these two guys to balance each other, which means that force between 1 and 2 and force between 1 and 3 should be equal. Force between 1 and 2 is just capital G, mass of the first guy, mass of the second guy, over distance square, distance between them square, and then it is equal to G times the mass of the middle guy and the mass of the right guy over y square. Now, if you look at it carefully, GMM and GMM is gone. So I'm left with 6. So in fact, you know what? 6 and 6 is also gone. So 1 over x square is equal to 4 over y square. If I cross multiply, then y square is equal to 4x square, which means that y is equal to 2x. So whichever option is satisfying this relationship, that's our answer. And I think it is option C. Nope, it's not option C. It's option A, because if I will plug in x as 1, y will come out to be 2. And this is actually the only option that's satisfying y equal to 2x. Was a pretty decent question. Right, this one says that astronomers collect data for several moons in orbit around a distant planet. And the data collected are the distance between the planet and each moon and the period of the circular orbit of each moon around the planet. Okay, the data is in the table. Due to experimental error, one of the combination is wrong. We have to find that which one is that. So this is based on Kepler's third law, which states that t square should be proportional to r cube. Or in other words, we can say t square over r cube should always be a constant. So guys, literally all you have to do is square this guy and divide by the cube of this guy. And don't worry, don't need to cube 10 to the 8. It doesn't make any sense because it's same everywhere. Just cube this guy and find the ratio. So when I did that, everything comes out to be somewhere around 1.75. This is 1.75. This is 1.7577, I think. This is also 1.75. But this guy comes out as 2.9, which is definitely way off than all the others. So option D makes the perfect sense because the ratio is not adding up. All right, and the last one that we have here is a person weighing 800 newtons on Earth travels to another planet with twice the mass and twice the radius. What is that? Okay, so that's a pretty straightforward question. We know that G is given by GM over R square. This new planet has twice the mass, which means that it is 2m, and twice the radius, which is 2r whole square, which means that it is 2gm over 4r square, which means that it is half of gm over r square. And this is g dash. And what is gm over r square? That's just the original thing, right? Or sorry, this is not g dash. This is the g, which is the acceleration due to gravity on Earth, and this is the g dash thing. So this g dash will be half of g, which means that if he weighs 800 on Earth, then he will weigh half, exactly half on that planet, because the gravity is just exactly half. So it has to be option A. There's a 3 kilogram box that slides along a distance of 2 meters on a frictionless surface inclined at 30 degrees above the horizontal. How much work is done on the box by the gravity? So I know that the situation is something like this, and this is 30 degree over here. This guy is 3 kilograms, and it slides 2 meters, right? Slides along a distance. Obviously, if this is frictionless, then it must be coming down, right? Like this, 2 meters. Now, I very well know the formula for the work, right? Work is given by F d cos theta for a constant force. We need to find the work by the gravity, and the gravity is acting straight down, which is 3g because mass is 3 and gravity is just g. So force is 3g, distance is 2, and cos of the angle between, now be careful, the angle between the force and the displacement, if this is 30, this is 90, so this is going to be 60 degrees, right? This is cos of 60 degrees. So this will be 3 times 2 is 6. 6g cos 60 is 1 over 2. So this will be 3g, and g is around 10. So I'm going to get 30 joules as my final answer. And yeah, if you take, 9.8 as g, then you will get option D. So 29.4 joules. Okay. A particular force on an object applies such that its strength can be expressed as a function of time. So F is dependent on X. Excellent. Object has 32 joules of kinetic energy when it is at the origin. From there, it is displaced 4 meters. What is the final? This is based on a really important concept that work done by all the forces is equal to the change in kinetic energy. Now, since this is the only force that is given, so this will be considered as the force that will be doing all the work. But you cannot do Fd cos theta because force is no longer constant. So you're going to use F dot dx integration from initial point, which is origin, to final point, which is 4, is equal to the change of kinetic energy, which is Ke final, which we need to find, minus Ke initial. So 6x square minus 2x minus 5 dx integration from 0 to 4 is going to be Ke final, which I do not know, and Ke initial is already given as 32. So this will be 6x cube over 3 minus 2x square over 2 minus 5x from 0 to 4 is equal to Ke final minus 32. 3 times 2 is 6, so 2x cubed minus x square. Honestly, guys, you can also put that in TI-84 or Desmos because APs are now hybrid, so you can very easily find this entire integral. If you typed in exactly like this in Desmos, it will give you the number. But anyway, if I put the upper bound, it will be 4 4 is 16, 16 4 is 64, 2 times 64 minus 4 square is 16, 5 times 4 is 20, 0 will make everything 0, will be equal to Ke final minus 32. This will be 128 minus 36 is equal to Ke final minus 32, and my answer is 124 if I simplify all of this out. So Ke final is 124, which means that 124 joules is the final answer. All right. The net force acting on a sled on a frictionless track of ice is plotted on the graph as it is displaced from the starting point. The mass of the sled is given, so if it started at rest, what is the speed at 4? This is the same concept, but just along with another concept. Again, we are going to use that work done by all the forces is going to be equal to the change of kinetic energy. But in this case, the force is not given. Force versus position graph is given, and we very well know that the area under the fx curve gives the work. So I need to find the area of this triangle, which is pretty straightforward, right? Half times base, which is 4, times height, which is 5. So this is going to be 10 over here. So work done will be 10. Ke final, I do not know. Ke initial is 0 because it starts from rest. So obviously 10 will be equal to Ke final. Ke final is given by half mv square because they are interested in the final, the speed, right? Speed at 4. Multiply both sides with 2, so the 20 is equal to m. M is 10, 10v square. So this is going to be, dividing both sides by 10. 2 is equal to v square. So root 2 will be equal to v. So v is root 2 meter per second, which is option C. Right, imagine a 2 kilogram steel ball that is launched directly upwards with some initial velocity v naught at t equal to 0. The ball flies up to a maximum height of 1.8 meters and falls back to its original height. What was the work performed on the ball by the gravity? Um, don't you think that in this case the work performed is just zero? For a very simple reason that when it is going from this point to this point, like this, it is covering some distance. In fact, that is given to us 1.8 meters. And while coming back, it is covering the same distance again. But remember, the direction of force is not changing. Even when it was going up, the force was down. And while this was coming down, the force was still down, and the force was just mg. So in the first case, whatever work was done, that was mg times d, which is, let's say d, times cos of 180 degrees. So it was minus mgd. And while it was coming down, it was mg times d times cos of 0, which is just mgd. So effectively, gravity has not done any work because this negative and positive work cancel each other. So the answer has to be option A. Right, a 3 Newton force applied on a 0.4 kilogram mass makes the mass move at a constant speed. In the span of it moving through 4 meters, how much work does friction do on the mass? Okay, if 3 Newton force is applied on a 0.4 kilogram mass and that is making it move with a constant speed, it definitely means that the net force must be 0. And the net force will be 0 only and only when the friction is equal, the friction, opposes the force completely. So the friction is also 3 newtons. They are saying that it moves by 4 meters. So obviously if it moves by 4 meters, the work done is going to be FD cos theta, which is going to be 3 times 4 times cos 180 degrees. Cos 180 is minus 1. So minus 12 joules. That's going to be the work done by the friction. Okay. A ball hits and bounces off a wall. Before the collision, kinetic energy was k. After it was k over 16. So after the collision, what is the velocity of the ball in terms of initial velocity v naught? This is less math and more algebra, honestly, because you're going to say that initially half m v naught square is k, right? Because initial velocity is v naught, and that is the formula for kinetic energy. After collision, let's say the velocity is v. So half mv square is k over 16, right? This k I'm going to sub in over here. So it's going to look like half mv square will be equal to 1/16 of k, where k is half mv naught square. I hope it makes sense because I just rewrote this k over 16 as 1 over 16 times k, and then replace this k by half mv naught square. If you look at it carefully, half m is gone from both the sides. So v square is equal to 1/16th of v naught square. If I'm going to take square root, then square root of 1 over 16 is 1 over 4, and v naught square is v naught. So the final speed is actually 1/4 of the initial speed. So see. All right, guys, if you have found any errors in my work, feel free to post it down in the comment section. I'll be happy to correct that. All right, a particle had potential energy dependent on its position, represented by this. So what force it feels at 1 meter. This is a pretty important formula, guys, and I hope you have memorized this, that force, the conservative force, because of which this potential, we are having this potential, is negative of du over dx. That's the formula. So it will be negative of, what is the derivative of e to the 2x plus 1? It will be e to the 2x times 2 plus 0 using the chain rule. So it will be minus 2e to the 2x, that is the force. And at x equal to 1, all I have to do is replace x by 1. So it will be minus 2e square, and minus 2e square is 14.8 meters, negative 14 point, sorry, not meters, newtons. So negative 14.8 Newton, this is option E, so that's the correct answer. Okay. A particle experiences a force given by this. What is the potential energy? That's the same thing. The only difference is now we have to integrate, because force is given by negative of du over dx. So f dot f dx, not dot, f dx is equal to negative du. So if I integrate both the sides, I should be able to get the potential energy. So f is kx square. So kx square dx is equal to minus du. Du is nothing but x values from here. I need to find from 0 to some value x. And initial potential energy is not really given. So ideally, I should put a constant of integral. So rather than putting the bounds, I will make this as, kx squared dx is the minus of integration of du. So this will become k times x cube over 3. This integral is u and then plus c. But I don't really know at x equal to 0 what is the potential energy. Usually they give that in the question, but if nothing is specified, then I'm just going to assume that at x equal to 0, u is 0, which means that 0 is equal to 0 plus c, which means that c is 0. And that's what I'm going to plug in over here. So kx cube over 3 is equal to negative u, which means that u is negative kx cube over 3. The best choice looks like option E. That should be our correct answer. All right, guys, if you're enjoying this video so far, please like and subscribe. Please also share it with your friends. It will be helpful for them and for me. If a particle has a position dependent potential function, then where will the particle be at equilibrium? So equilibrium happens wherever the force is 0, right? So forces we already know now, it's negative of du over dx, that's going to be 0. What is the derivative of position function? I think that's going to be 2x minus 3, that's going to be 0. Minus of 2x minus 3 is same as 2x minus 3, that should be 0, which means that 2x should be 3, which means that x should be 3 over 2, which means that x should be 1.5 meters. So that should be our final answer, which is option C. Okay. An object is attached horizontally on a frictionless surface by a given spring, which obeys Hooke's law. Well, that's interesting. When the object is at some position A, the force felt by the object from the spring is this, and the potential energy is this. At some different position B, the force is a little more, and what is the potential energy at that point? Okay, I know that the force of the spring is given by negative kx naught, right? So and potential energy is given by k over 2 x naught square. So this is potential energy and this is the force. Now I'm going to work on position A. The force is negative kxa, let's say, is equal to negative 2.4, which means that kxa is equal to 2.4. And that's one. And then second is half k xa square is equal to 2.4, right? Because that's the energy. Multiply both sides by 2, so that's going to work. That's going to look as kx square is equal to 4.8. And don't you think, guys, I can use a graphing calculator to solve it, or honestly I can do it manually as well, because I'm just going to replace this. If you want, you can just find the value of k from here, which is 2.4 over xa, and plug that in over here. So it will look like 2.4 over xa. Why? Because I just replaced this by this, and xa square is still as it is equal to 4.8. So 2.4 times xa square over xa is equal to 4.8, and divide both sides by 2.4, you're going to get xa as 2. So if xa is 2, you plug xa back in, so you're going to get value of k as 2.4 over 2, which is 1.2. So that's what I was interested in, value of k. Now, the scenario B has again some unknown displacement, but the force is negative 12, which means that negative kxb is negative 12. K is 1.2 and negative is gone from both the sides. So 1.2 xb is 12. So xb will be 12 over 1.2, which is just 10. They are asking what is the energy at this point. So energy will be K over 2 xb square. K is already 1.2, xb is 10, so 10 square. So this will be, I think, 100. So 1.2 times 100 is 120 divided by 2. So that's going to be 60 joules. So 60 joules is, yeah, fortunately, option C. That should be our answer, right? Okay. Okay, well, some fancy stuff is going on here. Suppose a 0.2 kilogram mass stretches a spring by 6 centimeter. I can see that when it hangs at rest, but only stretches by 4 centimeter when it is underwater. Okay, fair enough. The difference is due to the buoyant force that acts upwards on the mass. So for those of you guys who are not aware of the buoyant forces, although this is a concept of AP Physics 1, they have recently introduced fluid mechanics, but it's still not in AP Physics C, and believe me guys, that's so good because that's a boring chapter. Anyway, buoyant force is basically a force due to a liquid on an object upwards, right? What is the magnitude of the buoyant force? Okay, I know that in this case, the value of zero point 0.2 kilogram is right over here, of course. This is 0.2 kilogram, which is responsible for the stretch. So the force due to 0.2 kilogram is 0.2 g. So I know that 0.2 g will be equal to kx naught. Let's take probably the gravity as 10. So 2 will be equal to k, that I do not know. And x naught, be advised, should be in meters. So 6 over 100, because we are talking about SI units, newtons here. So the value of k will be multiply both sides with 100. So 200 is equal to k times 6. So the value of k will be 200 divided by 6. Let's keep it aside. Now over here, what will be the FBD on this water, on this block which is in water? One is definitely mg, that is not really going anywhere. It is just 0.2 g. And one will be buoyant force, which is upward. So I'm going to say that 0.2 g minus FB is actually providing the net stretching force to the spring, which is nu kx, kx naught. Let's not use naught because let's put kx. So 0.2 g is just 2, FB I do not know. K is already, I know now, is 200 over 6, and the value of x is 4 centimeter, which is again 4 over 100 meters. So gone, 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 gone. 2 minus FB will be equal to 4 times 2 is 8, 8 over 6. So 2 minus FB will be equal to 4 over 3, which means that 2 minus 4 over 3 will be equal to FB. So FB is 0.66 Newton is the value of FB, which matches obviously closest with option A. Most likely they must have taken G as 9.8, but yeah, that works well. Okay, that was a good question. A non-conservative force is the one that, okay, has differing work depending on the path taken by the object. Yes, that's absolutely correct. Because non-conservative force work depends on the path taken. That's correct. Converts mechanical energy into various forms of external energy. That's also correct, because mechanical energy is not conserved whenever there is a non-conservative force. So 1 and 2 are definitely correct. Gives work done as 0 as long as particles move along a circular path. That is not correct, because consider that I connect a bob over here and this is moving in a circle. But don't you think that if you're thinking that tension is doing 0 work, that's correct. But is tension the only force? Because there is air resistance as well. Air resistance is a non-conservative force that will definitely do some work. It won't do a 0 work. So 3 is wrong. So I'm going to mark option D as my correct choice. Okay. The potential energy as a function of R is plotted over here. Which of those values could be the total energy of an oscillating particle? Okay, this one is a tricky question, guys. The idea is if I want my particle to oscillate, it should be within the potential walls. Potential wall means the total energy of the particle should be more than the minimum potential energy, and less than the maximum potential energy, or let me call it local maximum potential energy, because we want it to oscillate. Minimum potential energy would ensure that its kinetic energy is maximum, and local maximum potential energy will ensure that this is the point where the kinetic energy is zero. And I want it to oscillate, so I want it to oscillate between zero and max kinetic energy. So this happens between 1 joule, and the local maxima is somewhere around 3 joules. So between 1 and 3, there is only option between 1 and 3, which is 2 joules. So that can be the total energy of the particle if it wants to oscillate. Okay, a small block moves around a frictionless track. What is the minimum speed that the block must have at the bottom so that it completes the loop? Okay, this is a very important concept, guys. And the idea is whenever they ask for the minimum speed, look at the topmost point here. The FBD will be a normal reaction, and mg both are going to act. And I know that Fn plus mg at that point, let's say this is V, should be equal to the centripetal force, which is mv square over r. But since I need the minimum speed at the bottom, I'll assume that at the top, it almost comes at rest. Almost comes at, sorry, not comes at rest, sorry, I misspoke. It almost loses the contact from from this floor. So Fn becomes 0, that's the limiting case, which means that mg should be equal to mv square over r, gone. So gr is v square, which means that root gr is the speed at the top, not at the bottom. Don't mark root gr yet. Now, if I want the speed at the bottom, let's say this is v naught, I'm going to conserve the energy because there is no friction and normal is not doing any work. So mechanical energy is conserved. Let's take this as the reference of the for the gravity. So initial energy or mechanical energy is just the kinetic energy, which is half mv naught square, because the gravity is just 0. At this point, the energy is half mv square, and there is a potential energy because this is r and this is r. So there is mg2r kind of potential energy. So half m v naught square, I don't know v naught, half m v square, v is just gr, or v square is gr, so gr plus 2 mgr. I mean, I wrote small r here, but that, guys, is the same thing. That is just the radius of the track. Okay, so multiplying both sides by 2, in fact, m is gone. Then multiplied both sides with 2, I will get v naught square is equal to gr plus 4gr. gr plus 4gr is 5gr, and the value of v naught will come out to be square root 5gr. So that is the minimum speed with which it should be pushed at the bottom on a frictionless track so that it will complete one complete loop. Okay. This one says that when a 1 kilogram block is attached to the spring and lowered to come to equilibrium, it extends by 0.2 meter. A 1 kilogram block is then removed, the spring is again brought to the unstretched length, and a 1.2 kilometer is hung and released from the rest. What will be the maximum extension of the spring? Okay, this is complicated because if you are thinking that maximum extension will be when it is at equilibrium, no, it will not be at equilibrium. Because think about it like this, excuse me, when I will release it, it will come to this position, some position where kx and mg are both equal. But will the block stop here? No, it will keep going on and on downwards till and then the spring force will be more than gravity, and then there will come a point where it will come to rest, because during this position it will be decelerating. So we need to find when it comes to rest, and that's when I need to find the extension, because that will be the maximum. So first I need to find k value using this information, because here I have 1 times g and here I have k x naught, so k times 0.2. So I know that k times 0.2 is g, which means that multiplying both sides by 2, 2k is equal to 10g, which means that k will be equal to 5g. So somewhere around 50 Newton per meter, that's the value of k. This is a pretty good question. Do you think, guys, wherever I want the speed of the object to be maximum, I want its kinetic energy to be maximum. And since all the objects are conservative, the mechanical energy is conserved. So if I want kinetic to be maximum, that will happen wherever the potential is minimum, right? Now treat this as calculus. You know a function, you want to find where is the minimum. Obviously, you take the derivative of this, and which is 6x plus 2, equated to 0 to find the critical points. So 6x plus 2 is 0, 6x is minus 2, x is negative 1 over 3. Then you make a number line to do the first derivative test, if you guys remember. Then anything less than negative 1 over 3, let's say negative 2, this will become negative. Anything greater than negative 1 over 3 may be 0, this will become positive. Negative to positive means it's a minima, and that's what I want. So if this is minima, then definitely at negative 1 over 3, kinetic energy will be maximum. So it has to be option B. That was a pretty good question. Okay, a 32 kilogram block drops from initial height of 1.4 meter towards the floor. On the floor, there is a 42 centimeter tall spring with spring constant K, which cushions the blocks fall. Okay, the distance with which the spring compresses before. Okay, this is more about the conservation of energy. So this is a spring, and this is the mass m over here, and initial height of 1.4 meter is dropped towards the floor. Now 1.4 meter is this much. Okay. On the floor, there is a 42 centimeter tall spring. So this is already 0.42 meters, because we convert into meters. Now, when the block falls and it comes to rest, obviously the spring will be compressed a little bit. So let's say this is the situation where the block momentarily comes to rest, and this was the drop height. And let's say this is 1.4 meter, and let's say I don't really know what is this, so let's call it h over here. And I know that this was the spring's natural length, which was 0.4, and since the new length is x, obviously it has been compressed by 0.42 minus h, right? Because 0.42 was initial, h is the new one, so this is the height by which, or distance by which it has been compressed. Now I'm going to compare the mechanical energy, because that's conserved. Taking the ground as the reference point, here there is one energy, which is mgh, gravity. So m is, I think, 32 grams, right? I'm just going to consider it as m, and g and h. There is no spring, because it's at natural length and released from rest, so there is no kinetic. Here it comes to rest eventually, so there is no kinetic. But there is gravity, which is mgh, that I do not know, that I need to find actually, and half kx square, where x is 0.42 minus h. Okay, now I'm going to equate these two. And m is 32 grams, so it's 0.032 times 10 times 1.4 is equal to 0.032 times 10 times, I do not know, h. K is 32, and this is 0.42 minus h whole square. Okay, I'm going to use Desmos over here, or TI-84. Actually, I'm just going to change the gravity to 9.8 before typing it in Desmos. It honestly doesn't really make a big difference, but I just want to be sure because anyway I'm using the calculator. So if I type this in decimals as an expression over here, I can see that the two roots are 0.27 and 0.55. 0.55 doesn't really make any sense because it is even more than its natural length. It cannot bury in the ground. So 0.27 makes sense, but that is not the answer, guys, because we need the compression. So the compression will be 0.42 minus 0.27, which is somewhere around 0.15, which is 15 centimeters. So that should be our final answer. It was definitely challenging, but yeah, that's how we do it. Okay. A 0.52 kilogram block is sliding to the right on a surface that exerts a frictional force with 0.4 coefficient of friction. It collides with a horizontal spring, this constant, this which compresses by 12 centimeter as the block comes to rest. What was the speed? That's a pretty straightforward question in my opinion. It's just mostly based on the conservation of energy. Um, okay, and finally it comes over here at rest. So from here, it is sliding to the right. So the friction force of 0.4. This is 0.52 kilogram. This K value is 18 and it is being compressed by 0.12 meters. We need to find the speed when it collided with the spring. That is at this point, what was the velocity? So don't you think the energy, we are going to conserve the energy, but total energy, not the mechanical. Why? Because there is a friction over here. So can we say that the mechanical energy initial plus work done by the friction is mechanical energy final? That's how we conserve when there is a non-conservative force. Initial mechanical energy is just kinetic at this point. Why? Because actually this representation is not even required. This is just kinetic because this will be half mv square. M is 0.52 and v I do not know. There is no potential because there is no change in height, and obviously there is no spring energy because at this point it just collided with the spring. The spring was still at the natural length. Work done by the friction will be F dot D or Fd cos theta, Fd cos theta. And final mechanical energy will just be the energy of the spring because the block came at rest. So that's K over 2 x naught square. So K over 2 x naught square. Okay. This will be 0.26 v square. Friction is mu times normal reaction. Mu is 0.4 and obviously the normal reaction is just same as mg. M is known to us, right? Yeah, 0.452. So mg, let's take g as 9.8. D is basically same as the distance of the compression, and the compression is 12 centimeters, so 0.12. And theta is, of course, I've already taken negative here. I don't know why I put negative. It should be positive, then it should become negative because it is cos 180, right? Friction is here, displacement is here. So cos 180 is minus 1 is equal to 9 times 0.12 square. So let's solve for v. So v from here using a calculator is coming as 1.1997 meter per second, and I think the closest value is 1.2 meter per second, which is option C. A 2 kilogram object is tossed straight up from the top of a 25-meter high building with a speed of 10, misses the roof on the way back and falls all the way to the ground. Assuming air resistance is negligible, what is the change in kinetic energy of the object from the moment it is tossed to the moment of the impact? I can conserve the energy because no non-conservative force is involved. So this is the situation and this is the final situation. Initially, remember this is 25 meters. So initially, if I take the reference, it has kinetic plus potential. Kinetic is half m is 2, v square, v is 10, plus mgh, m is 2, g is, let's say, 10, h is 25. And this is equal to, by the way, I need to find a change in kinetic energy. So honestly, guys, just put it as K E I is equal to K E F. because that's the final potential energy. Final kinetic energy, and potential is 0. So 25 times 2 is 50, 50 times 10 is 500, is equal to Ke final minus Ke initial. And isn't that what they want? Change in kinetic energy, right? Change in kinetic energy, which is just 500 joules. The velocity of an object of mass m varies like this. What is the instantaneous power? Instantaneous power is given by F dot V, guys. Power is given by F dot V. Obviously, I don't know what F is, but I can easily find. F is equal to ma, and acceleration is dv over dt. And I very well know what v is. So if I take the dv over dt of ct, it is just c, because the derivative of t with respect to t is 1. So F is mc, let's put mc here, and v is just ct, that's already known to us. So it will be mc square t. That will be our answer, which is option C. A motorized pulley lifts an object of mass m at constant velocity. Assuming that all the frictions are absent, the average power delivered is given by total work over total time, right? Um, I can find, obviously this is one way, and you can use another way. I mean, this will work because they are asking the power delivered by the motor. So it is something like this. Since there is no other force except the motor force which is trying to pull it up, and the gravity which is trying to pull it down, and since it is moving with a constant velocity, motor force should be equal to the gravity force. And let's say it is going up by I don't know, for some time, let's say t, or maybe some distance d that I do not know. So I'm going to say that the work will be F dot d, which is mg dot d dot cos 0, because force and distance are in the same direction. Why have I written total? Uh-huh. Uh, that's total time. Total time is, let's say, t. So it will be mg d over t. And if you guys notice, what is distance over time? Isn't that just speed? So it is mgv, because speed is constant. So the average power is mgv, which is option C. Okay, motorized pulley lifts an object, da da da. Okay, this time there is a constant acceleration. So what is the instantaneous power at some time t? So instantaneous power will obviously be f dot v. I need to find the velocity at time t and the force, right? Remember that it lifts up with an acceleration of g, which means that the situation is, this is the force of the motor, this is mg, and it is going up by g. So as per Newton's law, I'm going to say that F minus mg, because that's the net force, should be equal to ma, and a is just g. So it should be equal to mg. So the force by the motor is a constant 2mg. So it will be 2mg times the velocity at some time t using the kinematics is v is equal to v initial plus at. Obviously lift starts from rest, acceleration is g, and the time is t. So this v at some time t is just gt. So the answer is 2mg square t, which is the instantaneous power at that particular instant, which is option D. Barnum pushes a 60-kilogram crate along a floor with an average speed of this for 5 seconds as he's cleaning up his garage. If the coefficient of friction between this and this is point, okay, what is the average output of Barney during this time? So basically they're asking what is the power of Barney, output power. The force with which he pushes is not given. And that's the idea over here, that his average force will actually be same as the force of the friction, because overall it is just moving with an average velocity of this. So we are just going to assume that over here force of friction is given by mu times normal reaction, and normal in this case is just mg. So it will be mu, which is 0.34, times m, which is 60 kilogram crate, times g, which is 10. So this comes out as 204 Newton. That is also the force, the average force with which Barney pushed. Now, average output power is equal to the total work that he has done over the total time. The work is basically his average power multiplied with distance, because cos 0 is just 1, so there's no need to put up cos theta because that's just 1, and total time is just given as 5. F average is 204. The distance that is moved by, isn't that just speed times time? Because that's the average speed. So 0.65 times 5 over 5. These two are gone, and finally we are left with 132.6 watts. So the average power that he exerts is somewhere around option B. Over here, what is the average power required to stop a 90,000 kilogram train that has an average initial speed of this at a deceleration of this? Okay, I know that the average power will be equal to the total work over total time. And in this case, I don't really need to find the total work using the FD cos theta formula, because there is no force of the, I mean, it's not like we can, but I think there is a better way, that we know that work done by all forces is basically the change of kinetic energy over the time. Change of kinetic energy, final energy is just 0 because it stops, and initial energy is half m, which is 90,000, times v square, which is 25 square, over the time. I don't know time, so let's find that out. V initial is 25, v final, because it stops is 0, deceleration is -4, and time I do not know. So I think I'm gonna say v final is equal to v initial plus at equation. So 0 is equal to 25 minus 40, which means that 4t is equal to 25, which means that t is 25 over 4. So this time is 25 over 4. Obviously our power will come negative, but they are just interested in the magnitude. So we're just going to return the positive answer. Let me find that. Okay, so this is 4500000 watts, which is basically 4.5 times 10 to the 1, 2, 3, 4, 5, 6, 6 watt, which is option C. That should be our final answer. All right. I hope you're enjoying this video so far, guys. If you are, please like and subscribe. Please share this video with your friends. It will really help me and your friends as well. And if you need private tutoring, feel free to reach out. An engine that delivers power P is attached to a pulley that lifts a box of mass m naught, a vertical distance of y naught at a constant speed. Oh my goodness, so many moving parts. If, as shown in figure 2, there is no figure 2, guys. There is actually no figure in this question. They are just saying that there is a mass over here. Let's say this mass is m naught, and it is pulled by a motor with a power of P, and it goes up by a distance of y naught and sometime t naught. So if the same situation happens with the same power with triple the mass, and it goes with the same vertical distance y naught, what is the time? So I'm going to say that the power is actually power of the motor is basically the work over time, and the work is nothing but the change in the change in energy. Basically this time the total work in that case will be the change of the potential energy in this case, because that's the work that is being done, right? So potential energy will be m naught y naught g, because it's mgh, and m is m naught, g is y naught, and h g is just h is y naught, and g is just g, and time is t naught. So this is how P looks like. In the next case, I think it's going to work as P is equal to 3m naught y naught g over some time that I do not know. Let's plug in this P over here, which is m naught y naught g over t naught is equal to 3m naught y naught g over t. M naught y naught g, m naught y naught g is cancelled. So 1 over t naught is equal to 3 over t. If we cross multiply, then the time will be 3t naught. So it should be option D. Right over here, two blocks of equal mass are connected by a string that passes over a pulley. Block 1 hangs and block 2 can slide. The system is released from rest. Using conservation of energy, a student derives an expression for the speed v of block 1. Block 1 is this and this is block 2 as and obtains as root gh. The experiment is performed and both h and v are measured, but the measured values of v is larger than the calculated value using the student's equation. Which of the following sources of experimental error could have caused the discrepancy? Obviously, if this formula is actually giving a higher value, this definitely means that this question, guys, I hope you have read the question. They are just saying that right now someone performs an experiment and using energy conservation, they found the speed of the block 1 as root gh. But actually, when it was performed experimentally, that speed came out to be more than root gh. So which of the following can be the answer? Guys, friction and air resistance is just not possible, because if you take friction, the actual speed will actually be less, not more. And if you keep on increasing the mass of 2, assume that you make it so heavy, you keep on making this heavier, 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 heavier. So obviously this system, this block has this block will not have will have less tendency to go down. The velocity will decrease. The only possibility is option E. Let's say the table is probably not horizontal, it is slightly inclined, so that the gravity component over here is also now helping it to slide and eventually increasing the velocity of the entire system. So I think my answer is E, but if you feel this is not correct, let me know in the comment section. Several identical objects are initially at rest on a surface. The figures are FBD, and for the forces that are exerted for some distance delta x, the following diagram is the net work being done on the system. Okay, if there is some network that is being done on the system, what is the network being done on the system? Zero. Sorry, okay, that's a weird statement, but where's the network done? Zero. That's what they're asking. I think it has to be a symmetric option, which is option D, because if it is moving to the right, first off, these two guys will not really be doing any work because they are at 90. And whatever work this force does because of this angle, this force, because of its symmetric angle, because this is 180 minus theta, it will do exactly opposite work, same magnitude, opposite sign. So eventually they will not do any work on the system. So it should be option D. A conservative force has the potential energy. Here, the particle moves in one dimension under the influence of the force has a kinetic energy of 1 joule when it is at position x1. So at position x1, its potential is -2 and kinetic is 1. Fair enough. Which of the following is correct about the motion of the particle? So I know that at x1 its kinetic is 1 joule, its potential is -2 joule. So its total energy is actually -1 joule, which is going to be conserved because the force is always conservative in nature, so the mechanical energy is conserved. So don't you think that if total energy is literally -1 joule, how can the energy or the potential curve go in this region where the potential is more than -1 joule? The reason is very simple, guys. Let's say the particle is at 1 joule. So in order to make the total energy -1, which is not changing, 1 plus kinetic energy should be -1, so kinetic energy should be -2. But can the kinetic energy actually be -2? No, kinetic energy can never be negative. So the yellow region is just not possible for the function to, for the particle to go over there. So I will say that, let's read the option. It oscillates with the maximum position x2. No, it cannot really go to x2. It moves to the right of x3 and does not turn. I don't think so. It moves to the left of x0. Where is x0 over here? Okay, we need to look. This is x0, guys. Sorry. This guy over here is x0. it comes to the rest at either x0 or x2, and it cannot, yeah, this is the best option. It cannot reach x0 or x2 because these are in the yellow regions and these are forbidden regions. They can never reach these positions. It was a good question, I think. Okay, a conservative force has potential energy U. The function has 3 kg moving around and influence of force of kinetic energy of 9.5 joules at the position x equal to 10. Isn't that almost the same question? Which are the following positions that the object comes to rest? Okay, similar question. So at 10 meters, its potential is about -2. So the total energy will be kinetic plus potential, which is 7.5 joules. Now, if the total energy is 7.5 joules, obviously kinetic energy plus potential energy at any point will be 7.5 joules over here. Now, I want the object to come to rest. So I want the kinetic energy to go to 0. So I want the potential energy to be 7.5 joules. But I don't really see any point where the potential energy actually can be 7.5 because the maximum is 1 joule and that is going negative and then tapering somewhere over 0.2 joules or something like that. So I'm going to mark option E that there is no point actually where it comes to rest because nowhere potential energy seems to be 7.5 joules. In an experiment, the car of mass m is set up on a horizontal surface of negligible friction. That's a long question. Group of students push the car towards an ideal spring of known spring on the vertical surface. The motion sensor is set up behind the cart, and the force sensor is attached to the cart as shown in the figure. The motion sensor is used to measure the position and speed of the cart, and the force sensor is used to determine the force on the spring exerted. Which of the following hypothesis can this experiment be used? Can this experiment be used to test? That's a long, wordy question, but honestly, they are just testing the conservation of mechanical energy because the friction is negligible. Um, if you look at option D, they are saying that because right now the speed is not changing, and the moment it hits the spring over here, obviously the spring is compressed, and at this point the system comes to rest. The only force that is exerting that is involved is the spring force. So it makes sense that work done by all forces, which is equal to the change in kinetic energy, all force is just the spring force, final energy is 0, initial energy is minus ke, work done by the spring is anyway negative in a way, so it's work done by the spring is negative of change in energy, and we can say that the work done by the spring is actually proportional to the initial kinetic energy from this, and that's what option D is suggesting, that the work done by the spring on the card is directly proportional to the initial kinetic energy of the card when it reaches the spring. A defensive football player with mass of 60 kilogram tackles the opponent who also has mass of 60 kilogram. Okay. Suppose a defensive player is running in the plus x at 8 while the opponent is running in minus y at 8. Okay. Well, I'm going to draw a scenario first. This is the the first person at 8 meter per second, and the other person is like this 8 meter per second and the minus y. Let's call this person D because he's going in the plus x axis, and this is O, opponent. Now the defensive player tackles the opponent, and within a contact time of 0.2 seconds, both players starts moving at the velocity of 4 and minus 4 meter per second. This is a vector, by the way. It means that they are moving 4 to the right and 4 down. Find the magnitude of the average force applied by the defensive player on the opponent. Okay, this is the initial scenario, guys, and the final scenario is they are together. They are together, moving at 4 to the right and 4 downwards. Obviously, the momentum is conserved here because there's no other force and the internal forces cancel each other. So but the catch is we need to conserve the momentum in both the directions separately, right? So in the x world, I'm going to write the, what do you call it, as the momentum of any one, because momentum is definitely conserved, but we are looking for force, and force is change in momentum over change in time. Now, it doesn't really matter whether you find the change of momentum of the opponent or of the defensive player, because it's equal and opposite, right? So let's pick any player that you are interested in. Let's pick the defensive player and find its change in momentum. So initial momentum is obviously to the right, so that's going to be mv, so 60 times 8, which is 480. I'm not writing the unit, it's kilogram meter per second, but that's fine. Final momentum has two components. One is towards the x, and this one is also towards the x, by the way, and one is towards the y. Towards the x, that's 60 times 4, which is 240, and towards the y, it is minus of 60 times 4, which is minus 240. And if I want to find the change, so the change is obviously P final minus P initial. So let's find the change of momentum in the x direction. That's just going to be 240 minus 480, which is just minus 240. And change in the momentum in the y direction, it's going to be, let me take out this f here because we are just looking for change. In y, there is just one, momentum, so that's just this. So how do we find the total change? One is in x and one is in y, obviously using Pythagoras theorem. So change net is going to be square root of 240 square plus 240 square. There's no point of putting a negative sign, because even if I put a negative and I square it, that's still going to be positive. Okay, if I do that, I'm going to end up with 240 square root of 2 kilogram meter per second. And all I need to do now is, if you are confused about how I got this, is totally fine. You can just use a calculator and get a decimal number. And eventually you can plug that in over here. So you're going to get the force, which is, 240 square root of 2. And the time of contact is given to us, it is 0.2. So 0.2. This number comes out as 1697.06 newtons, which is somewhere around 1700 newtons, right? So that's going to be our answer for this one. I hope this makes sense. Okay. A 3 kilogram ball moves along in one direction and then encounters an outside force that alters its velocity. According to this graph, what is the average force experienced by the ball between 1 and 3? Okay, we know that the average force will be given by change in momentum over change in time. I know that this is 5, and if I count this 1, 2, 3, this is, negative 3, of course. So the final momentum, because I'm looking for change, so final momentum over here is going to be mass times velocity. Mass is 3, velocity is minus 3, so the momentum is going to be negative 9 kilogram meter per second. That's the final one. And here it's going to be 3 times 5, because again mass times velocity, that's the momentum. So 3 times 5 is 15. That's going to be 15 kilogram meter per second. So the change is going to be final, which is negative 9, minus initial, which is 15, over how much time elapsed from 1 to 3. Isn't that just 2 seconds? So 2 over here. This comes out as, I think 5 and 4 is 24 divided by 12. So that's going to be negative 12 newtons. So that's going to be the average force that is exerted during this, the period. That was pretty straightforward, I think. Okay. A ball is moving straight down with a velocity of v0 and bounces off the ground and moves back up with the same velocity v0. So what is the change of momentum? 0 looks pretty tempting, but please be very careful about the directions, because momentum or impulse, because impulse is change in the momentum, is all about directions. So I know that the final momentum will be, let's take upward direction as positive. It will be mass times velocity. And let's take the downward direction as negative. So it will be minus mv0. So impulse, or the change in momentum, is going to be P final minus P initial. P final is mv0. P initial is minus mv0. So guys, actually these two guys are going to add. So the answer will be 2mv0, which is option C. Just be careful with this. All right, three particles of equal mass are moving as shown in the sketch. What is the magnitude of the resultant magnitude of the center of mass of the uh, system? Okay, resultant magnitude of the center of mass, guys. Okay, the momentum of the center of mass is nothing but mass, the total mass, times the velocity of the center of mass, right? That's how it works. Total mass, we don't really know the mass, but we know that they are equal. So let's call it m, m, and m. So this will be 3m multiplied with v center of mass. Now the question is, how will I find the v center of mass? V center of mass is a formula that VCOM will be equal to m1v1 plus m2v2 plus m3v3 over m1 plus m2 plus m3. In other words, V center of mass is basically the sum of the momentum, individual momentums, over the total mass. That's the formula. Okay, anyway, so what I'm going to do is, but again, we have to be really careful because there are directions involved. So there will be some velocity in the x, some velocity in the y. So you have to take care of that. I'm going to make components of, for this one, there will be a V naught cosine theta or cosine 60 component, and V naught sine theta or sine 60 component. So here also we'll have V naught cosine 60 and V naught sine 60. Now the interesting part, and the part that is good for us, is its y direction's velocity. If you notice, of these two pieces, this anyway doesn't really have any y direction velocity. So in the y direction, the total velocity of the system is anyway 0. So we don't really need to, I mean, I can do it for you so that you can have a better sense. Let's actually do the math so that you understand. Let's find in the x direction first. So in the x direction, it will be m times v naught cos 60. Cos 60 is 1 over 2, guys. So I'm just going to replace it with v naught over 2 and v naught over 2. So here I will have m times v naught over 2 plus m times v naught over 2 plus m times minus 2 v naught. Just be careful because that's in the left direction over 3m. That's the total, that's the velocity in the x direction. mv naught over 2 plus mv naught over 2 is just mv naught minus 2mv naught over 3m, which is just going to be minus v naught over 3, because mv naught minus 2m, I mean, I hope you understand. That's just a simple math over here. This is the velocity of the center of mass in the x direction. Now the question is there any velocity in the y direction? Let's try to find that using the same formula. So velocity of the center of mass in the y direction will again be m1v1 plus m2v2 plus m3v3 over m1 plus m2 plus m3, which is just 3m, m2 plus m3. Okay. This one has a velocity of v naught sine 60 upwards, so m times v naught sine 60. This one has a velocity of v naught sine 60 downwards, so m times minus v naught sine 60. And m3, or this one, doesn't really have any velocity in the y direction, so that's just 0 over whatever, 3m. Now guys, these are equal and opposite, right? This is v naught m v naught sine 60, then this is minus m v naught sine 60, so this is just 0. So there is no y direction velocity of the center of mass, which means that my answer is just 3m multiplied by velocity of center of mass, which is minus v naught over 3. So the answer is going to be just m v naught with a negative sign. I think they are just interested in the magnitude. Yeah, they say magnitude, so there is no negative in our answer. That's why it should be just be option B. Hope do you understand this one? A ball of mass 0.15 kilogram moving east at 10 meter per second struck by a bat. So east is over here, 0.15 kilogram, and this is 10 meter per second. It now moves west at 20 meter per second. Remember, the mass doesn't change, and the collision lasts 0.01 seconds. So what is the average force by the bat? So I know that the average force is going to be the impulse, which is the change in momentum over time of contact. The initial momentum is just mass times velocity, which is 1.5 kilogram meter per second. And the final, just be careful with the signs because it will be 0.15 times minus 20, which is going to be minus 3. So F average will be P final minus P initial over 0.01. So this comes somewhere around 450 newtons, so with a minus sign. So that's going to be our answer. Once again, I think they are interested in just the magnitude. That's why there's no negatives. I'm just going to mark option A. Okay. Right, this is calculus dependent. So a 1.2 kilogram particle experiences this force. What is the impulse delivered by this force from 0 to 2 seconds? I know that if the force is variable, then impulse is given by, we write dp will be equal to f dt integration. That's how we write that. Right, so dp is basically the change in momentum, so, or we can say that this is the impulse eventually. That's what I'm going to get, but I can definitely write in a proper way. 3t squared dt, and this is from time 0 to 2, and I'm assuming that initially the whatever the momentum is here, let's say p1 and let's say p2. So I'm gonna integrate that. Integration of dp is just p from p1 to p2, and here the integration is t cube over 3 from 0 to 2. 3 and 3 is gone. If I put 2 here, it will be 2 cube, which is 8 minus 0, and this will be p2 minus p1, and p2 minus p1 is nothing but the change of momentum or the impulse, which is going to be 8 kilogram meter per second or 8 Newton second. That's also a unit. So option B looks like the correct choice. Okay. A sleeping panda is placed gently on a frictionless ramp and then slides down the ramp. The ramp slides on a frictionless floor so that the ramp slides along the floor as the panda slides down the ramp. What direction does the center of mass for the panda ramp system move as the panda is sliding down the ramp? So guys, remember that in this system of panda ramp, there is no horizontal force, or let's call it F net horizontal is just 0 because there is no friction, and whatever the normal is acting here, the same normal is acting on the ramp as well because of action and reaction, and they are just going to cancel each other. But because of a gravity force, this external force will not really be cancelled by anything. And that's why, since the F horizontal net is 0, the center of mass is not really going to move left or right. It will just move down because of the gravity, because the gravity is not really cancelled by anything, right? So it has to be option B. The child pushes a toy car with a mass of 4 kilograms for 10 seconds. The child pushes harder for 2 seconds, but then becomes fatigued. And okay, there's some drama given, and there's some, the graph over here as the force changes with time. They're asking the graph, what is the initial velocity of the cart? Okay, by the way, the important portion is the cart is momentarily at rest at t equal to 4 seconds. Okay. This means that if I am finding uh, f times delta t is equal, I know that f is delta p over delta t, and when the graphs are given, I know that impulse is basically the area under the f time curve. Sign sensitive area, of course. Here I don't have to worry about the sign because everything is above the x-axis. So let's take this interval because it is momentarily at rest at t equal to 4. So at 4, its momentum is definitely going to be 0. So I can just replace this portion with 0. And initial momentum is just mass, which is 4 times velocity that I need to find. Area of this triangle is just obviously half times base. Base is 4 and height is another 4. So this is going to look like negative 4v is equal to 16 over 2. So that's going to be negative 4v is equal to 8. So v is going to be negative 2 meter per second. Yeah, we have that in the option. So option B is the best choice, that the initial velocity is negative 2. Looks like the other triangle is not needed, right? Okay. The ball of mass m is moving at the speed of v naught at an angle da da da. It strikes and the same momentum with the same momentum at the same angle. What is the magnitude of the change in momentum? Okay, the classic question of impulse, we need to make components, of course, because this is, you know, oblique in nature, not horizontal or vertical. A little bit of geometry is involved. If you guys notice, these two are parallel and this is a transverse. So can we agree that these two angles are equal? So this angle is also theta, which makes this velocity as v naught cos theta and this velocity as v naught sine theta. Likewise, this is also v naught cos theta. If you want to look at the angle, this angle is also theta because they are corresponding angles, and this will be v naught sine theta. Obviously, guys, there is no change in the momentum in the y direction because the velocity is not changing. So even if I find a change, that's just going to be 0. So the only change is in the x direction or I cap. So all the j caps are anyway gone. Final momentum is m v naught cos theta, and initial momentum is minus m v naught cos theta. So the impulse is going to be m v naught cos theta minus m v naught cos theta, which is going to be 2m v naught cos theta in the I cap direction, of course, because it is in the x direction. So it has to be option D, I think, right? Guys, I hope you are enjoying these well, questions and solutions so far. If you are, please like and subscribe. Please share this video with your friends as well. It's really going to help me. And if you need private tutoring, feel free to reach out. All right, a 100-kilogram cannon is loaded with a cannonball of mass 10 kilogram. The cannonball is shot at a speed of 80. What is the magnitude of the impulse delivered to the cannon? Okay. There are two things or two objects here. One is a cannon and then one is the cannonball. I know that impulse is going to be equal and opposite because momentum is conserved, right? If the momentum is conserved, this means that the impulse or the change in momentum, the magnitude of the change in momentum of the cannon is going to be same as the magnitude of the change in momentum of the cannonball. And they have already given us the speed of the cannonball anyway, and then they are asking the impulse of the cannon. So don't worry, we can just find the impulse of the cannonball and this magnitude should just be same. Initially cannonball was definitely at rest, so initial momentum of the cannonball was 0, and the final momentum of the cannonball is just mass times velocity. Mass is 10, velocity is 80, so that's just going to be 800, and the impulse or change is just going to be 800 minus 0, which is 800. So 800 Newton second is option C. That's going to be our answer, which is also the impulse of the cannon. I hope that makes sense. A plot depicts the momentum of, oh, interesting, the momentum is changing with time here. They are asking at 5.5, what is the instantaneous force? This is again calculus based, guys. I know that F is dp over dt whenever the force is not constant. Just find the derivative of the momentum with respect to time. It will be 4t minus 3. I hope you remember your derivative rules. And now I need to just plug in 5.5. So 4 times 5.5 minus 3 is just 19 Newton. So that's going to be the force acting at that instant. Right. Two objects have the same kinetic energy. The first object has more momentum than the second. Which of the following must be true? They're asking us to compare speed, I think. Yeah, moving. Okay, they're asking us to compare the masses. Interesting. Okay, there's a very good way to do this question, guys, and this is a very popular question. Kinetic energy is given by half mv square, right? We know that. Can I write v square as v times v if you don't mind? Okay. And don't you think m times v is just momentum, right? So can I write kinetic energy as half times p times v, momentum times velocity? Okay, excellent. Now they are saying that they have the same kinetic energy, which means that half p1 v1 is equal to half p2 v2. But then they're also saying that the first object has more momentum. So obviously, guys, if this guy is greater and this is less, and if these two guys are equal, then obviously it makes sense that V1 should be less and V2 should be more so that they can be equal. So the conclusion is V1 is less than V2 or V2 is greater than V1, the way you want to see it. Let's see. The first object must be moving faster. No, the second object must be moving faster. Over here. And so what can we rule out? A cannot be possible, C cannot be possible, and yeah, that's it. Now, in order to compare the mass, let's come back to, because we already compared the velocities, right? Now we can compare the mass. Remember that their momentum is mass times velocity, right? m1 v1, this is the p1, and p2 is m2 v2, and they are saying that p1 is greater than p2, right? Which means that m1 v1 is greater than m2 v2. Now, don't you think that if this velocity is already more than this one, then in order to make the left guy product greater than the right guy, obviously you want to make the first one heavier. Then only this big number will multiply with a relatively small number to make eventually a bigger number, right? I hope you are able to understand. This is more about a game of numbers and comparisons. But yeah, I can just explain it again, that if this velocity is more, then this number is definitely more. Let's take some examples. Let's take V2 as 4 and V1 as 3, right? Now, I want some number here and some number here that should multiply with this, and it should be bigger. So obviously, whatever number I put here, let's say I put here 2 kilogram. So I have to put a number greater than 2, right? So in order to make this product bigger, because this is already 8. So maybe I can put 3 so that this will become 9. So this mass will be greater than this mass. And that's what I'm saying. M1 should be greater than M2. So the second object must be faster and have more mass? No, the first object will have more mass. So second object must be moving faster and have less mass. I think this will make sense. And the first object must be moving slower and have more mass. You can ignore option E, because although it is correct as well, obviously if second object is faster then the first is slower, and if second has less mass, then the first object will have more mass. So E will also be correct. That's why just ignore this option, otherwise there will be two correct options. And in AP Physics C, since the pattern has changed, the multi-correct option MCQs are no longer a part of the exam, right? So just option D, ignore option E, that's correct. Although E is also correct, so either you can ignore D or E. But the point is, I hope you understand the logic behind it, the way we are solving it, right? Okay. A variable net force pushes a toy. Straight line magnitude is this. What is the velocity of the 0.3 kilogram after this thing? Okay. You can do this using momentum, and you can do this using kinematics as well. It's up to you. Since we are in the momentum chapter, I'll try to do this using the momentum. We know that F is dp over dt, right? So I'm given that, and obviously by that logic, f dt will be equal to dp. So I'm going to say that dp integration will be equal to f dt integration. Initially, the momentum is 0 because it starts from rest, and finally, let's say the momentum is p. Initially, the time is 0, and finally, the time is 0.7. Okay, f is 1.5 t dt, and I need to integrate from 0 to 0.7. The integration of 1.5 t will be 1.5 times t square over 2 from 0 to 0.7. So this will be 1.5 times 0.7 square divided by 2, and this is on the left side is just going to be the integration of dp is just p from 0 to p. So this is just p minus 0, which is just momentum. And momentum is given by mass times velocity. Mass is 0.3 and the velocity is unknown. So I'm going to say that 0.3 v will be equal to 0.3675, and that if I divide by 0.3 is going to be 1.225 meter per second. I hope that is in the options. Yes, 1.2 meter per second is in the option, so I'm just going to mark option D. All right, dart of mass m is shot with a speed of v naught. The dart penetrates a block of mass m that was initially at rest and exits the other end of the block with a speed of half v naught. What is the speed of the block after the dart passes through it? So this is a classic question of the conservation of momentum. The block M was sitting here peacefully at rest while a dart is fired or shot, mass small m with a speed of v naught. That is the initial scenario. Guys, I always have a habit of making scenarios like this, so it really helps me to think. And finally, this came out with a velocity of v naught over 2. This is still mass, but I need to find what this velocity is. Like I said, momentum is conserved. So the initial momentum will just be m times v naught because the momentum is only of the dart. This mass is at rest. And the final momentum will be of this block, which is m times v. I don't know v. Plus of the dart, it will be m times v naught over 2. These two should be equal, of course. So m times v plus m v naught over 2 should be equal to m v naught. Subtract both sides by mv naught over 2. So mv naught minus mv naught over 2 is just mv naught over 2. I hope you understand. It's just, essentially 1 minus 1 over 2 is 1 over 2, and mv naught remains as it is. So that's just mv naught over 2. This is m times v. So v is going to be mv naught dividing both sides by capital M over 2v, which is fortunately option B. So that should be our final answer. Okay. A block of mass m is released from rest at a height of h on a frictionless track. The box collides and sticks to another block of mass m at rest at the bottom. What is the height reached by the blocks after the collision? This is a classic question of perfectly inelastic collision and then eventually conservation of energy. There are three parts to this question. The first is, what is the velocity when this top box M is about to hit the bottom box that is at rest? That is part number one. Let's call it V. The second part is, let me draw that over here. So I don't know what this V is. The second part is, after hitting and when they stick together, what is their new velocity? Let's call this v1 and let's call this v2. This is 2m. And after this, when they reach a particular height, let's call it over here, what is the height, which is definitely our answer, the final answer. Let's call this height as, I don't know, maybe d. So let's find the first one. The first one, we will find this velocity using conservation of energy, because this is a frictionless track. Friction is not doing any work, and normal is also not doing any work because it is always at 90 degree. So the mechanical energy is conserved. So initially the energy was all potential mgh, and that is converted into all kinetic, which is half m v1 square. M is gone, so 2gh is equal to v1 square. So v1 is root 2gh. That's part number 1. Now, when they collide perfectly with a perfectly inelastic collision, the momentum is conserved. So initial momentum is mv1, final momentum is 2mv2. M is gone, so v1 divided by 2 is v2, or I can say that root 2gh over 2 is v2. Finally, I need to conserve the energy once again. So I'm going to say half,
because kinetic is converted into potential. Just be careful that the mass is now 2m. 2m v2 square will be equal to m, not m, 2m g d. 2m is gone. Half of v2 square, just be careful when you square this. The top square root will be gone, so 2gh, and the bottom 2 will become 4, and this g and d remains as it is. Fortunately, g and g is also gone, 2 and 2 is also gone, so h over 4 will be the d, and isn't that what we needed? So the height, the new height to which the combination will rise will be h over 4. Right, a group of students wish to conduct an experiment. Hey guys, I hope you read the question. So here you can visualize this as an object that is going over here. Let's say there's a cart over here which is going to the right with some speed v, and there is an object or a stone that is falling over here with some velocity, let's call it v2. After this object lands in the cart, they both move together, right? They both are now a part of the single, a unit, and they both move with some velocity v3. Now, obviously, there is no change. This just goes to 0 because of the impulse, but we are interested in what happens with v3. Obviously, it has to decrease, right? Because the momentum is conserved, and let's say this was m1 and this was m2, and now this is m1 plus m2. The momentum is conserved. Initial horizontal momentum is just m1 v1. Final horizontal momentum is m1 plus m2 times v3. Since the mass has increased, velocity has to decrease. So v3 will go down. Teacher's speed will remain unchanged. No. Decrease because of friction. No, it's not because of friction. It's because the teacher has to carry this new object along with her, so she's kind of accelerating it. So decrease, no. Increase, way, no. Decrease because she will have to apply an impulse to no, that's not the correct justification. These two individual statements are correct, but her speed will not decrease just because she's applying an impulse to catch. Impulse to catch is the reason for v2 to become 0. E is correct because they are saying speed will decrease because the object will apply an impulse to the teacher as she will apply an impulse to accelerate the object forward. Exactly, that's what we are talking about, so it should be option E. Okay. Here they are saying that the diagram shows a large object with 3m sliding. So the situation is 3m is going with v, and there are two objects at rest, smaller objects, and they just collide, and after the collision there are scenarios that are given to us. So which of the following depicts a scenario that has impossible values for the velocities of the three objects? We just have to look for a combination where the momentum is literally not conserved, right? Because the momentum should be conserved, and that should be something that is not allowed. Just by looking at it, I think can we agree that vertical momentum has to be 0, right? Because initial vertical momentum, there is nothing on the vertical side. So P initial y is 0. Let's look for an object where there can be a P final y, because that will not really be allowed. Well, I don't really see it because everything is pretty much symmetric in nature. So that may not work. Okay, fine. Then the initial x momentum is towards the x direction, positive x direction. That's the other thing. So let's see which one is not in the positive x direction. Okay, let's talk about this one. C looks pretty straightforward. Here final momentum is 3m times v naught over 2 towards the x direction, because these are just going in the y. And here initial momentum is 3mv. How is that possible? Initial x momentum here is 3mv. Here final x momentum is 3mv over 2. So this scenario is just not possible. How can it just go vertical? It has to go in an oblique sense, A, B, D, E are making sense, and C is definitely not possible. Okay, a block of mass m and v naught perfectly inelastic, another block m, what is the kinetic energy loss? So perfectly inelastic, I hope you know, the objects stick together. That is honestly the most easy collision question. So m is going with v naught, and this m is initially at rest.
And finally, obviously they stick together. So this is 2m and this is some v that I do not know. Initial momentum is just mv naught. Final momentum is 2mv. Since the momentum is conserved, so I'm going to say that 2mv will be equal to mv naught. So this is gone. So the v, the final momentum of the combination, is just half of the initial, so v naught over 2. But they are interested in how much energy, kinetic energy, is lost. So initial kinetic energy is given by half m v naught square. Final kinetic energy is given by half, total mass is 2m, and new velocity square. These two are gone. So m times v is v naught over 2 square. So this will be m v naught square over 4. How to find the change now? Change is obviously final, which is mv naught square over 4, or 1/4 of mv naught squared, if that helps to see it better, minus half of mv naught square. So 1 over 4 minus 1 over 2 is just negative 1 over 4. So negative 1 over 4 mv naught square. So that's the loss of the kinetic energy, right? And 1/4 mv naught square is, there you go, right here. So B makes the most sense. Okay. The motion of two identical moving carts is captured in the graphs, and the cart 1 starts to the left of cart 2. Okay, so just to be clear, cart 1 starts to the left of cart 2. Cart 2 starts to the right, and cart 2 is solid line, and this is dashed. Okay, just to be clear, both are moving in a straight line along the same path, right? Okay, all right, and they undergo an elastic collision, and velocity to the right is positive. So obviously cart 1 is moving to the right and cart 2 is moving to the left. So that is for sure that initial speed of cart 1 is positive and initial speed of cart 2 is negative, which in my opinion rules out one option definitely, which is E, because here everything is positive. Now, another very important thing is they are of the same mass, they are identical. So I don't know if you know this concept, guys, but in elastic collision, if there is a perfectly elastic collision, and if the mass of both the objects is same, they basically interchange their velocity after the collision because their kinetic energy is conserved, right? Even if you don't know this, you can just apply the kinetic energy conserved concept and that should be fine. For example, cart 1 is positive, right? And cart 1 is a dashed line. But initially the dashed line here is negative, so A doesn't make sense. Initially dashed line is negative, so D doesn't make sense as well. Now, if you look at this, the initial kinetic energy of the system here is, let's take the mass as 1 honestly. So it will be half mv square, so half times 1 times 1 square, and here also it's half times 1 times 1 square, so half and half, right? Initial kinetic energy is half plus half, which is 1. But finally this will be half times 1 times 1 square, and this will be half times 1 times 2 square. But that will not work because this will be half and this will be, well, 2 plus 1.5 is 2.5. How can the kinetic energy increase? It should be conserved, right? So C is not possible. B makes sense because initially it was -1 and 2. Finally it will be 2 and -1, which definitely will make the kinetic energy same even after collision. So option B is the best choice. Block 1 of mass m moving at the speed of v collides elastically with block 2 of mass m, which is initially at rest. What are the velocities of v1 and v2 right after the collision? So this is m that is moving with the speed of v, and this is m that is at rest. Guys, if you know the shortcut, this question will hardly take 10 seconds, not even 10 seconds, 5 seconds to answer. That if the velocity, if the mass of both the objects is same,
and they undergo an elastic collision, then their velocities interchange, which means that the first object will take the velocity of the second object which is at rest, and the second object will take the velocity of the first object. Remember, I'm saying velocity, not speed. So speed with direction. So v to the right. So velocities of v1 and v2 right after the collision is going to be 0 and v. Only this combination is making sense. It has to be option C. That's the best choice. Ideally, they should have written 0 and v first, 0 first, because 0 corresponds to v1, but I think it's okay. There's a minor probably typo here. Right, a block of mass 2m moving at the speed of v collides and sticks with another block of mass m that is initially at rest. So sticks means this is perfectly inelastic. What is the magnitude of the impulse delivered to the block of mass 2m? Okay, so this is 2m, which is going with v, and this is obviously m, which is at rest. Over here, they collide and stick together, so this is 3m. Going with some speed v that I do not know. But I can conserve the momentum here. P initial is 2m times v. P final is just 3m v. Let's take v as v2. These two should be equal, so 2mv and 3mv2 should be equal, which means that v2 is just 2/3 of v. They're asking what is the impulse to the block of mass 2m. So it doesn't really matter. I can find the impulse of m or impulse of 2m, guys. It doesn't really matter because, like I said, impulse of both will be equal in magnitude. But okay, if you want to be for the the peace of mind, you can find the impulse of the 2m. So that will be 2m times v2, which is on the right, minus 2m times v. So it will be 2m times v2 minus v. They both are in the same direction, so I don't have to worry. It's just a simple number subtraction. So it will be 2v over 3 minus v. 2v over 3 minus v is just negative v over 3. So the answer will be negative 2mv over 3. That should be the impulse, and let's see if this is in the options. Negative 2mv over 3. Yeah, 2mv over 3 is right here. They're asking magnitude, that's why there is no negative sign. Right. Two spheres of mass m and 4m are connected by a rod whose mass is negligible and the distance between the center of the spheres is d. 4m is now moved a distance d over 3 towards the small sphere. So how far is the center of mass for the entire object moved? Okay, initially this is m, and this is how it is, and this big guy is 4m over here. Luckily the rod is massless. Okay, this is d. We need to find the center of okay, we need to find how much it has moved. So first let's find the initial center of mass location. So initially the center of mass is located, let's take this as the reference. So let's say this is at 0. So it will be m times 0 plus 4m times d over total mass. I hope you remember the formula. Center of mass formula is m1 r1 plus m2 r2 over m1 plus m2, where r1 and r2 are the respective positions. Here r1 is just at 0 because we just assumed that this guy is the reference, and r2 with respect to 0 is just d. So m times 0 is 0, so I will have 4md over 5m, which is 4/5 of d, right? This is the radius of this, not the radius, the location of the center of mass. Now they're saying that this guy is moved d over 3 towards the small sphere. So towards the small sphere would mean that its new position would be somewhere over here. And if it is moved d over 3, then it is obviously at 2d over 3 distance, because this is d over 3. So this will be 2d over 3. So the new center of mass, let's call it, I don't know, RCOM dash, will be equal to still m times 0, but now 4m will become 2d over 3. Over the total mass is 5m. So it will be 4 to the 8, 8md over 3 over 5m, mm is gone. So it will be 8d over 5 times 3 is 15 using keep change flip. So this is the new center of mass. They are saying what is the distance between the two center of mass positions, or in other words, how much it has moved. So it will just be, I think, 4/5 of d minus 8d over 15. So over 15, 5 times 3 is 15, 4 times 3 is 12, 12d minus 8d is 4d. So it has moved 4d over 15 distance in the scenario. So it's option C. I hope this makes sense, right? It was a good question, pretty good question. Oh, another similar one. Okay, a dumbbell is composed of two spheres, connected mass levels, 2m, and okay, this is we do not know. The dumbbell can balance when the supports are 2d over 3 from the center of 2m, then what is the... Okay, that's on the easier side because they are just saying that the center of mass is right here, which is 2d over 3 from the reference point 2m. So what is this mass? So I can just take this as the reference, which is origin. So I'm just going to say that the center of mass, which I know, is m1 r1 plus m2 that I do not know. Let's call this, I don't know, x or maybe y. Y times its distance is obviously d over total mass is 2m plus y. So this will become 2d over 3 is equal to yd over 2m plus y. Sorry, 2m plus y. d is gone. Let's cross multiply. So 2 times 2m plus y is equal to y times 3 or 3y. Let's distribute 2. So it will be 4m plus 2y is equal to 3y. So 4m is equal to y, or y is equal to 4m. So that's what I'm looking for, right? The mass of the other object, which is 4m. So that's double of the left one. I mean, there's no need to do that. It's just 4m. That's our answer, option B, right? Okay, what is this weird option D? 2y over 2m? What is that? Oh, well, that's weird. Anyway, right, another center of mass question. The x location and mass of two objects are given as this. So this is origin over here. Let's call it 0, or x-axis, and this is 0. So this is at 1 meter and I have 3 kilogram, and then I have at minus 2 meters and I have 2 kilogram. There's 1 kilogram third object, and we need to find that what should be the location of this so that the center of mass of the entire thing is at -1 meters. So I don't really know. Let's say it is at x meters over here, and this is 1 kilogram. And remember that the center of mass is at -1 meters. So the formula is pretty straightforward, that -1 is going to be m1 r1 plus m2 r2. Obviously, this is my reference. This has to be my reference because center of mass is with respect to 0. Plus m3 r3 over m1 plus m2 plus m3. So -1 is equal to -4 plus 3 plus x over 2, 3, 5 plus 1 is 6. Cross multiply, -6 is equal to -4 plus 3 is -1 plus x. Add 1 both the sides, so x is -5. This means that I assumed to the right, which was wrong. It should be on the left at 5 meters. So it should be option A. That makes the perfect sense. Okay. A non-uniform rod of length L lying on the x-axis is a linear density of this. So what is the mass of the rod? dm, the mass as per the linear charge density, is given by lambda dx, where we integrate this from, well, 0 to L to the length of the rod, and this is 0 to mass of the rod. So left side will just become m. Lambda is ax square dx, and that is integrated from 0 to L. Integration of ax square is ax cube over 3 from 0 to L. So this will be a L cube over 3. That is going to be the mass of the rod. So option C is the best choice. All right. Next one. Consider an L-shaped object with the vertical legs extends from the origin to 0, 5, and the horizontal. Okay. It looks like it's something like this. So this guy is 3, 0, ends at horizontal leg here. This is 0, 5.
Assume that the object has a uniform linear mass density throughout. So what is the location of the center of mass? Interesting. Let's say the mass of 1 meter is m. Mass of 1 meter of this rod is, let's say, m, because they are saying it's uniform linear mass density. So for 3 meters, the mass must be 3m, and for 5 meters, the mass must be 5m. Now, what is the center of mass of these respective rods? For this one, obviously, it will be right at the center for both. So this will be at 1.5 comma 0, and this will be at 0 comma 2.5. So if I need to find the center of mass of these two pieces, then I'll just find the x coordinate of the center of mass as m1 x1. So m1 x1 plus m2 x2. x2 is just 0 over the total mass, which is 8m. That is the x coordinate of the center of mass, and the y coordinate likewise would be m1 y1. Here the y coordinate is 0 plus m2 y2, which is 2.5 over 8m. So let's find these values using calculator. Obviously m is irrelevant because it will cancel. 1.5 times 3 is 4.5. 4.5m over 8m is going to be 0.5625, because m and m is anyway gone. And likewise from here, this will be 12.5m divided by 8m, because this guy is just 0. And 12.5 divided by 8 is going to be 1.5625. M and m is once again gone. So 0.5625 and 1.5. Okay, there you go. Option B is the correct choice over here. Pretty good question. I hope you understand this. Guys, just a request: if you're liking this video, please like and subscribe. Please share it with your friends. It will help your friends, and it will also help me. And if you need private tutoring, feel free to reach out. A typical panda has a mass of 110 kg. A very rough model of a panda would be to approximate it using two spheres, one resting on the top of the other. The radius of the lower body is r, and the radius of the upper head is r over 2. So it's something like this. This is r, and right on the top of it there is another sphere that is r over 2. So this is r over 2, and this guy is r. The contribution, and by the way, this is the mass is given. Never mind. The contribution of all other parts of the panda is assumed negligible, assuming uniform charge density and, sorry, not charge density, uniform mass density, and treating the bottom lower sphere. This is y equal to 0. They are saying this is the reference. What is the vertical center of mass of the panda? Okay, pretty straightforward, I think. The mass is already 110 kilograms. So I think the idea is to find the individual mass, right? That is the concern over here. Since we know that this radius is half and this is r, so here we need to figure out the volume of this, right? Because these are spheres, so this will depend on the volume. So this is 4 over 3 pi r cube, and this volume is 4 over 3 pi r over 2 cube. This can be written as 4 over 3 pi r cube over 8. And another way to write this is, let me erase this thing or move it to the right side. This is just 4 over 3 pi r cube. This 1 over 8 can be written out in the front. So 1/8 times 4 over 3 pi r cube. This means that if the bigger one has a mass of m, the smaller one is just 1/8 of this guy, 4 over 3 pi r cube, which is just m. So this is very important, how the mass is distributed. So m plus 1 over 8m is 110. So 9 over 8m is 110. So 9m is equal to cross multiply 880. So m is somewhere around. Honestly, that's not even required. I don't even know why I'm doing that, because this is irrelevant, because it will eventually cancel. You will understand what I mean. So this is not required. I just need m and m over 8. What is the center of mass of this m? It is obviously 0 comma r. And what is the center of mass of this guy? Be careful. It will be r plus r plus r over 2. So r plus r plus r over 2 is 2r plus r over 2.
which is 5r over 2 or 5 over 2r. So this is 0 comma 5 over 2r. So obviously the center of mass will be mass times r plus m over 8 or 1/8 m times 5 over 2r over the total mass, which is just m plus m over 8 is, I think I did that earlier. M plus 1 over 8m is just 9 over 8m. So 9 over 8m. This can be written as m times r plus, 5 over 16 times mr over 9 over 8m. Now, if you notice carefully, if I take m as a factor from the top, I'm left with r plus 5 over 16r, and here I'm left with 9 over 8r. So 9 over 8m. So you see this m is gone. That's why I was saying that there's no need to bother about the individual masses, just the proportions help. R plus 5 over 16 or 1 plus 1 over 16 is 21 over 16. R remains as it is, and this is 9 over 8. That's where my calculator comes in. So I'm getting this as 1.1667 R, approximately 1.2 R. 1.2 R, yes, guys, 1.2 R is definitely here, which is option B. It was a very, very good question. I will accept that this is slightly difficult, but yeah, I hope you understand. If you're doing physics C mechanics, be prepared for such questions, and that's where you're going to take an edge over the other students, right? Your 2 kilogram pet cat drops down towards you from a shelf. You are located at y equal to 0 and can be approximated as 60. The cat starts from rest at a height of 2 meters. When will you, cat system, will have a center of mass height of 0.01? Okay, remember, cat is changing its x coordinate as well, but I do not care about that because I'm just asking, they are just asking the y coordinate of the center of mass, right? The height. This is at 0, and this is 60 kilogram. This is 2 kilogram, and they're asking that when will you, okay, when means they are talking about the time. And cat starts from rest at a height of 2 meters, guys. This is 2 meters over here. So I need to find what is the y coordinate of the cat, correct? When this is the center of mass, 0.01. So I'm just going to say that 0.01 will be equal to mass of the boy times 0 plus mass of the cat times some y that I need to find over the total mass, which is 62. Cross multiply, this will become 0.62 is equal to 0 plus 2y, which is just 2y. So y is coming as 0.31 meters. So that is the height, right? This is 0.31 meters. But I need to find the time. So they are very clever here. They are mixing a free fall with a momentum question. So it means that cat must have fallen 2 minus 0.31. Can we agree on that? Right? Which is 1.69 meters. The question is, how much time will cat take to fall 1.69 meters? I'm going to assume that it starts from rest, and I'm going to use the second equation of motion, which is delta x is equal to v initial t plus half gt square yg, because this is a free fall. So this is 1.69, v initial is 0, gravity, let's call it 10, and time I do not know. So 1.69 is equal to 5t square. So 1.69 divided by 5 is t square. So square root of 1.69 over 5 is t. So t is approximately 0.58 seconds, which has to be option D. Again, guys, a very good question here. I hope you understand what I did. Okay. Guys, this may look a little difficult, but it's not. They are saying that this M initially with V collides with a stationary thing. Spring is massless. And after collision, obviously spring is compressed, then expands, and then M again moves to the left and 3M moves to the right. So what is the final velocity of the center of mass?
Now, you must be wondering that if I need to find final velocity, then I need final velocities of these two people, and then they don't have enough information. But the idea is, since F net is 0, so acceleration net is 0, which means that the acceleration of the center of mass is 0, which means that velocity of the center of mass is constant. So even if I find the velocity before the collision, that should be same as the velocity after the collision. So V center of mass is, I know, m1 v1 plus m2 v2 over v1 plus v2. Sorry, m1 plus m2, not v1 plus v2. So m times v, the 3m is at rest, so 3m times 0 over 4m. So the answer is mv over 4m, which is going to be v over 4. So velocity of center of mass is just v over 4, which is going to be option A. Right. Looks like a similar question that we did earlier. Uniform rod bent L shape, what is the coordinate of the center of mass? Okay, so this guy is x coordinate is L over 2, y is 0. This guy has x coordinate L and y L over 2. Equal length, uniform, so mass m, let's say, for both. So x coordinate of the center of mass will be m times L over 2 plus m times L over 2m. ml over 2 plus ml is basically half plus 1 is 3 over 2. So 3 over 2 ml over 2m. mm is gone. So 3 over 2 is just 3 over 4l. So that's the x coordinate of the center of mass. For the x, so 3l over 4. Fortunately, that's just an option B, but I'm still going to solve the y coordinate for you. That will be m times 0 plus m times l over 2 over 2m. So that's just ml over 2 over 2m. mm is gone. And L over 2 over 2 is just L over 4. So that's the y coordinate of the center of mass. And obviously the answer is just B. Okay. A 30 kilogram child is standing on one end of a 6.5 kilogram surfboard that is 1.9 meter long. Surfboard is motionless on a waveless pool before the child walks to the opposite end of the surfboard. So they are saying that this kid is over here. This is 1.9 meters. And this guy is 30 kilogram and the surfboard is 6.5 kilogram. He moves to the other end of the surfboard. Now he comes here. So how far surfboard move relative to the water if friction is negligible? Right, guys, so since the F net is 0 because there is no external force and internal forces cancel each other, which means that acceleration of the center of mass must be 0. Since initially they were at rest, so the velocity of the center of mass should always be 0. So the center of mass position should be unchanged. What is the initial center of mass? So R, let's call it, I don't know, RCOMI will be equal to 30. Let's call this point as 0. Will be 30 times 0 plus 6.5 times. Since this is a 1.9 meter rod, so the half of 1.9, whatever that is, I think that's 0.95. Divided by the total mass, which is 36.5. So this is nothing but 6.5 times 0.95 over 36.5. So that's going to be the initial center of mass. Now we'll find the final center of mass. So here we have to be very, very careful. Let's obviously the board should move to the left. Let's say it moved left by x units. So its new center of mass will be 1.9 minus x. This guy moved 1.9 right, but relative to the surfboard. So relative to the water, since this is going left by, a surfboard is already going left by x. So this guy will eventually move 1.9 minus x to the right side. So the new center of mass, RCOMF, is going to be 30 times 1.9 minus x plus 6.5 times 0. Sorry, I wrote 1.9. That is not correct. It should be 0.95 because the center is 0.95. So 0.95 minus x over 36.5. And the green and the red guys should be equal because the center of mass is not going anywhere. So I'll just equate them. 6.5 times 0.95 over 36.5 is equal to, okay, I'm not going to write that again. I hope you understand what I meant. I'll just extend probably just on this box that this should be equal to 6.5 times 0.95 over 36.5. And all I need to do is plug in this or solve this using the graphing calculator, which will give me the value of x somewhere around 1.56 meters, or minus, not minus because I already taken minus into consideration. So 1.56 is 156 centimeter, which is option C. Velocity of, well, depending on time. Initial angular displacement is 0. Which of the following best corresponds to the angular displacement of the object after 5 seconds? So this is a classic C mechanics question, not AP Physics 1 question, because this involves integration. Okay, we know that omega is d theta over dt, or if we do not know, we should know that omega is d theta over dt. So omega dt will be equal to d theta, and omega is, let's flip the omelette here. So d theta will be equal to omega dt. Omega is 5t plus 3 dt, and now I'm going to integrate from 0 to 5 seconds, and this I'm going to integrate because the initial value is 0 to some angle theta. Then of course the integration of d theta is theta, and I'm going to plug in the bounds from 0 to theta here. Here the integration will be 5t square over 2. Obviously you can use your calculator or Desmos to just get the numbers quickly, but I'm just doing it. It won't take much time. So upper bound is 5 square is 25, 125. So it's 125 over 2 plus 5 times 3 is 15, minus the lower bound. If you plug in, is just 0, guys. So if you add these two people, you are going to get 77.5 radians, not degrees, because it's SI unit and everything is in SI. So the answer should also be in SI unit. So it has to be option B. Okay, by the way, guys, why are we applying the calculus here? Why not the equations of motion? Because omega is again dependent on time, right? Whenever omega is a function of time, it's not a constant value. So we have to use integration in such cases. Okay. A disk of radius this initially at rest starts spinning with a constant alpha of 2. What is the linear speed of the outer edge after rotating through 25 radians? So linear speed is dependent on omega, right? Because we should know that this is a very important formula, that d is equal to omega r. Our job, we already know radius, by the way. It is 0.25. So this is the v. But we don't really know omega at the end of 25 radians. So that's what we can find. It starts from rest, so I think I'm going to use the third equation of motion probably. Omega final square is equal to omega initial square plus 2 alpha theta. So let's sub in the numbers here. Omega final is what I need to find. Omega initial is 0, alpha is 2, and theta is 25. 25 times 4 is 100, so omega final square is 100, which means that omega final is just 10. We're going to sub in that 10 over here, so we're going to get 10 times 0.25, which is just 2.5 meter per second. So that is the velocity of the the point on the outer edge of the disk. Right, I hope this makes sense. An object rotates with omega this. What is the alpha? When will the angular acceleration, or is alpha of the object 0? That's also based on calculus, guys. I hope you know that alpha is d omega over dt, just like acceleration is dv over dt. So we need to find the derivative of this guy. So 15t squared differentiation is 15 times 2t, minus differentiation of 30t is just 30, and that's alpha, which is 30t minus 30. I want alpha to be equal to 0, which means that 30t minus 30 should be equal to 0, which means that 30t should be equal to 30, which means that t should be equal to 1. So that is the time when the alpha of this object is 0. All right. Assuming an axis of rotation through the center of the ring perpendicular to the page, it means that it is usually represented by a cross. It's fine if you do not know this nomenclature. It's mostly used in E&M, but cross just means that it is going into the page, right? And dot means it is coming out of the page. So there is basically this is the axis which is going into the page. That's the point of drawing this cross. What is the rotational inertia of a ring of mass m and radius r about point P? Okay, now we have to find the rotational inertia about P, not about the center of rotation. Here, C. The moment of inertia about its center is mr squared. So here we need to use something called parallel axis theorem. Parallel axis theorem. And parallel axis theorem suggests that I through any point, any other point that is parallel to the to the to the axis that is passing through the center of mass. So I through any other axis is same as I center of mass plus m times L square. I'll explain what this means. I center of mass means the moment of inertia of that thing through the center of mass, which is given in the question as mr square, and m is again mass, and L is the distance of the new point and the distance between the new point and the center of mass, which in our case um, is just the radius, guys. So I'm gonna put r over here, so that's r square. So mr square plus mr square is 2mr square, and yes, it looks like the correct choice is option E. Right. Over here we are given that the disk shown is in both rotational and translational equilibrium, which statements about the forces acting on this disk is true. Okay. Uh, Rotational and translational equilibrium means the net force is 0, which means that well, F1 and F2, F1 should be equal to F2 plus F3. That is for sure, as something that I know from the translational equilibrium. But from the rotational equilibrium point of view, the torque about this point should be 0. Now, if you notice carefully, F1 is acting along the, its axis is along the center. So even if I want to find the torque due to F1, that's going to be 0, because the torque is going to be F1 times R times sine of theta. Force is going to the right. The R is also going to the right. So the angle between them is 0 and sine 0 is 0. So this is not really providing any torque. Yes, this is providing a torque because this is at 90 degree to the center. So that's going to be F2 times R times sine 90, and sine 90 is 1. So I'm not writing the sine 90 here. Let's call this torque 2, and the torque 3 is going to be likewise F3R sine 90. Again, I'm not writing sine 90. And this is trying to rotate in counterclockwise sense, and this is trying to rotate in clockwise sense. Since this is in rotational equilibrium, I want these two guys to counter each other. In other words, I want tau 2 and tau 3 to be equal, which means that F2R should be equal to F3R, RR gone, which means that F2 and F3 must be equal. So F2, and there you go. Option D, that is the correct choice. I hope this makes sense. Okay. A solid sphere, a thin hoop, and a thin hoop is basically also a ring. That's what is a thin hoop. And a solid cylinder, uh, all rolled down an inclined plane from rest. All three have mass m, radius r, and all start at the same position on the ramp. Which of the following correctly describes the order in which they would reach the bottom of the ramp? Alright guys, this is a really popular question, and very much likely that it can appear in your school quizzes, exams. It can appear in AP as well in some form. I'm going to show you approach, and then I'm going to recommend that try to learn the analogy that we are going to draw. Okay, the idea is obviously they have different moment of inertia. Just to be specific, the solid sphere's moment of inertia is 2/5 mr square, hoop is mr square, and solid cylinder is 1/2 mr square. So to be specific, this one is 2 over 5 is 0.4, this is 0.5, and this is obviously 1. So moment of inertia of hoop is more than sphere is more than cylinder. I think we agree on that. A sphere, sorry, cylinder is more, right? 0.5 and 0.4. Yeah, sorry. Cylinder is more than sphere. Okay, we agree on that. That's important. Now, everything starts from here, and remember, they all are circular in nature, they all have a radius of r, and they all travel the same distance. So we know that whenever they reach at the bottom, their theta is going to be same. So their theta is going to be same, and remember, they all start from rest. So I'm going to use the second equation of motion, which is omega initial t plus half alpha t square. Omega initial is 0, theta is anyway same for all. So this is the first equation that I have. And remember, I'm interested in time. So 2 theta over alpha is t square. I hope you understand what I did here. I just performed a literal equation and isolated t. Remember, I don't need to find t. I just need to find a relationship between t and alpha, which is inverse relationship, which clearly means that more is the alpha, less is the time, and it will reach faster, less in less time. So that's the first relationship that I want. Okay. The next relationship is I'm going to use is omega final square is omega initial square plus 2 alpha theta. Omega final square is equal to 0 plus 2 alpha theta. Remember, theta is a constant, and this means that alpha, let's flip the equation. So 2 alpha theta is equal to omega final square, which means that if theta is constant, more is omega, more is alpha, right? So more is alpha, more is omega. So I got the relationship between alpha and time, and then alpha and omega. So clubbing these two relationship, do we agree that so this means that if alpha is more, omega is more, and time is less? We agree on that, right? Because alpha more, omega more, and alpha more, time less. So these three are related like that. Now, how do we find the relationship between omega and t using energy conservation? So I'm going to conserve energy at the top. I don't know the height. I don't even have to know. I know that it's same. So initial potential energy is mgh, which is same for all. And then final energy will be half mv square plus half I omega square. Half mv square plus half I omega square. Okay, this means that mgh is equal to half m. V is omega r, guys. I hope you know that this is a pure rolling case. So even though they have not written it anywhere, but yes, this is a pure rolling case. There is no slipping. So V is omega r, omega square r square plus half I omega square. Sorry, I'll just zoom out a little. Okay. This means that if I take omega out, mgh will be equal to omega square out. I'm left with mr square over 2 plus I over 2. Right? No need to simplify anything. Now, guys, everything is same for all the objects. These things are same, these things are same, these things, except I. And that's why I wrote this. So don't we agree that these are inverse relations, right? Because this entire thing is going to go, come down in the denominator, which means that more is the moment of inertia, omega is less, correct? Because more is the moment of inertia, the denominator will be more, because this entire thing is, I'll just write that equation for you guys if you are confused with this. It's just going to look gross. So omega square will be equal to mgh over mr square over 2 plus I over 2. I hope you understand now that if I is more, denominator is more, so omega is less. And how is I related? I of hoop is greatest. So greatest I means least omega. So omega of hoop will be less than omega of cylinder, will be less than omega of sphere. And how are omega and time related? Inversely, if omega is greatest, time is the least, which means that the time of hoop is greater than time of cylinder is greater than time of the sphere. So this is the relationship that we are looking for, and they are saying that which of the following, how will they reach? So minimum time is for the sphere, so it will reach first. So first is sphere, then cylinder, and then hoop. I think this is option D. I'm not asking you to mug anything up, but yeah, the process is important. But if you can understand that more is the moment of inertia, more is the time, then definitely you're going to save, some effort in your actual exam. But yes, if you have to show work, then yeah, of course, this is really important, and that's how I'm drawing the conclusions. Right? I hope this makes sense. Okay. A square mass is acted upon by three forces with the third unknown force. Okay, this guy is unknown. What must be the magnitude so that it is an equilibrium of all kinds, translational and rotational? Uh, Fair enough. Let's make the components first. So this is F. Okay, we don't know what this is. I don't really know what to call it. F is already taken. So let's call it Y. This will be y cos 30, and this component will be y sine 30. Let's put this in translational equilibrium first, which means that these two guys should counter each other. So y cos 30 should be equal to 2f, which means that y root 3 over 2 should be equal to 2f, I think, which means that y root 3 should be equal to 4f, which means that y should be equal to 4f over root 3. And let's try to see if when will these two reach equilibrium, because they should be equal and opposite. So that's how it is. Sine 30 is 1 over 2, 2f, y is 2f. So I don't think so that's possible, because this will reach equilibrium at some other point. This will reach equilibrium at some other point. So actually there is no such value where it can reach translational equilibrium. I mean, forget about the rotational. Translational is not even possible. So I'm not even bothered about the rotational. Should be option E. Right, what is the rotational inertia I of a uniform rod of mass and length 2L about an axis through its center and perpendicular to its length? Um, uh, the axis, I don't know, guys, if you have memorized this. Uh, my goodness, that's so difficult to make. Okay, finally. Um, about the center of mass, the moment of inertia is given by 1/12 ml square. The only difference is the length now is 2L. So I'm just going to replace that by 2L. So that's going to be 2L whole square, which is going to be 1/12 m times 4L square, which is going to be 1/3 ml square, which is going to be option B over here. Okay. Two masses of M are connected by a rod of length L. If both the masses and the length of the rod are doubled in size, what is the value of the new rotational inertia I knew in terms of the old rotational inertia about its center of mass? Okay, the rod is massless, guys. That's given in the question. I'll just add it over here. Rod is massless. Okay. So the initial situation is this is what we have here, and we have M over here and M over here, and they are separated by L, and we need to find the center of, rotational inertia about the center, which means that this is L over 2 and this is L over 2. So in this situation, what is the moment of inertia? It's just 2 times. Why 2 times? Because there are 2 of these, and moment of inertia for a point mass is mr square. So M and r is L over 2, so L over 2 square. So this will be 2 times m times L square over 4, which is ml square over 2. That is the moment of inertia. Finally, the rod is doubled right? It's double in size. So this is 2L, which means that each mass is L units from the end. So this is also, and the masses are double, by the way. This is 2m and this is 2m. So the new moment of inertia is going to be 2 times m, which is 2m, and Lr square, which is L square. So this will be 4mL square. Now, if we cross multiply, then 2I is ml square. And this ml square, I'm going to sub in over here. So this will look like 4 times 2I, and 4 times 2 is 8I over here. So the new moment of inertia is 8 times the old moment of inertia. Right, guys, over here we are given, I think that is, yeah, rotational equilibrium question. Just by looking at it, I can figure it out. A 2 kilogram mass is placed with its center of mass at 10 centimeter to the left of the fulcrum uh, on the balance beam. Right, guys, I think this figure will make more sense. That was a little confusing. So we have a couple of masses here, this one, this one, this one. The distance is given, this is the fulcrum. And we need to figure out that what is the value of this small m so that the system is in rotational equilibrium. This is all about balancing torque, guys. I hope you know this concept. So we have FBD as 2G over here, mg over here, and mg over here. So the torque due to the left one, and this is my pivot, by the way. The torque, and of course, there is a normal reaction at the pivot, but that's not really providing any torque, on the pivot. So I'm not really interested in that. And remember, they are only saying rotational equilibrium. They're not saying translational equilibrium, so I'm not worried about that. So for rotational equilibrium, I'm going to say that the torque due to this 2G about this point, the force of the torque, the formula for the torque is RF sine theta. R is 10. I'm not bothered about converting into centimeters because everything is in centimeters, so it's going to balance. So R F sine 90 because it's downward and this is right, so that's 90, and this is providing the torque in counterclockwise sense, so that should balance the torque due to these two small m that are trying to move in clockwise sense. So it will be mg or rf sine theta, so r f sine 90, once again I'm not writing that, and then again r f sine 90. Okay, so this will become 20g on the left side. This will become 40 mg plus 70 mg. So this will become 20g is equal to, I think, 110 mg. Gg is gone. Dividing both sides by 10, this is also gone. So I'm left with 2 is equal to 11m. So 2 over 11 is the value of mass. So this one comes out as 0.18 kilograms. So I think the best choice will be option B. Right, guys. The next one is a massless meter stick is in equilibrium about its center point. If a 50-gram mass is placed at the 30 centimeter mark and a 75-gram is placed in 70 centimeter mark, where must a third mass of 50-gram be placed to keep the system in equilibrium? Okay, so the meter stick is obviously the markings will start from 0 to 100 centimeter. I'm writing centimeter because they have given the markings in centimeter as well, and this is the starting point. And let's say this is 50 centimeter, and about this it is supposed to be balanced because this is the center point. And they are saying that there are two guys already sitting here at 30 centimeter mark. So there you go, we have a guy sitting here which is 50 grams, so 50 grams over here, and there's a guy at 70 centimeters which is 75 grams. Okay, 75 grams, and this is 30 centimeter, and this is 70 centimeters. So they are saying where must the third mass of 50 gram be placed so that it is in equilibrium over here. So again, the rotational equilibrium concept First, we'll try to figure out that where is this trying to rotate, right? So this is 20 centimeter, of course, and this is also 20 centimeter. So obviously it makes sense that since this is heavier, it will try to rotate like this, which is clockwise. So if I want to balance something, I obviously have to obviously have to place a mass that is on the left side of the 50 centimeter. So let's call this mass m, and let's call this distance x. Okay, now the torque due to this one is going to be mg. It's the same thing, right? Rf sine theta, theta is 90. So this is the gravity force, this is the gravity force, this is the gravity force. Again, I'm not bothered about converting grams to kilograms because, and centimeters to meters, because everything is going to nullify. It's the same. So it will be R, which is 20, F, which is 50 times G. Remember, this G is not the G of grams. This G is the gravity, mg. And sine 90 is 1. Plus distance x that I don't know. Mass m that sorry, mass m I know, right? Oh my God, that is 50. I am really sorry. So this guy is 50. Okay, excellent. So this guy is 50 over here. So this is 50G then. Excelente. So this one will be over here again, RF sine theta. So R is 20, F is 75, G and sine 90 is just 1. I'm not bothered about that. Okay, guys, lots of things are, I think, going to cancel out or simplify. So this will be 50 times 20 is 1000 G, and this will be 50 GX, and this will be 75 times 2 is 150, so 1500 G. Let's subtract 1000 G from both the sides. So this will become 500 G is equal to 50 GX. G and G is gone. Divide both sides by 50, so I'm left with 10 centimeter. But be careful, the answer is not option A, because they are asking the marking, at what marking it should be placed. So a 10 centimeter from the 50 centimeter mark is basically a 40 centimeter mark on the meter scale. So the answer is option B. Just be very careful. That was a pitfall, but yeah, that's what they are asking. All right. A non-uniform rod of length L and a total mass M swings from a pivot P. The center of mass is located at 2L over 3. Okay, this is 2L over 3. What is the magnitude of the torque on the rod when it is displaced by an angle of theta? Well, really, isn't that just mg acting over here? And this is the theta, and I need to figure out, obviously this is 2L over 3 because that's also given to us in the question. This is at a distance of 2L over 3. So my answer is RF sine theta. The only question is, what is the angle between R and F? Isn't that theta? Yeah, I mean, it looks like theta, right? Because these two are parallel. This is a transverse, guys. I hope you remember geometry. So these are corresponding angles. So this one is also theta. And this is my R line, and this is my F line. So the angle, obviously you might be wondering that why we should not take this angle. You can, I won't really mind, but it will give you the same answer because this is 180 minus theta, and sine of 180 minus theta is same as sine theta. So my recommendation is always take the acute angle. So here the torque is just going to be R, which is 2L over 3, F, which is mg, and then sine of theta, which isn't that just option E? Yeah, I mean, maybe they were trying to trick us with the theta or something angle. I don't really know, but that looks like a straightforward question. Yeah, okay. Oh my goodness, what the hell? Okay. A sculpture in the sketch has 4 identical beads that are spaced at even intervals across a solid 3-meter pipe. Okay, I understand that beads are solid with uniform density. They each have a radius 16 centimeter and mass 5 kilogram. Oh my god, the pipe has a mass of 20 kilogram as well. The pipe reaches from the center of the leftmost bead to the center of the rightmost bead. Okay, fair enough. Determine the rotational inertia of the sculpture about an axis of rotation perpendicular to the sculpture as shown in the sketch. Okay, what object is this? They are solid with a uniform density. Okay, so I think they are solid spheres, of course, right? Solid spheres. So solid spheres means I am talking about this over here. Okay, and then we do not really have any point mass over here. We have excessive rotation. So this is a solid rod, I think, and solid rod about the center. That's what we are looking for, because this is a solid rod and this is the center. Fair enough. And this is the more, okay. All right, excellent. So I think we need to use a parallel axis theorem as well. Okay, I think we are first going to start with calculating for the solid rod, because that looks the easiest. So it will be 1/12 mass of the rod, which is 20, and length of the rod, which is 3 square. So that's just 20 over 9. 9 times 2 is 18, 180 divided by 12. 12 times 1 is 12, 12 times 5 is 60. Okay, so that's a happy number. 15, that's for the rod. Let's keep it aside. Now let's find a sphere. So I think I need to find these two, because I can just multiply by 2 as they are symmetrically placed. I know that this is 1.5, right? I know that very well. And what is the moment of inertia about the center of this solid sphere? The center of the solid sphere is going to be, it's written over here, 2/5 mr square. But unfortunately, I need to use the parallel axis theorem here, because that is not really, the axis is here, not here. So it will be I for the most left is going to be 2/5 mr square plus m times this distance square, which is 1.5 square over here. So I for the most left is going to be 2/5, and one ball is of what was that? 5 kg, right? 5 kg. Radius really matters. You need to convert in meters over here. So it's 0.16 square plus 5 times 1.5 square over here. That's how it works. So let me find that. This one comes out as 11.30 kilogram meter square. And we need to find I for this one. I don't know, let's call it I2, and let's call this one as, this is already I left. So I2 is also going to behave in a similar fashion. It is 2/5 mr square plus m. The only difference is, what is this? All right, so for this length, we have to be very careful, because this is again some geometry involved here. If you know, if you divide this entire situation in some blocks, for example, I'm drawing vertical lines at the center of each sphere. Now you understand that each of these pieces are equal, right? Because there are 1, 2, and 3, three gaps. 3 pieces will make it 1. But keep in mind that this entire thing is 1. But I just need the half of it. So this will be 1/2 square, right? So if we plug in the numbers, it will be 2/5 to 0.16 square plus 5 times 1/2 square. So this number comes out somewhere around 1.3 over here, right? So now our final answer will be the red one, plus twice of the green one, because there are 2 such blocks, plus twice of the blue one, because again there are 2 such, I mean spheres, not blocks, yeah. So this comes somewhere around 40.2, which is option B. Definitely it was a little challenging, because there was physics along with the geometry involved, but yeah, that's how we solve this question. Okay. For an object with a moment of inertia of this, angular displacement this, what is the net torque? Pretty straightforward, guys. The torque is what? I alpha. They are so kind to give us moment of inertia. And alpha, since this we have a theta over here as a function of time, I think you understand we need to use calculus. So alpha is given by what? D omega over dt. but they are making us go one step further because we are given theta. So first we need to find omega, and omega is d theta over dt. So the derivative will be, I think, 6t square minus 10t, that's omega. And another derivative of omega that we have to sub in over here will be 12t minus 10, that is the torque. They need at 5 seconds, so all I have to do is replace t with 5. So 12 times 5 is 60, 60 minus 10. 60 minus 10 is 50, and 15 times 5 is 75 with a 0 and Newton meters. So yes, perfectly, this is option D. That should be our answer. Yeah, I hope that makes sense. All right. A solid disc roller is pulled with a force F. What is the minimum force of friction required to keep the disc rolling without slipping? So that's an idea of pure rolling over here. Okay. Let's say the friction, obviously, where will the friction act, by the way? It has to act backwards because see, this force is not really providing any torque because it is acting along the center. It is only providing a V towards the right side. So if this guy has to perform pure rolling, and remember that pure rolling means the bottommost point is at rest, and this point already has a V towards the right side, it makes absolute sense that omega should be directed like this, so that at point P, the omega r is pointing to the left and v is pointing to the right, and these two can be equal and it performs pure rolling. So that's the reason why friction should be backwards, so that it can provide the necessary torque so that this guy rotates clockwise. All right, now I need to figure out that what should be the minimum force. Okay, all right. I know that V is equal to omega r. That is supposed to happen because that is performing pure rolling. I also know that, and also for pure rolling, we know that the acceleration, the linear acceleration, and alpha are also related in a similar fashion, that acceleration is alpha r. Okay, I'm more interested in the acceleration because, forces and all are given and I can relate these guys. So the translational equation as an F net equal to ma will be F minus F is equal to ma. We don't know m, it's totally fine. That's the first equation. And the torque is provided by the friction. So Fr, Rf sine theta, or I can write Rf, but that's same. And theta is 90. That should be equal to I alpha, correct? Do we know the moment of inertia? Yes, this is a solid disk. Solid disk is half m r square alpha. R is gone. So from here, the friction comes out as half m r alpha. Okay. All right. I think I want to find the value of A and alpha so that I can plug these guys over here and solve for friction. That's my aim. And this R is, by the way, capital R. So let me just replace that. So from the first green guy, can I isolate A by dividing both sides by M? So this is acceleration. And from here, I'm going to multiply both sides by 2. So 2 times friction is equal to mr alpha, and divide both sides by mr. So that's alpha. And these two guys I'm going to sub in over here. So acceleration is going to look like F minus F over m. And alpha is going to look like 2 times friction over mr times r. R gone, M gone. So F minus F is equal to 2F. So F is equal to 3F. So F over 3 is the friction that we are looking for. So yes, answer is option B. Pretty good question, pretty decent question. Absolutely something that can appear in your exams, etc. So yeah, I hope you understand. Guys, I hope you're liking this video so far. If you are, please like and subscribe. Please share it with your friends. And if you need private tutoring, feel free to reach out. All right. A solid disk of mass m and radius r is free to spin about a center is pulled by a string. Given the rotational inertia is half mr square, what is the alpha? That's pretty straightforward, guys. Because the I know that mg is acting downwards, but the poor mg cannot provide torque because it is acting at the center of mass. Only this tension can provide the torque. Its distance from the pivot is r and its angle is 90. So the torque is given by r f. So r is r, force is t, and sine 90. So the torque will be tr. And torque is also equal to I alpha. We know that. So TR is equal to I is given in the question half mr square and alpha we are looking for. So R is gone. Multiply 2 both the sides. So 2T is equal to mr alpha. Divide both sides by mr. So 2T over mr is alpha, which is option B, 2T over mr. Okay. This one is something similar, I think. They are saying that a string is wrapped around a pulley of mass m, rotational inertia I. The string is pulled by a constant force F. What is the angular acceleration? I think that is the same thing because this is F now, and this is, I think, almost the same approach. So the torque is gonna be F times R over 2 times sine 90, which is just 1, is equal to I alpha, and I is just I, and alpha I do not know. Divide both sides by what do you call it as I. So the answer is FR over 2I, which is alpha, which is option B, I think. Yeah. Oh, well, that felt like a bonus question. It was pretty easy. Okay. Over here, two blocks of mass m are connected by a rod of negligible mass, and the length of the rod is 2r. The rod is mounted on another light rod of radius r. Okay, so this is one rod. This guy is massless, and this is another rod over here, which is of radius r, right? Okay. The string is wrapped around a vertical rod, is pulled by a fixed force F. What is the angular acceleration of the system? All right, okay, fair enough. So the angular acceleration of the system obviously depends on the torque and the moment of inertia. The first things first, this is the pivot. So what is the moment of inertia of these guys? Obviously, it's r distance apart. So it will be mr square times 2 because there are two of these kinds. So this is the total moment of inertia. And what is the torque due to this force? I hope you are able to visualize. I can give you a top view of this. A top view will be, this is the rod of radius r, right? And the force is trying to act tangentially over here. So once again, the torque is going to be just Rf sine 90, and sine 90 is 1, and this is equal to I alpha. That's how it works. So Rf is equal to 2mr square alpha. Okay, notice that these are different radius, right? This is small r, this is capital R. So the idea will be, the answer will be fr over 2m capital R square. That should be our alpha, I think. Yeah, that should be option D. I hope they are not trying to trick us here. That should be the answer. Yeah, if you feel the answer is different, just let me know in the comment section. Okay. Right, guys, this is a pretty good question. We are given a torque versus a rotations graph over here, and the moment of inertia is given, and we need to find that what is the omega at t equal to 2 if it starts from rest, and the graph is from 0 to 2 seconds. Like this is all the rotations, but they also tell us that at 2 seconds this is the behavior, and by the way, this is 1.5 as you have figured out already. This is based on work energy, guys, because we should know that the area of the torque versus theta, although it is not theta, in a way it is revolutions, but I can convert revolutions easily to displacement by multiplying with 2 pi. So I'm going to do that, and I'm going to find the area under the curve, which is literally just a triangle. So the area is going to be half base, which is not 2, it will be 2 times 2 pi, because I need to convert in radians, times height. Height is 8. So this is 2 gone, so this is 16 pi. And we very well know that area is the work, and work done by all forces is change of kinetic energy. That is the work energy theorem. Work is 16 pi. Final rotational kinetic energy is just half I, which is 0.0025 omega square, that we do not know, minus 0 because it starts from rest. So multiplying to both the sides, that's 32 pi, dividing by 0.00625 is this, which is omega square. So from here, the value of omega comes out as, sorry, this is not 625, this is just 25. So if I plug everything in, I'm gonna get omega as somewhere around 200.53 radian per second, which looks like option B. That should be the correct choice. Right, I hope this makes sense. Let's try the next question over here. Right, this is a pretty straightforward conceptual question. They're saying there's a small piece of space junk that is at rest in outer space. A very small asteroid strikes it, exerting a force on it that is not directed through the piece of space junk's center of mass, which means that it is providing torque. Which of the following describes the motion of the piece during the asteroid strike? So obviously, if this is that piece and this is the center of mass, and if the force is somewhere over here, obviously it is going to rotate it because this is not along the center of mass, so it will spin. And it will also provide a linear acceleration because there is a net force acting on it. So yeah, it's option E. Pretty straightforward, I think. Okay. A 15-gram meter stick is placed horizontally onto a fulcrum located on its 30-centimeter mark. The meter stick can be treated as a thin horizontal rod where the moment of inertia is this. What is the angular acceleration caused by its weight upon release from rest? Okay. So this is the meter stick that we are looking at. This is the 30-centimeter mark, guys, and this is 15 grams. So obviously this is the 50-centimeter mark, and this is the 15, this is the mg over here. uh, we are given the moment of inertia about the center, which is here. So be very careful because the pivot this time is over here. So I need to find the moment of inertia about this point using the parallel axis theorem. The rest is pretty straightforward because this is just mg is providing a torque, so we will use mgr equal to I alpha. So that's not really a problem, but yeah, let's find I first. So I, using the parallel axis theorem, will be equal to I center of mass, which is 1/12 ml square, plus m times this distance square, which is 20 centimeter. But be careful, this will be 0.2. So it will be 1/12. M is 0.015. Again, everything should be in SI units. Meter stick is 1 meter, of course. M is again 0.015, and this is 0.2 square. So this number comes out as, okay, that's a teeny tiny number, guys. It's 6.1875 times 10 to the negative 4. I'm not bothered about the unit here. So that's in SI units of I. And we are trying to find alpha. So I know that torque is equal to I alpha. Torque is mgr is equal to I alpha. I alpha will be equal to mgr. So alpha will be equal to mgr over moment of inertia. I think we know everything. Mass is 15 grams, so this is 0.015. Gravity is, I don't know, let's take 9.8, not 10. R is, remember, is 20 centimeters, so I'm going to take it as 0.2. And then this 6.1875 times 10 to the minus 4 is the moment of inertia. So this all comes out as, I'm gonna switch the gravity to 10 because I think that's that's how they want us to do. And if we use that, we are gonna get somewhere around 48.5 around. So I think 49, right? Somewhere around 49. That's what I'm gonna say as my answer, which is also matching with the options. This is in radian per second square. So that's alpha, which is option E. Right, I hope this makes sense. Okay. Wheel with the rotation ensure I begins spinning with omega. A brake is then applied, and after the wheel makes one complete turn, it comes to a stop. So the following values best estimates the magnitude of the average torque exerted. Okay, for the average torque, I need alpha, right? So mm, I know that omega final is 0, omega initial is omega, theta is one complete turn, so 2 pi, and alpha is unknown. I think the equation omega final square is equal to omega initial square plus 2 alpha theta makes sense. Omega final is 0, omega initial is omega, alpha I do not know, and theta is 2 pi. Okay. Yes, it will come negative omega square, but we know that alpha has to be negative in nature, so that's why don't be alarmed with that. So minus omega square should be equal to 4 alpha pi. So negative omega square over 4 pi is alpha, and like I said, alpha should be negative because it is stopping it. And they need torque, so torque average is just I alpha over here. I is just I, and alpha magnitude is omega square over 4 pi. So I omega square over 4 pi looks like option B. It's a long one. It says that there are two systems. In the first system, there are two identical stars of m and radius r separated by d, and they are moving with a velocity of v1 in a circular orbit. Now the mass is doubled, but the radius is same, and now for the same distance d, they are moving with v2. So what is the ratio of v1 to v2? So the situation is something like this. This is the mass m, this is the mass m, and they are separated by a distance of d that is significantly larger than the radius. So we can disregard the radius, right? The distance between them can just be taken as d. Now, if we take the force on any one star, and remember, this is moving in a circle. Let's say I take the green force, which is given by capital G m1 m2 over r square, that is the gravitational force. And this should also be equal to same as the circular force, the centripetal force, which is m v square, which is v1 square over r. And remember, the radius will be half of d, so d over 2. Okay, let's equate these two and see what we get. So I will have gm square over d square will be equal to 2mv1 square over d. One of the d is gone, one of the m is gone, so it will be gm over d is equal to 2v1 square. Let's flip the omelette. So 2v1 square is equal to gm over d, which means that v1 is equal to root of gm over 2d. Now, the only change that they are doing in the second scenario is doubling the mass. So obviously, you might think, obviously, if you're thinking that you can just replace mass with 2m, that's absolutely correct, because doubling the mass will just only change this while the distance remains the same. So v2 will become g times, and a factor of 2m will come over here over 2d square root. And isn't that very clear? What is the ratio of v1 is to v2 from here? Isn't that just 1 is to root 2? Because v1 over v2 is root g m over 2d divided by square root of 2gm over 2d. So this will be square root of gm over 2d multiplied by square root of 2d over 2gm. These two are gone, these two are gone. I'm just left with 1 here and over root 2. Okay, but they need the value of v2 is to v1. So v2 is to v1 will obviously be exactly opposite. So v2 is to v1 is square root 2 over 1, which should be option D. There you go. That's the correct choice. Right. The next question is, an asteroid is heading straight for Earth. The asteroid has this much speed, and relative to the center of the Earth, when it is at a distance of this many meters from the Earth's center. With what speed does the asteroid hit the Earth? Assume that the Earth is the only body exerting gravitational force. Ignore any resistance from the Earth's atmosphere. So this is more about the energy conservation of the system. The radius of the Earth is given to us, by the way. This is a part of the question. So at this point, we are we have two scenarios that at this point we have speed of the asteroid, which is given to us. Let's call it v, and there's a distance given to us. And then at this point it hits the Earth. Let's call the speed as v2, and let's say this is v1. So at point A and at point B, we are going to conserve the energy. At point A, the energy is going to be half mv square, and mass of the asteroid we do not know, and we don't even need that. So half times m times v1 square. And at this point, the potential energy between of the system of the asteroid and Earth, this is a system, so it will have a gravitational potential energy which is negative g m of asteroid mass of Earth divided by the distance between them. The distance between them is what do you call it as? It's given in the question already, which is this 3.84 times 10 to the 8. And finally it will have half m v2 square that we do not know, and minus g m mass of the Earth over 6,400 kilometer, which can be written as 6,400 times 1,000, and that should obviously be when I convert everything in meters. So we don't need the mass of the asteroid because m is gone from all the sides, and now I'm just supposed to plug in the numbers. Obviously this is going to be a little gross, but we will use Desmos. I'll just plug in all the numbers here so that you understand where will be what. So this is v1. G is let me put the g in a minute. Let's write it as it is gme over 3.84 times 10 to the 8. Add that thing on both the sides. So adding this on both the sides will be gme over 64 times 10 to the 5 is equal to half v2 square. Okay, now this thing can obviously be taken as a factor, so I'm left with, and we can multiply 2 both the sides as well. So when we multiply 2, then 2 times 1/2 is gone, so I'm just left with 14.8 times 10 to the 3 square minus gme, and this will be 1 over 3.84 times 10 to the 8 minus 1 over 64 times 10 to the 5 is equal to v2 square. Yes, mass of the Earth will also be a part of the question, which is 6 times 10 to the 24 kilograms. So don't worry, that is a part of the question. You can use it. And let's plug in everything in Desmos. And yeah, sorry, I forgot there should be a 2 over here because we multiplied 2 both the sides. So don't forget that this is a 2. Now let me just share the Desmos. Okay, so there you go. I plugged in everything for you. You can have a look at it. Just the first, velocity square minus 2 times g value, which is right over here. This is the g value, and then this is the mass of the Earth. This is the other entities, and the entire thing is in the square root. So I'm getting somewhere around 18,493. And yes, I think 18,493 matches perfectly with 1.85 times 10 to the 4, which is 18,500 around, which of course is the approximate value. So the velocity is somewhere around 1.85 times 10 to the 4 meter per second. That's the answer. Right. The next question is the Earth mass is given, has a radius of this. Suppose your friend wanted to throw a 145-gram baseball paddle to the ground from a hot air balloon 20,000 meter above sea level. Neglecting air resistance and height changes of the landscape, at what speed would the baseball need to have after your friend throws it to enter the free fall orbit and never fall to the ground? This is just really a fancy way of saying that what is the orbital velocity of the baseball, because if it enters the free fall orbit and never falls to the ground, don't think that this is the escape velocity. Escape velocity, had this was escape velocity, then enter in the free fall orbit will not make sense. Entering in the free fall orbit means it just keeps circling around. And what is the formula for the orbital speed? That's just square root of g me over r, because in this case we have Earth. So all we need to do is plug in g as 6.67 times 10 to the negative 11. Mass of the Earth is given to us in this case is 5.972 times 10 to the 24. Just be careful with R because the baseball is somewhere over here above the sea level, and we have to take, this is obviously 20,000 meters, and we have to take the radius of Earth into account as well, because the distance is always calculated from the center of the Earth. Radius of the Earth is 6,371 kilometer. So it will be 6371000 plus 20000. And if we find this comes at somewhere around 7,897 meter per second. So this will be the orbital velocity, which is option C. Right. Next question is, consider two satellites both in circular orbit around a very heavy planet. Satellite 1 has a mass of m, radius r. Satellite 2 has a mass of 3m, radius of 2r. What is the ratio of kinetic energy? The formula for kinetic energy of a satellite is given by g m of satellite, m of the planet over 2 times r. If you write KE1, that will be G times M. Actually, this is just KE1 because that's just, no funky stuff. But for kinetic energy 2, the mass of the satellite is 3m, planet is not changed, and its radius of the orbit is 2r. So it will be, the r is replaced by 2r. Remember, this 2 is a part of the formula, right? Okay, so this will become what? 3 GMMP over 4R, and now we just have to take the ratio of this. So KE1 divided by KE2 can be written as GMMP over 2R divided by 3GMMP over 4R. Keep change flip, so GMMP over 2R times 4R over 3GMMP. GMMP, R and R is gone. So I'm left with 4 over 6, which is 2 over 3, which should be option C. Okay, in this one, they are literally just trying to confuse us. The question says that two identical small moons are traveling in elliptical orbits around a planet of mass capital M. They crash into each other and stick together, then settle into a stable circular orbit of radius r. If the moons originally have a mass of m, then what is the orbital speed of the new circular orbit? Remember that the orbital speed does not depend on the object that is rotating, but on the planet. So since the formula is root gm over r and mass of the planet is not really changing, radius of the planet is just same as r, you might think that it is E because the two masses, join and becomes 2m, but no, it does not depend on the mass of the object that is rotating, but on that planet, so which is just capital M. So the answer is option A. All right. This one is, a planet with a mass of m was moving in elliptical orbit. The radii of point A and B are Ra and 3Ra. And the kinetic energy of the point at A is Ka. Then what is the planet's orbital speed at B in terms of Kam and universal constants? So first we need to use the conservation of angular momentum to find the respective speeds. Let's say the speed at A is VA and the speed at B is VB. As you can see that the angle between the velocity vector and the radius vector in both the cases is 90 degree. So when we conserve the angular momentum, I'm going to say that M VA RA sine of 90 is equal to M VB RB sine of 90. M and M is gone. VA I do not know. RA is just RA. Sine 90 is 1. VB is unknown. RB is 3 times RA given in the question, and sine 90 is 1. Okay, so this means that RA and RA is gone. So if we flip the omelette, then 3VB is equal to VA, and VB is equal to VA over 3. That's the velocity at B. Now, what is the kinetic energy then? Kinetic energy at B is going to be half m. Sorry, they are looking for orbital speed. Never mind. They are looking for orbital speed. So we need to convert or rewrite VA in terms of kinetic energy. We can do that. because kinetic energy at A is half mva square. So 2ka is equal to mva square. So 2ka over m is va square. So from here, I'm going to sub in the value of va over here. So VB will be equal to 1/3 of VA, which we get by taking square root on both the sides. So square root of 3KA, I'm sorry, it's not 3, it's 2, it's 2KA over M. So this is finally going to look like square root of 2 over 9, because this 9, if you take out, it is just 3, or if you bring this 3 inside, it will become 9, because I need to match the options. It will be square root of 2ka over 9m. That's another way to write the same thing, which is option C, right? I hope you understand. I mean, if you take this 9 out from square root, you have 3, right? So option C can be written as 2ka over m square root with 1 over 3 on the outside, which is right here, option C. Yeah. Right, that was a pretty decent one. A satellite is circular, in circular orbit, has a radius r and orbital period of tr. If the satellite is now moved to a new circular orbit with a radius of 4r, what is the ratio of the new time period to the original? So Kepler's third law will be really helpful here, which states that t square is proportional to r cube, which means that tr square over t4r square will be equal to, because when we divide them, the proportionality will be gone. It will just turn into an equal to, is r cube over 4r cube. So tr square over t4r square will be r cube over 64r cube. These two are gone. So I'm left with tr square over t4r square is 1 over 64. I'm just going to take square root on both the sides. So tr over t4r will be 1 over 8, which means that 8 times tr is t4r using cross multiplication. So you can see that they are asking what is the ratio of new period to the original. So let's I could have just flipped the omelet over here, take the reciprocal on both the sides. So t of 4r over t of r will just be 8 over 1. That looks like option D. All right. What is the mechanical energy of a satellite of mass m in circular orbit r around a planet of mass m? This is a really straightforward question. This literally just formula based. So the mechanical energy, I will write all the three energies. Kinetic energy is given by g m capital M over 2r. M is the mass of the satellite and M is the mass of capital M is the mass of the planet. Potential energy is negative g m capital M over r, and total kinetic energy or mechanical energy, when we add these two, is negative gm capital M over 2r, which is option B. That should be the answer. Okay, a satellite is launched from the surface of the moon with an initial velocity of magnitude v0. Which of the following are conserved by the satellite moon system throughout the orbit? Okay, this is more factual, because whenever a satellite moves around a planet, its mechanical energy is always conserved. We just saw its formula above. So mechanical energy is always conserved. Linear momentum is never conserved, but the angular momentum once again is conserved, because I think in question 7 we just did that, right? Or maybe question 6. Yeah, there you go. This mvr sine theta is nothing but angular momentum. So angular momentum is always conserved. So uh, these are facts, and 1 and 3, which means that I should mark option D as my correct choice. That should be the correct answer. Yeah. Okay. Consider this kilogram planet with this radius. At what speed would a projectile being shot vertically from the surface of the planet need to be going to escape the gravitational pull of the planet? This is a fancy way of asking what is the escape velocity. So escape velocity is given by root 2gm over r. So that will be square root of 2. G is 6.67 times 10 to the negative 11. Mass of the planet is this, which is 3.109 times 10 to the 30 over the radius of the situation of that projectile, which is 5.15 times 10 raised to 10. Let's plug that in. So I'm going to get 89739.7 meter per second, which is closest option is 90,000, because this is somewhere around 89.7 kilometer per second, which matches with option C. All right. Here we are given that two satellites X and Y of equal mass m and equal size. Okay, so their radius is same, are in circular orbit around a planet of mass m and radius r. Okay, fair enough. Initially, X is orbiting m at an orbital radius 3r. I can see that, and the other one is at 4r. The initial kinetic energy of X is Ka. Then an external force P moves satellite X to the same orbit as Y, such that X now has the same circular orbit as Y. In terms of X's initial kinetic energy, how much work is done by force P in moving X to its new orbit? Okay, so as the work done is basically the change of mechanical energy, right? So I need to find the total mechanical energy here, total mechanical energy here, and subtract. The only catch is that should be in terms of kinetic energy. So that's where the relationship between the energies come into picture. Remember that the kinetic energy is always same, equal, and opposite in sign to the mechanical energy. And just so you know, these guys are also equal to negative of twice of negative of potential energy divided by 2. This is the relationship that we get from the three formulas that I wrote earlier. If you find a relationship, it will be this, and this is pretty important. So we just need the first two, that kinetic energy, mechanical energy is just the opposite of the kinetic energy. So at this point, the kinetic energy is already given as kx. The kinetic energy at x formula, that is going to be g m capital M over 2 times the r, which is 3r. So this comes out as g m capital M over 6r, or multiplying by 6 both the sides, 6kx is equal to g m capital M over r. Likewise, ky will be g m capital M over 2 times 4r. 4 times 2 is 8, multiply 8 both the sides, so 8ky is equal to g m capital M over r. Why I did all that is because I want ky in terms of kx. Now look at gmm over r. Isn't that same as 6kx? So that's what I'm going to plug in over here. 8ky is equal to 6kx. So ky is equal to 6 over 8kx, or 3 over 4kx. And now all I need to do is subtract the mechanical energy. So it will be mechanical energy at y minus mechanical energy at x. That's going to be the work done. Mechanical energy is negative of kinetic. So negative of ky minus negative of kx. So it will be negative ky plus kx. So kx minus ky. So kx minus, and ky is 3/4 of kx. So this will become 1/4. 1/4 of kx. Positive, that is the work done, which is option E. That should be the correct choice. Okay, two planets C and D are orbiting around the same star. The planets have equal mass and they both are in circular orbit. Planet C has a smaller orbital radius than D. Then which of the following is true? And the options are about energy. Okay, just to write the formulas once again. In fact, I don't really need to write all the formulas. I know that kinetic energy is inversely proportional to R, and potential energy is inversely proportional to -1 over R, and total mechanical energy is also inversely proportional to -1 over R. So if planet C has a smaller orbital radius, obviously this denominator is small, which means that its kinetic energy will be more. So that is for sure that the kinetic energy of planet C is more. So planet C has more kinetic energy, which is definitely going to uh, be over here. And unfortunately, three options are adding up with that. But since this is a negative reciprocal, so because of negative reciprocal, if you increase the value of R, this value will, decrease the value of R, this value will increase in the negative direction. You understand what I mean? For example, this one was 2 joules, so this now became 8 joules. But this one was initially negative 2 and became negative 8. And sort of like negative 3 became negative, I don't know, 9. So these values actually decrease, right? Decrease. So they have less potential as and less mechanical energy as compared to D. So option A should be the best choice. I hope this makes sense. Okay. For an elliptical orbit sketched at right, which of the following statements true about A and B? The mechanical energy and the angular momentum are greater. So this is for sure. We just learned that mechanical and angular momentum are always conserved, right? So mechanical energy greater at point A and B doesn't make any sense. This also doesn't make any sense. Is there any option that is saying that, yeah, should be C, right? Mechanical energy of the system and the angular momentum of the satellite around the planets are the same at points A and B. Obviously, Kepler's law and the mechanical energy thing, that's a fact. Okay, when two masses separated by a distance r are brought closer, ending with a separation of r over 2, the gravitational potential energy of the system. So this is again the same thing, right? Gravitational potential energy of the system is inversely proportional to r. So when the distance becomes half, or sorry, negative 1 over r, right? So if the distance becomes half, this will become a factor of negative 2 because it's inversely proportional to r. So initially if it was negative 2 joules, now it will become negative 4 joules because half radius means it will become double in magnitude, but remember the sign will be as well. So what happens with this? This increases by a factor of 2 or decreases? I mean, it increases, sorry, it decreases, right? Decreases by a factor of 2. It should be option C. Okay, that was pretty straightforward. Satellite is placed in circular orbit of radius r, and second satellite is placed in circular orbit of 2r. Compared with the first satellite, the second will have less energy and less angular momentum. Okay, so this is about the total energy first off. So total mechanical energy is inversely proportional to the negative of radius. So if the distance is more, this number will become less but with a negative sign. For example, initially it was negative 2 joules, now it will become negative 1 joule. So obviously energy will be more. So less energy is gone. It should be more energy. And angular momentum is given by mvr sine theta, right? Theta is 90 because these are circular orbits, so mvr. Now, remember that the mass is compared to the first satellite, their mass is same, although it's not given in the question, but a second satellite, that satellite is identical. So you have to take the same mass over here. So M1, V1, sorry, MV1, R1. Now we need to eliminate this V because we know that the orbital speed is given by root of gm over r1. R1, so this will become m root gm, and r over root r will become root r. So this means that angular momentum L is proportional to root r. So more is the radius, more is the angular momentum. So for a second orbit, the angular momentum will be more. So compared to the first, the second will have more angular momentum. It should be option D. I hope this makes sense. All right. Over here, a satellite S is in an elliptical orbit around the planet M with a radius of R1, R2 being its closest and farthest, R1 and R2 being its closest and farthest distance respectively. What is the speed at the farthest distance if the closest one has v1? This is again a conservation of angular momentum. So I'm going to say m v1 r1 sine 90, because this is 90, is equal to m v2 r2 sine 90 once again. So m is gone. v1 r1 is equal to v2 r2. Flip the omelette. So v2 r2 is equal to v1 r1, which means that v2 is v1 times r1 over r2. Pretty straightforward, which should be A, I think. Yeah, A should be correct. Okay. Escape velocity for a rocket at Earth's surface is VE. What would be the rocket's escape from a surface of a planet with twice Earth's mass and the same radius? So escape velocity is given by square root of gm over r. Sorry, 2gm over r. And they are saying that the mass is doubled over here, right? The radius remains the same. So if the mass is doubled, obviously this double means that a square root 2 factor, I mean, I can definitely do that for you. VE, let's call it dash, will be square root of 2g 2m over r, which will become square root of 4gm over r. We need to find the ratio. So VE dash divided by VE is going to be square root of 4gm over r divided by root 2gm over r, which will be square root of 4g. Square root of 4 is 2, so 2 root gm over r times square root of r over 2gm. The square root can be taken out, so it will be 2 root gm over r times 1 over root 2 square root of r over gm. Square root of r gone, gm square root gone. So I'm left with 2 over square root of 2, which is square root of 2. So this means that a VE dash over VE is square root of 2. This means that VE dash is square root of 2 times VE, which is option B. Yeah, option B should be the correct choice. Okay, the figure above represents, the below figure represents S2 and S3 of equal mass orbiting Earth in circular radii, What is the relationship between kinetic energy and angular momentum of S3 compared to S2? We just proved a similar question for angular momentum, and we learned that more is the radius, more is the angular momentum. So this is for sure that the angular momentum of S3 is greater. So it has to be either option A or B. And kinetic energy is inversely proportional to positive 1 over r. So more is the r, less is the kinetic energy. So kinetic energy is less for S3 and angular momentum is greater for S3. I hope this one makes sense because we already did most of the work earlier, right? So yeah, this is how we do it. Okay. Okay, this time they're asking for the graph. An object moves away from the surface of the Earth. The graph of gravitational potential energy is. What is the formula for gravitational potential energy? Isn't that just inversely? Obviously the exact formula is negative gm over r. It's inversely proportional to negative 1 over r, remember. Had this was positive 1 over r, it would have looked like this, but since this is a negative outside, it will be in quadrant 4, and it will be obviously this is called rectangular hyperbola, so it has to be option A. That's a pretty straightforward, more math than physics, but yeah, that's how it is, option A. Okay, there was a total mechanical energy of a satellite M orbiting Earth at a distance equal to 2 times the Earth's radius above its surface. Be very careful. 2 times Earth's radius above the surface, right? Above the surface would mean that this guy is 2 times RE and this is already RE. So remember that be careful, the total distance will be 3 RE. So the total mechanical energy formula was negative G m over 2R. So all we have to do is negative gmm over 2 times r will be 3re. So it will be negative gmm over 6re. That will be the total mechanical energy, which looks like, isn't that just option A? Yeah, should be option A. Right, the radius of Earth is r and acceleration due to gravity is g. If a body of m is sent to a height of r over 4 from the Earth's surface, the potential energy increases by. So the formula for the potential energy is given by negative g m over r. At the surface in situation A, it is just negative g m over capital R. And in situation B, it is r over 4 from the Earth's surface. This means that its total distance from the center will be r plus r over 4, which is 5r over 4. So this will be negative gmm over 5r over 4, which is just negative 4/5 of gmm over r. There is a potential energy at B. So potential energy at A is here, at B is here. We are looking for a change. So the change is going to be potential energy at B minus potential energy at A, which is negative 4/5 gmm over r minus of minus gmm over r, which is negative 4/5 of gmm over r plus gmm over r. 1 minus 1 over 4 over 5 is just 1 over 5, so it's 1 over 5 gmm over r. Of course, not in the options because they need in terms of acceleration due to gravity. The formula for g was gm over r square, which means that if I multiply both sides by r square, I get the g capital M value. So let's replace that g capital M over here. First, I'm going to rewrite it as 1 over 5th small m over r gm. And this gm is now replaced by g r square. One of the r, of course, is gone, so I'm left with mg r over 5. So that should be the final change, which is, yes, indeed, option C. Yeah, makes sense. This could have been done another way as well, using mgh and all. But yeah, I just wanted to use the potential energy formula so that you will get, some practice as and how to apply these things. Right, satellite in the circular orbit of radius r has this as E. Total energy, we know that. What minimum work must an engineer deliver to send it to infinity? Okay, so there are two things. Infinity means the potential energy at that point is zero, and minimum means I want the kinetic energy at that point also to be zero. So in other words, at A, the mechanical energy is given by negative g m over 2r, and at B, both are zero. So the work by the agent is mechanical energy at B minus mechanical energy at A. So it is 0 minus g m over 2r, which is g m over 2r. So that should be the work. That's straightforward. It should be option B. That's what we have. Guys, if you're liking this video so far, please like and subscribe. Please share it with your friends. And if you need private tutoring, feel free to reach out. A wheel with a known moment of rotation inertia I is mounted at rest on a fixed axis through its center. In order for the wheel to rotate, a constant torque is applied to the wheel. Which of the following quantities would be most helpful in determining the energy added to the wheel while this torque is applied? I think that's pretty straightforward because if we want to know the energy, then the energy due to a torque is given by tau times the rotation, the angular displacement, that is theta, if the torque is constant, which it is in our case. So we need theta or the number of rotations, because from number of rotations I can figure out the angular displacement as well, if it makes sense. Right, guys, so jumping into the territory of angular momentum now. A marble of mass m is moving at the speed of v towards another ball of mass m attached to the point P by a light rod. Marbles stick together. What is their angular speed immediately after the collision? Um, I am going to conserve the angular momentum here, because whenever the torque, the net torque is zero of the system, so I'm going to conserve the angular momentum in this case. If you're thinking that why is the linear momentum not conserved, because this guy is a rod, right? It is exerting, as soon as it collides, it exerts an external force on the system. So linear momentum is not conserved. So we are going to conserve angular momentum. The initial angular momentum is only because of this mass, and this is the angle that we are looking for. I hope you remember the formula for the linear momentum, a special formula for the point mass. It is mvr sine theta, where r is the distance between that point and the pivot, theta is the angle between the velocity and the r, and then v is just v. Obviously, we don't know theta, and obviously we don't know r, and that's why I made this triangle, so that I can say that sine theta is opposite over hypotenuse. So r sine theta is just L, and this r sine theta I'm just going to replace by L, which is mvL. That is L initial. And L final, remember that they stick together. So this is 2m, and they have some omega, and this is L. So I think it is worth, it would be fair to use I omega as the formula now for the final angular momentum, where I is m r square and r is L, because these are, we are not given any radius, so we are just going to assume these are point masses times omega. And these two guys should be equal because the angular momentum is conserved. So 2ml square omega should be equal to mvl. M and m is gone, one of the L is also gone, so 2L omega should be equal to V, which means that omega should be equal to V over 2L. That is the angular speed immediately after the collision. Should be option C. Guys, if you have done linear momentum conservation, I think you will again get C, but remember, it's just a happy coincidence, but linear momentum is not conserved. That is not a legitimate physics that you will be doing. So angular momentum is conserved, linear is not conserved, just be advised here. Okay. A ring of mass m radius r is released from rest on an incline from height h. The ring rolls without slipping. At the bottom, what is the angular momentum of the ring about the center? So in other words, I need to find omega. And for omega, I need to conserve the energy. So let's say there is some velocity v and some omega at the bottom. The initial energy is just mgh, because this is the height over here, and the final energy is half mv square plus half I omega square. We are not given any I over here, right? So I think they want us to, or probably let's just keep I as I. So this will be mgh. Actually, you know what? This is a ring, so I'm just going to replace by mr square. I think this is going to make my life a little easy. And v is omega r, so omega r square plus half mr square omega square. Yeah. Okay. M is gone, so I'm left with gh is equal to half omega square r square plus half omega square r square, which is just omega square r square is equal to gh, which means that let's flip the omelet. So omega square r square is equal to gh, which means that omega square is gh over r square, which means that omega is root gh over r. And now we need to find the angular momentum, which is I omega. I is, for the ring, is mr square, and omega is root gh over r. One of the r is cancelled, so I'm left with mr root gh. Oh my goodness, that's a gross expression. I hope that is in the options. Yes, indeed, option A. That should be the correct answer. Okay. Particle of mass m moving with v, magnitude angular momentum about the. This is the honestly the same type of question that we did, because its radius is given as, this is d over here that we are given already, and we need to figure out what this theta is, right? What this theta is. So the angular momentum is going to be mvr sine theta. M is m, v is v. We need to find the angular momentum about the origin. So r is d, and theta, if we notice carefully this triangle, uh, uh, this tan theta will be opposite over adjacent, which is d over d. So tan theta is 1, or if you are honestly, I'll just do sine theta, guys. You might be confused. So if this is d, then this will be square root 2d, and sine theta will be opposite over hypotenuse. So that's going to be 1 over square root of 2, that is sine theta. I'm just going to plug that in over here. So that's just 1 over square root of 2. So that will be mvd over square root of 2, which looks like option C. That should be the best choice. Right, guys, I hope this one makes sense. Okay. Uh, 5 Newton meter torque acts on a thin hoop with a mass this and a radius this for 10 seconds. If the hoop starts from rest, what is the new angular velocity? The moment of inertia is given. Isn't that pretty straightforward, guys? We need to find alpha, of course, which is torque over I, because, torque is equal to I alpha. Torque is 5 Newton meter. I is, we don't know, but we are given the formula, which is mr square. M is the mass, which is 0.5. R is 0.15 square. So this guy comes out as 0.01125. If we put that I over here, 0.01125, then alpha comes out as 444.44 radian per second square. I am interested in the angular velocity, final angular velocity. So omega final is equal to omega initial plus alpha t. Omega initial is 0 because it starts from rest. Alpha we just found, it's 444.44, and the time is 10 seconds over here. So the answer will be 4444.44 radian per second. Well, that's a lot of force. And yes, the answer is also option 4, or option D, which is 4444 radian per second. Okay. What's going on here? A particle with a mass of 12 meter per second. Yes, I can see it at 30 degree, over here. Okay, above the horizontal. So this guy is 30 degrees over here. A line is drawn from P to the particle. From P to the particle is 3.5 meters long and makes an angle 55 degree. Okay, so this is 3.5 and this is 50 degrees, sorry. What is the angular momentum of the particle with respect to the point P over here? So this is the velocity. We are already given this r over here, so I'm just going to disregard this 3.5 because this has no relevance. So I'm going to say that the angular momentum is obviously mvr sine theta. M is 1 kilogram, that's written over here, teeny tiny guy. Velocity is, there you go, that's my boy, 12. R is of course about point P, that's 3.5, so that's 3.5. Now theta is, be careful, this entire thing. And if this is 50, then these are alternate angles, so this should also be 50. So the total angle that we are looking at is, yes, it is indeed 80 degrees. So let's multiply all these people up. So I am getting 41.36 kilogram meter square per second. So I think the best choice should be option, not E, it should be D. Yeah, that guy is the closest guy. I think that's what I'm gonna go with. So that should be the answer over here. All right, fellas. This question is, this is spherical star of radius r that is spinning with omega. As part of its life cycle, the star collapses to a smaller diameter while maintaining the same mass. What is the new angular speed when the okay, this is a classic question of conservation of angular momentum because it's spinning and net torque is 0. and so I'm going to say that L initial is equal to L final. So I1 omega 1 should be equal to I2 omega 2. Okay. Moment of inertia is given by, since this is a spherical star, so I'm going to say it's 2/5 mr square. So 2/5 mr square times omega initial is just omega. And final I is 2/5, mass remains same, and the radius is just half. So r over 2 square, and omega 2 I do not know. So 2/5 m is gone. So r square omega is equal to r square over 4 omega 2. R square is gone. So multiplying both sides by 4, we have 4 omega is equal to omega 2, or omega 2 is 4 omega over here. So omega 2 is 4 omega. That is our answer, which is option B. Right. For a solid cylinder of mass and radius are rotating at omega, when a non-rotating hoop of equal mass and radius drops onto a cylinder. In terms of initial omega, what is the new angular velocity? And the moment of inertia of cylinder is this, and of hoop is this. Again, a very classic question of the conservation of angular momentum, because when this disk is rotating, and when this hoop is placed on the top of it while this was at rest, this hoop will try to slow this cylinder down, and this cylinder will try to speed the hoop up. And whatever the torque is involved between these guys, that is equal and opposite. And as a system, it cancels each other, and then they will start moving with a common omega. So initially the angular momentum is only because of the cylinder, which is I omega. I is 1/2 mr square, because it's given in the question that the moment of inertia of the cylinder is 1/2 mr square, times omega. M and R are small, so that's fine. I can just replace with the small case, although it doesn't really matter. Finally, their moment of inertia will be I hoop plus I cylinder times omega. I hoop is, remember, it's mr square, and the mass and the radius is same. So I'm just going to write mr square here, and cylinder is 1/2 mr square, and that should be omega. So this should be 2 over 2, 3 over 2 over here, 3 over 2 mr square omega, and all we need to do is set these guys equal. So I'm going to say that 3 over, I think omega and omega is overlapping, so let's call this as omega dash. So I'm going to say that 3 over 2 mr square omega dash, or omega prime if you have the feel of calculus, is 1/2 mr square omega. Half gone, mr square gone, so we are left with 3 omega dash is omega, which means that omega dash is just omega over 3, which looks like option A. That should be the correct choice. Okay. A solid cylinder of mass and radius r, when rotating at an angular velocity, has a momentum, angular momentum L. Which of the following will double the angular momentum? So let's first write the formula for the angular momentum. It's just I omega. I of a solid cylinder is 1/2 mr square, and omega is just omega over here. So that is the value of L. Now I want to double the angular momentum, right? So let's read the options. Doubling the mass of the cylinder while halving is angular velocity. I don't think so, because if I double the mass and if I halve the angular velocity, then these two effects will nullify each other, because this will be a 2 and this will be a 1 over 2, which will cancel. So omega L will not change. Doubling the angular velocity while halving the mass, once again, I again no, because if you double the angular velocity and half the mass, again the same situation is going to happen, that it is going to nullify. Doubling the radius while halving the mass of the cylinder, I think that could work, because doubling the radius would make it a factor of 4, because that's 2 square, right? So there will be a factor of 4, and the mass of the cylinder should be half, so there should be a 1 over 2 over here. So 4 over 2 is just 2, and yes, that's what I want. It should be double, so it should be option C. The others are not going to work. You can definitely check those options, but yeah, it should be option C. Okay. The next one is there is a ball of mass m that is released from rest at position A after falling from a height of h. What is the magnitude of the angular momentum of the block about point C when it reaches B? So it's pretty straightforward. I think all I need to do is find its velocity, because at this point I will have the angular velocity as just mvr sine theta. M is just m, v I need to find, r is obviously this distance. Oh, I also have to find this, which should not be a problem because that's just a trigonometry, and theta is just 90 degrees, so that's just 90 degree over here. So it will be mvr. Okay, let's find both these one by one. For velocity, I think I can use kinematics. So v final is equal to v initial plus at. It's released, rest, so 0. Acceleration is just g, and time is just t over here. But we don't know the time, right? Oops, wrong equation. I think we need to use the third equation because we know the displacement. So v final square is equal to v initial square plus 2as. So 0 square plus 2 times g times h. So it is root 2 gh. That is the v final. You could have used energy conservation as well. And for r, I'm going to, of course, pay attention to this triangle. I'm interested in finding r, so I think cosine will help me. Cosine theta is adjacent over hypotenuse, so L cos theta is r. That's about it. Let's plug all these guys in. So m times velocity is root 2 gh times r is L cos theta. So the answer is m L cos theta root 2 gh, which is ml cos theta root 2 gh is sorry guys, there is a typo in the question, because if you notice B and C are same. This guy is cosine theta, so it should be option B. So ml cos theta times root 2 gh. All right. For this one, there is a solid cylinder of mass m and radius r rotating at omega. When a non-rotating cylinder of double the mass and equal radius drops onto the cylinder. By what factor does this change the rotational kinetic energy with regard to its initial rotational kinetic energy? So this involves energy, but to start with, we need to conserve the angular momentum. Okay. Angular momentum of the cylinder is given by 1/2 mr square. So that's for cylinder number 1. And for cylinder number 2, it is double the mass given over here, so 2m, and equal radius, so that's just mr square. So initial angular momentum is given by I omega. I is 1/2 mr square and omega is just omega, and final angular momentum is given by I omega, but I should be for both, right, because they both are moving together now. So 1/2 mr square plus mr square, and then omega, let's call it omega dash, that we do not know. So this will become 3 over 2 mr square omega dash, that is the L final. Obviously, these two guys should be equals because the angular momentum is conserved. So I'm going to say that L final will be equal to L initial. L final will be equal to 3 over 2 mr square omega dash will be equal to 1/2 mr square omega. 2 gone, m gone, r square gone. So what are we looking at here? 3 omega dash is equal to omega, which means that omega dash is omega over 3. But they are interested to know that by what factor does this change the rotational kinetic energy with regard to its initial rotational kinetic energy. So initial energy is I omega square, of course, I omega square. Now we need to convert the kinetic energy.
So initial kinetic energy is I omega square over 2, which is going to look like 1 over 2 times I, and I is 1/2 mr square times omega square, which is 1/4 mr square omega square. That is the initial kinetic energy, right? The final kinetic energy is, I think I'm gonna run out of space, so okay, I'm still gonna try it. Is I nu omega square over 2, right? So 1/2 I nu is, there you go, sitting right here, 3 over 2 mr square. So 3 over 2 mr square, and omega dash square, and omega dash is omega over 3. So mr square and omega over 3 square. So 3 square is 9, and 3 is over here. So 3 over 4 times 1 over 9 times mr square. 3 over 9 is 1 over 3, 4 times 3 is 12, so it's 1 over 12 mr square. This is the K final. And all we need to do is now take the ratio of these two. So K final over K will be equal to 1 over 12 mr square omega. I think I left an omega square here. There should be an omega square, guys. Let me fix that. Okay. So 1/2 mr square omega square over the K, which is 1/4 mr square omega square. So keep change flip, it will become 1 over 12 times 4 over 1, and 4 over 12 is 1 over 3. So this should be option B. I think B makes perfect sense. It was a pretty good question, right? Again, guys, if you're liking this video so far, please like and subscribe. Please share it with your friends, and if you need private tutoring, feel free to reach out. Particle of mass m moving in a circle with radius r and constant alpha. After one revolution, what is the angular momentum of the particle around the center of the circle? So I know that at any point, the velocity is always making a 90-degree with the center, because this is the tangential velocity. So it has to be mvr, because sine 90 is 1, right? So that's what we are looking at. M is just m and r is just r. We need to figure out what v is, and for that I need to take the alpha into consideration. One revolution would mean a theta of 2 pi. So I think I can use the omega final square is equal to omega initial square plus 2 alpha theta. Starts from rest, alpha is alpha, theta is 2 pi. So omega final square comes out as 4 pi alpha. And if you're going to take a square root of this guy, so omega final will be equal to root of 4 pi alpha. I'm looking for V, and of course V is related with omega as well, because V is equal to omega R. So I'm going to replace that with omega R. So it will look like m r square, and omega is root 4 pi alpha. And what is square root of 4? 2. So that 2 comes out, 2 mr square root pi alpha. There is a slight typo in the options. It has to be option E, and this is 2 pi r square root of pi alpha. So option E matches with the answer. And then we have planet Xenon has twice the mass of the Earth and orbits its star at the same orbital distance that the Earth orbits the Sun. If the planet takes 365 and a quarter days to complete one orbit, then how does the angular momentum of planet Xenon compare to the angular momentum of the Earth, assuming both are orbital? This is based on Kepler's law, guys, Kepler's second law, where angular momentum of Xenon and angular momentum of Earth is conserved. Angular momentum is mvr, so m1 v1 r1. I'm skipping sine theta because that's just going to be sine 90, as they are circular in nature, so tangential and centripetal kind of stuff. So this is equal to m2 v2 r2 over here.
They are asking to conserve angular momentum. So why am I even doing all this? Isn't the answer just option E, because their angular momentum should be equal? Right, let's talk about the last question that we have here. Rod is initially hanging straight down from a pivot point at the top. A piece of clay that is initially moving horizontally strikes the rod and sticks to it. Which quantities are conserved during the collision? Once again, this is only a conservation of angular momentum and not linear momentum. I think we have done a similar question, uh, you know, earlier, and the idea is that this rod is applying a force, external force, because of which the angular momentum is the linear momentum is not conserved. And since it sticks to it, there is no point of conserving the kinetic energy as well, because we know that whenever it sticks, the kinetic energy is lost, right? It is only conserved in elastic collision. This is a perfectly inelastic scenario. So in the conserved, I should only have angular momentum, and in the non-conserved, yes, linear momentum and kinetic energy both are not conserved. So it has to be option A. Makes sense. With a relaxed length of 50 centimeter hangs from the ceiling. A uniform solid block of mass m is suspended, and the block is at rest, and the distance from the ceiling to the top of the block is 54 centimeters. Okay. Spontaneously, 1/3 of the block breaks away and falls straight down, causing the system to begin oscillating with simple harmonic motion. Find the period of the motion. So obviously, if 1/3 block falls down, remaining 2/3 will perform simple harmonic motion. And we are looking for what is the period of the oscillation. Okay, the formula for period is 2 pi square root m over k in this case. We are given that the mass is no longer m, it is 2/3 m. So this is 2/3 m over k. So it will look like 2 pi square root of 2 over 3 and m over k, everything. The setup is like this. I'm just writing m over k separately because we don't know that yet, and we need to use this information to figure that out. Okay. All right. It is given that the block is at rest at the distance from the ceiling to the top of the block is 54. So this is 54 centimeter, guys. And remember, what is the original length of the relaxed length? That's 50, which means that the stretch is 4 centimeters. And when it is in equilibrium, it absolutely makes sense to say that mg and kx naught must be equal and opposite to each other. That's why it is balanced, right? So I'm going to say that kx naught should be equal to mg. X naught, I know it is 4, but 4 over 100 because meter, SI units. And m and g, let's say, is just g. Okay, so 4k will be equal to 100 mg. And remember, we need the value of m over k. So all we need to do is divide both sides by k from here. So it will look like 4 is equal to 100 mg over k. If you're confused with I'm not going to use this approach, otherwise you might be confused. What I'm just going to do from here, let's flip the omelet. So 100 mg is equal to 4k. I'm just going to find the value of m from here. So m will be 4k over 100g, right? M will be 4k over 100g. This m I'm going to sub in over here. Okay, so this is going to look like 2 pi square root 2/3 as it is, and over k as it is, and this m will go here, right? 4k divided by 100g. Let's simplify this a little bit. So this will become t is equal to 2 pi square root of 2 over 3, 4k on the top, and k at the bottom, and that 100g will also drop to the bottom, right? Keep, change, flip. Now see this carefully. K and k is gone, and now we don't have to worry about any unknown constants. So it's 2 times 4, which is 8 on the top, and 3 times 100, 300, and 300g. And if we plug that in our calculator, the number comes out as 0.3 3 to 7, 8 seconds, which looks like option B. Yeah, option B should be the correct choice. That was a pretty decent question. Okay. The graph shows the position of an object undergoing periodic motion as a function of time. What is the maximum acceleration for the oscillation? This is a simple harmonic motion, not just a periodic motion. They should have made it very clear. I'll make sure to edit that in the PDF. But yeah, this is a simple harmonic motion. They're asking what is the maximum acceleration. So the formula for maximum acceleration is A omega square, right? A is the amplitude and omega is the angular frequency, of course. With this curve, we can very clearly see what the period is, because one cycle is completed in down, up, and down. There you go. One cycle is completed. So 2 seconds is the period. Okay. We know that omega is related with period as 2 pi over t. Now all we need to do is plug in amplitude, which is 0.2. It is in meters, and period is just 2 over here. So the answer is 0.2 multiplied by pi square. 0.2 is 1 over 5, so it will be 1 over 5 pi square, or pi square over 5, which looks like option A. Yeah, option A should be the correct choice. All right. The equation for the period of a pendulum is given by 2 pi root L over G. All of the following approximations are required to derive this equation except. This is more of a conceptual question. If you guys remember the derivation as in how we arrive to that situation, one really important derivation, the assumption that we have to use is the angle of oscillation should be really small. So this is definitely an approximation. Remember, they are asking except. So B is an approximation. A string is massless, definitely, because we assume that the entire mass is concentrated at the end of the string, just like grandfather's clock, the pendulum, and all. So by default, A is also an assumption. The gravitational field is constant throughout. Yes, of course, we don't really assume that the G is different here or G is different here. The G is assumed to be same during the entire motion. But D is saying that the tension in the string is considered constant throughout. No, definitely not. The tension is changing because this is performing sort of like a simple harmonic motion. So the tension will be maximum at the bottom. So it will be different at different positions. No, that's not really an assumption that we take. So D is the correct choice because this is not the assumption that we take. Okay. The position of a particle undergoing SHM is given by this. What is the maximum velocity of the particle? Maximum velocity of the particle performing SHM is given by A omega. Here A is just written right here because the equation of X is A cos omega t plus phi, I'm just interested in A, which is 0.2. And omega is also something that I can see right here because the equation, like I said, is 0.2 cos omega t plus some base angle phi. Don't worry about this phi. Just focus on omega over here, which is just 3. So that's 0.6 meter per second. Yeah, should be option C. All right. A block of mass m is attached to an ideal spring, and the spring constant is k over here, and they're saying that the block is pulled to the right and then released. The block slides back and forth across the floor in SHM with a time period t1. Now, which modification of the system would result in a period t2 which is same as the old period? Okay, all right. We know that the period is given by 2 pi root m over k. Now they are saying that adding an identical spring in parallel to the original spring, no. Well, that will double the effective spring constant and will change the period. I don't want that. Replacing the spring with a tighter spring, of course not. That's also going to change k and eventually is going to change the period. Replacing the spring with a much looser spring, no. That's again the same situation. Pulling the block twice as far to the right. Yes, this doesn't really have any effect on the period because this is just going to double the amplitude, but the period will still remain the same. As you can see, that period is only dependent on the mass and the spring constant, not really the amplitude. So it should be option C, which will keep the same period. Okay. The position width varies with time according to this. So what is the acceleration of the particle as a function of time? This is just kinematics coming in. We know that velocity is given by the first uh, derivative of the position. So that's as per kinematics. But okay, let's find the velocity first. So what will be the derivative of this function? 2 is as it is. Derivative of sine is cosine, and 4t minus t remains as it is, and the derivative of 4t minus 6 is just 4, right? I'm just using the chain rule over here. So this will become 8 cosine 4t minus 6. That's the velocity, but we are interested in acceleration. So the acceleration is going to be v prime t, and let's find the derivative of this, which is 8 remains as it is. Derivative of cos is negative sine 4t minus 6, and the derivative of 4t minus 6 is just 4. Okay, so 8 times 4 is 32 with a negative sign, so it's negative 32 sine of 4t minus 6. That should be the equation for the acceleration, which is, yeah, indeed, that is indeed option E. That should be our answer. All right. A block is attached to an ideal spring. The block is initially at rest and then pulled 20 centimeter to the right. After being released, the block slides back and forth in SHM. The maximum speed of the block reaches, maximum speed the block reaches is this. So which additional information would allow the spring constant of the spring to be determined? Okay, all right. The formula for the maximum speed is given by A omega. We know already what A is because it is pulled 20 centimeter to the right and then it performs SHM, which means that the amplitude is 0.2. And Vmax is already given in the question as 5. So we know that 5 is equal to 0.2 times omega. We can multiply both sides by 10. So 50 is equal to 2 omega. So 25 is equal to omega, or omega is 25. We don't need to do all the calculations. I'm just making it well easier for you guys to follow. So omega is 25 over here. And what is omega? Root of k over m. So square root of k over m is given as 25. They are interested in spring constant. So of course, the two unknowns here are k and m. If I can get the mass of the block, I can easily get the, what do you call it as, the value of k. And yes, indeed, that is in the options, the mass of the block. But I'm just gonna take a pause here because option E says either the mass of the block or the period of the oscillation. The period of the oscillation is given by 2 pi square root m over k. Now, the period is not really going to help us because don't you think we in a way already have period? If we have omega, and remember the period is given by 2, the period is also given by 2 pi over omega. So even if I have omega, but in a way I already have period, but still I cannot figure out what the spring constant is without knowing the mass. So it's only option B. The period is not really going to help us. The period alone will not be going to help us find the value of spring constant. Should be option B only, right? A student places a 1 kilogram block onto a frictionless table and attaches a spring of constant k to it. The mass exhibits SHM with a period of 2 seconds. The student then removes the 1 kilogram block and attaches a block of unknown mass in its place, measuring the period to be 3 seconds. What is the unknown block's mass? Okay, so two situations here. T is given by 2 pi root m over k. We very well know that. In situation number 1, we are given that the period is 2 Let me change the color over here for situation 1. Period is 2, mass is 1 in situation 1, and k we don't know. So this is this is how the math looks like. 2 gone, so 1 will be equal to pi square root 1 over k. Let's cross multiply. So, I hope you understand the math here. Square root of 1 is just 1. So it is essentially 1 over root k. And if I cross multiply, then square root of k will be pi, and k will be equal to pi square. So we got the value of k from this information. Now we need to figure out what is the block's unknown mass. So once again, the period is 3 seconds. 2 pi is 2 pi. The new mass we need to figure out, and k is just same as the old one, which is pi square, right? So I'm just going to put pi square over here. So 3 will be equal to 2 pi square root m over the square root of pi square is just pi. So pi and pi is gone. Dividing both sides by 2, 3 over 2 is square root of m. And if I square both the sides, I have 9 over 4 is equal to m. So m will be equal to 2.25 kilogram. So the best choice in the options would be option C. All right. A 0.15 kilogram block is attached to a horizontal spring of spring constant 15 Newton per meter. The block is pulled 4 centimeter from its equilibrium position and released at t equal to 0. Which of the following correctly represents the position of the block as a function of time? Okay, it's a horizontal spring mass system, and it is pulled 5 centimeter from its equilibrium position and released. So it has to be a cosine function. Why I'm saying that is because at t equal to 0, it is at its maximum right or maximum left, right? It's either, let's say this is the equilibrium position. So it's either maximum left or it can be the maximum right as well. And the maximum value, if I'm given two options, sine and cosine, if I have to put t equal to 0, cosine is the one that comes to be maximum or minimum, because sine will just come out to be 0, right? Because if you put t equal to 0, the sine is just 0. So it has to be the cosine function. Now, what is the amplitude? Obviously, if it is pulled 5 centimeter from the equilibrium, the amplitude has to be 5 centimeter or 0.05, which automatically rules out option A as well. And between these two, omega varies. So let's find omega. Omega is k over m, root k over m. K is given as 15, mass is given as 0.15. 15 over 0.15 is just 100, and square root of 100 is 10. So the one with 10 is our answer, and it has to be option C over here. All right. Here we are given that there is a block of mass and that is attached to two springs of spring constant K. What is the period? Okay, this is a very popular variety in AP Physics C, that whenever this is called series connection of the springs, right? I'm just going to give you a straightforward formula, because right now the spring constants are same, but even if they are not, let's say hypothetically this is K1 and this is K2, and you're supposed to find this effective spring constant, then the way this works is 1 over K effective is 1 over K1 plus 1 over K2. This is the formula to find the K effective of springs. In this case, it's pretty easy, because 1 over K effective will just be 1 over K plus 1 over K. 1 over K plus 1 over K is 2 over K, which is 1 over K effective. Take reciprocal on both the sides, so K effective will be K over 2. Effective spring constant means that I can just replace these two springs with a single spring of value K over 2. And now we are free to apply our formula, which is 2 pi square root m over K. So m is just, well, m, and the K that we have is K over 2. This 2 is going to jump up. So the period comes out as 2 pi square root 2m over k. Do we have something like this in the options? 2 pi, yeah, it looks like option C, right? 2 pi root 2m, yeah, should be option C. That's our answer. Right. A block of mass m is attached to a spring constant k, where the maximum speed of the block is v. What is the amplitude of the block? All right, v max is given by a omega. So let's flip the omelet. So a omega will be v max. V max is treated just as v over here. They need amplitude, so amplitude should be, by the way, let's put the value of omega here, because we know that omega is root of k over m is equal to v. Let's multiply square root of m on both the sides. So a square root of k is equal to v square root of m, and divide both sides by square root of k. So v square root of m over square root of k, which can also be written as v square root m over k. So this is the amplitude, v square root m over k, which looks like option D. That should be the correct answer. Right. In this question, we are given a mass that sits in equilibrium at x equal to 0 atop a frictionless table. Fair enough. The mass is pulled to the right. Mass is pulled to plus a from equilibrium and allowed to oscillate. Which expression correctly gives the velocity of the mass as a function of time in terms of... Okay, they're asking the equation of the velocity. Now, in all such cases, the starting position is really important, because they are saying that the mass is pulled a horizontal distance of plus a from the equilibrium and allowed to oscillate. This means that plus a would mean that it is going to the right by a convention. So it is released from this position, which is right extrema, right? Right extrema. Obviously, when it is released from here, it has to go towards the left. It obviously makes sense. And when it is released at t equal to 0, it also has to be at rest, because it starts from rest, goes to the left with increasing velocity. That's how it works. So definitely it cannot be a cosine function, because in cosine function, if I put t equal to 0, v will not really come out as 0, because cosine 0 is 1. So it will come out as some value that I don't, some value, so which is not 0, which I don't want. So it has to be sine function. That is for sure, right? So it's either C, D, or E. I can eliminate E, I think, by finding the value of omega, because omega is just given by root of k over m, and this is where omega sits. I hope you understand, because in the general equation we have cos omega t or sine omega t. So this omega should be root of k over m. Sine or cosine, whatever that is, it should be root of k over m. So by that logic, E is also gone. And now comes the point that it should be going to the left. So if it should be going to the left, it means that whether it's option C or whether it's option D. There are two ways to actually just think about it. Like, if this is going negative, then it has to be sort of like a reflection about the x-axis, if you're able to visualize, because sine curve is going to look like this from the start if there is no reflection, there is no negative sign. So it is positive. But since this is going towards the negative side, left side, so this negative will actually make sense, because this will flip the equation towards the bottom half, and it has to be towards the negative side till it reaches the right, so the left endpoint, and then it changes the direction and comes back again to the right endpoint. So the minus on the outside is really important, so it has to be option D. All right. A simple pendulum oscillates according to the equation theta is equal to, so this is definitely a pendulum situation, because whenever we talk in terms of angle, we are talking about pendulum. Using G as approximately 10, what is the length of the pendulum? So theta is equal to theta max cos of omega t. That's how it works. And since I don't see any number here as the coefficient of t, omega must be 1. So if omega is 1, t is 2 pi over omega, which should be just 2 pi over 1, which should be just 2 pi. Which means that the period formula, which is given by 2 pi root L over g, t can be replaced by 2 pi. So it is 2 pi is equal to 2 pi root L over g. 2 pi is gone, which means that 1 is equal to root L over g, which means that root g is equal to root L. Let's flip the omelette. So root L is equal to root g, which means that L is equal to g, and g is already given as 10 to us. So the length of the pendulum is 10 meters for this to happen, which looks like option D. That should be our final answer. All right. A large panda swings on a swing, creating a simple pendulum. Okay, well, during one of its oscillations, a baby koala bear crawls under the swing, and at the lowest point in its swing, the panda picks it up. During the period of the oscillation, does the period of the oscillation increase, decrease, or stay same? Why? Okay, so it's something like this. Ignore the panda and the koala bear stuff. It's something like there is a mass over here and it's performing a simple pendulum kind of SHM. So it's like something like this, right? Now, what they're saying is at some point when this pendulum was at the bottommost point, uh, the mass of this pendulum suddenly got increased because the bear picks up the koala bear, right? So this was m here. Assume that it is going from here to here, and this m suddenly increased to some value m dash. So in other words, m dash is now greater than m, because at this point that that guy picks him up. So they are saying, how will the period change? A lot of fancy stories and all, but remember guys, the period of simple pendulum is 2 pi root L over g. Does it have anything to do with the mass of the object? No. So the period stays the same. Definitely period stays the same. And it should be option C, because the period stays the same because the mass of the simple pendulum does not affect the period, not because the conservation of momentum or anything. That has nothing to do with it. So the answer is option C. All right. Which of the following mass spring combination have the greatest period of oscillation? Assume all the springs and masses are identical. All right. Okay, that's pretty fancy stuff here. We are given springs in series, parallel, and all those things. So mass is same, so that at least gives us some advantage, because time period is given by 2 pi root m over k, and the mass is same, which means that for the greatest period, we are looking for the smallest k, because k is in the denominator. So obviously the the smallest value of k would mean that I can ignore the parallel stuff, because parallel stuff always increases the period. For example, this is k, effective is 2k. I don't want that. This is even worse, effective is 3k. This is just k because that's just a single spring. What I want is maximum springs in series, because if this is k and this is k, and we already learned earlier that the formula is 1 over k effective is 1 over k plus 1 over k. So here in this case, k effective will come out as k over 2, but in this case it will come out as k over 3, and that's what I'm looking for. K over 3 is the smallest of all 5 here, and the smallest is something that I need, because if k is the smallest, then period will be greatest, so it has to be option C as our answer. All right. A block of mass m is attached to a spring of spring constant k in all three configurations. In figures 1 and 3, the surface is frictionless. So 2 is also, 2 also does not really have any air resistance, just so you know. So there is no air resistance or friction anywhere. The ranking of the three frequencies of oscillation, guys, this is just a very classic trap. It doesn't really matter whether the spring is horizontal or vertical or oblique at some angle on an inclined plane. If there is no air resistance and there's no friction, the period is going to remain same, which is 2 pi square root m over k. I'm not going in the derivation. It's mostly not required for physics C. I'm pretty sure you guys have learned the derivation of this middle one. That's a traditional thing that they follow in school. Almost the same thing that we follow on the inclined plane as well. But yes, the result is the period is going to be same. So it's option E. Right, the figure shows a uniform rod of length this, mass this, suspended from a pivot at a distance of d 0.25 meter above the center of mass. Then the moment of inertia of a rod about an axis through its center of mass is given by this. Then what is the angular frequency of for small oscillations? Okay, this is a physical pendulum, and for a physical pendulum, the period is given by 2 pi square root I over m g d, right? Remember, I is the moment of inertia about this point, about which it is, performing the simple harmonic motion, while center is somewhere over here. And we don't really know the moment of inertia about this yet, because they have only given us about the center. And d is the distance between the pivot and the center of mass. So we are given that suspended from a pivot at a distance of 0.25 from the center of mass. So this guy is 0.25. Right, so we are given D. Now only challenge is how to find I. So recall rotation. This is the parallel axis theorem. So I around this axis is I center of mass plus md square. I center of mass is 1/12 ml square, so 1/12 ml square plus md square. Let's sub in the numbers here. Length is 2 kilometers. Sorry, the mass is 2 kilograms. The length is 1 meters. Mass is again 2 kilograms. D is 0.25 meters. If I simplify this, I get 0.2917. That is the I towards this axis. Let's sub in all the numbers over here. So the answer will be 2 pi square root of 0.2917. Sorry, 2917. That is not 2917. This is 2917 over mass of the rod is 2 kilograms. Gravity, let's take it 9.8. And D is 0.25. Yeah, 0.25. Let's sub in these numbers. So the number that I'm getting is coming as 1.53 seconds. That is the period of this physical pendulum, which looks like option C. Yeah, that is the best option. Right. Over here, the mass in the figure slides across on a frictionless surface. Mass is this, K1 is this, K2 is this. What is the frequency of oscillation? We can find T and then we can find frequency. Remember, guys, this is a very popular connection, which is also in parallel. This connection is treated as parallel because think about it like this. If I push it right by 1 meter, it means that this stretches by 1 meter and this is compressed by 1 meter, and that's exactly in a way the property of parallel springs, because of course in those parallel things they will stretch or compress together, but the idea is by the same amount, right? Here, yes, one is stretched, one is compressed, but it is still with the same value. So these are in parallel. In parallel, the effective spring constant is pretty straightforward. We just add both of these. So if we add both these guys, what do we get? 1000 plus 500 is 1500, right? So this is 1500 Newton per meter. The period is given by 2 pi square root m over k effective. Mass is just 2, k effective is 1500. So period from here comes out as 0.229 0.294 seconds. But they are interested in frequency of the oscillation. So frequency is just the reciprocal of time. These are buddies. So frequency is 1 over t, and 1 over this guy will come somewhere around, I think 4 point something, right? Yeah, 4.36 around. So they are saying approximately, I think. Yeah, approximately. So yeah, approximation should be option C. Okay. The torsional pendulum consists of a solid disc, 2 kilogram, 1 meter, suspended by a wire attached to a rigid support. The body oscillates about the support wire. If the torsional constant is this, what is the angular frequency in radian per second? The moment of inertia of the disc about an axis through its center is 1/2 mr square. Okay, this is pretty straightforward, just about memorizing the formula. So for torsional pendulum, omega is given by omega, which is the angular frequency, is given by root of I over, I'm sorry, not I, K over I, where K is the torsion constant and I is the moment of inertia. So everything is given to us, almost. I is 1/2 mr square. What is m? That's 2 kilogram. What is radius? That's 1. So 1/2 times 2 is 1. And 1 times 1 square is also 1. So moment of inertia is just 1. So omega comes out as square root of k, which is 16 over 1. And square root of 16 is 4. So in radian per second, omega comes out as 4, which is option B. Okay. The next one is there are two identical massless springs that are hung from a horizontal support. The mass is 1.2 kilograms, suspended, Block is in equilibrium. Each spring is stretched an additional 0.15 meters. Okay, so it is just stretched by 0.15 meters before coming to equilibrium. Now, when the block is set into oscillation with amplitude, some amplitude A, it passes through its equilibrium with a speed of v. So they are not saying it is maximum, but we should know that at the equilibrium position, this speed is maximum. Now, which of the following cases will the block, when oscillating with the same amplitude, will have a speed less than v when it passes through its equilibrium position? So in equilibrium position, again, they are saying that in which of the following cases the maximum speed is less than the earlier maximum speed. Okay, so V max is given by A omega, and A remains same, by the way, and omega is given by square root of K over M, or K effective over M, right? Right now, so if I want to decrease this V max, let's see the options here. We have three options. Okay, sorry, we have three situations and then a couple of options. The block is hung from only one of the two springs? I think yes, because right now if this is K and this is K, K effective is 2K. But if it is hung only from one spring constant, the spring constant will decrease, right? Because it will now become just K. And if K effective decreases, V max decreases, and definitely that's what I want. So 1 is correct. The block is hung from the same two springs, but the springs are connected in series. Yes, of course, that will definitely work, because if the springs are now connected in series and they are identical, it doesn't really matter whether they are identical or not, but in this case they are. But when they are connected in series, the spring constant decreases, and in this case precisely it will become half. So from 2K it will become K over 2. So obviously it decreases by 1/4 to be precise, but it decreases. That's what I want. So again, K effective decreases, so V max will again decrease. So yes. A 0.5 kilogram mass is attached to the block. Yes, of course, it will work, because in this case, I'm increasing mass. So if the mass increases, obviously this ratio is going to come down again, and that's what I want, right? V max should decrease. So yes, 3 will also work. So answer is option E, 1, 2, and 3. That was a pretty good question. Okay. All right, a mass is oscillating on a frictionless horizontal surface in SHM. When does the mass have the maximum possible acceleration? Okay, this is something that we should know, that it doesn't really matter whether that's horizontal or vertical, but since it is given that it is horizontal in this case, This is the equilibrium position. This is right extrema. This is left extrema. Remember that at the equilibrium position, its V is maximum and A is 0. While at the extrema is V is 0, while A is maximum. Because it is changing the velocity at that point. Velocity is going from right to left, it's kind of changing the direction. So that's why, or you can think about it like A max, because the force is maximum here, kx, the x is maximum, so that's why A is maximum. Now they're saying maximum possible acceleration. Obviously, at this position, they are saying that when the kinetic energy is maximum. Obviously not, because kinetic energy is not maximum at this point. The kinetic energy is actually 0, because when A is max, V is 0. When the displacement is minimum, no, on the contrary, displacement is maximum, because this is the maximum, these are the maximum values of x. When the mass is moving at the maximum speed, again no, because at these positions, V is 0. The mass is not moving. When the displacement of the mass is 1/2, absolutely not. It should be equal to the amplitude. But when the potential energy is maximum, yes, because potential energy depends on half kx square. Obviously, there is no change of height, so there is no gravity involved. Half kx square, k is constant, x is maximum at either extremas, and that's where acceleration is also maximum. So B definitely checks out. All right. In an experiment with simple pendulum, the measurements of the period t are made with different values of length. When plotted on the graph, which of the following should result in a straight line? Okay, t is given by 2 pi square root L over g. The variables here are t and L, so we know that t is equal to some constant m times square root of L. So if you want t and L, or some t and some L, to behave as a linear function, you should take y as period and x as square root of L. That is not in the options anywhere, which is totally fine. There is another way in which you can linearize this thing. Let's square both the sides. So t square will be equal to some m square. If you're confused about this m, I can make it k, because that's just a constant after all. So some k over here square times L. Well, k square is also a constant, so again it is replaced by probably some constant c times L, which is also a linear function if I take t square as the y coordinate and L as the x coordinate, which is fortunately in the options. It is D. These type of questions are asked in FRQs, guys, so be advised. They ask you to graph it, how to make a linear graph and all. So that's how we can do it. Both are correct, t versus square root of L and t square versus L. But in this case, to respect the options, it should be option D. Right? A small sphere of mass m at the end of a light spring L. The sphere is pulled back a small distance and released. The sphere springs with a period of the motion t. The process is repeated with the sphere 2m and the light string of length 4l. The new period will be. Remember, this is a pendulum, and pendulum does not depend on the mass. It's just 2 pi root L over g. So t is proportional to square root of L, and they are saying if the length is now 4 times, the new period, let's call it t2, is going to be proportional to square root of 4l, which means that t2 is proportional to square root of 4 is 2 root L. And if we divide these two, then t1 over t2 will be equal to square root of L over 2 square root of L, which means that t1 over t2 is 1 over 2. I hope you understand that when proportionalities are divided, the proportionality is gone. It just turns into an equal to sign. This is more math. Cross multiply 2t1 is equal to t2. Flip the omelet, which means that the new period t2 is 2 times of the old period, which has to be option B. Okay, the last one that we have is talks about energy, guys. A 1.2 kilogram mass attached to a spring executes SHM on a horizontal frictionless surface according to this equation, where x is in meters, t is in seconds. What is the total mechanical energy of this system? You should memorize this formula, guys, in case you haven't already. Total mechanical energy in case of spring, whether that's horizontal spring, mass combination, or vertical, is given by half k a square, where k is the spring constant that we do not know, and a is the amplitude, which is 0.5. Okay, let's make some efforts to find the value of k. We know that this is omega, so 6 is equal to root of k over m. M is given by 1.2. Okay, so let's square both the sides. This means that 36 is equal to k over 1.2. Let's multiply both sides with 1.2, cross multiplication. So 36 times 1.2 is k. So k comes out as 43.2. 43.2. And this is what I'm going to plug in over here, 43.2. Let's multiply all these people to get 5.4 joules. So that is the total mechanical energy, which is always going to be conserved because there is no loss as it is frictionless, no air resistance and all that stuff. Part B is asking when the displacement is 0.3, what is the potential energy stored in the spring? That's pretty straightforward. Potential energy stored in the spring will be half k x naught square. K we just found as 43.2. So this is 43.2 multiplied by x naught, which is of course 0.3. So 0.3 square, which is 1.944 joules. The best choice, I think, would be option B over here. And when the displacement is once again 0.3, they're asking what is the kinetic energy. So kinetic energy is given by the total mechanical energy, which is going to remain constant, minus potential energy. So total mechanical energy is 5.4 and the potential energy is 1.944 or just 1.94. So this comes out as 3.46 joules should be the kinetic energy, which is option D.